Hello. 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 Good. Nah, there's nothing good about mornings. How about just hello, everyone? Yeah. We have a small problem here, and we're absolutely going to have to, throw a bit of shade Timon's way when he wakes up and gets into the building. So we are switching around talks. Matis will be doing his talk first. So yeah, make sure Timon knows that he did wrong. You can do that for me, right? Wow. Third day of DConf energy. Look at this. All right. Well, while we're setting up, Robert, how you been enjoying the conference?
Very well.
Just very well. That might be the most German answer you could have given this morning. Thanks, Robert. Yeah, well, he gave me a few more words after that. Leith, how you doing, mate?
Very good, thank you. It's really been inspiring. I was speaking to Manu earlier. It's rare that you get kind of see intellectual level, but the enthusiasm, people doing really interesting things, at a very deep level across all these different areas.
Cool. Yeah, that was a bit of a wake-up talk. Thank you. How you doing there, Philip?
I'm doing good.
Another German answer.
Yeah, no.
Not even German.
Oh, it's been really amazing being here. It's my second year, and it's a lot of the same people, and it's so fun to see everyone again and hear about what everyone is doing, and yeah, it's been really good until now.
See, thanks, Timon. Manu, you've broken your triannual attendance rule.
Yeah, I know. What happened there?
Well, you booked a ticket.
Did I?
Well, I don't know. Did somebody else book your ticket?
I don't know. We had a big win with Walter this morning, though. And
what are we winning on today?
I think there might be motion on move semantics.
Hey, that's a good thing. Geez, are we set up yet? I think we're set up yet. I should just stop talking. Hey, Matis, you're a regular here.
Hey, I found another excuse to come here.
Well,
Notice, but I'm good. Sound?
Yeah, let's do the round of applause and kick it off.
All right. Right, so let's talk about Dustmite. First of all, the talk for this is a Markdown file. After the talk, I'm going to share a link for it in chat. Yeah, don't worry about it. So Dustmite is a tool that ships with a DMD distribution. So if you have DMD on your computer, you already have Dustmite. It's written by Cybershadow, who should very much be proud of it because it is immensely useful if you're doing bug reports. So basically, this is a reducer. And what a reducer is a thing that takes your gigantic program that just unfathomably hit a DMD bug, which of course never happens, but just in case, and turns it into a very small, very adorable, very readable error that you still don't understand. So how does this work? A reducer is basically a program that takes two things. It has a test folder and it has a reproduction script, called a tester in this case. What the tester does is it demonstrates the presence of the bug, or it tests for the presence of the bug. In other words, the tester can be anything. It can be an executable, it can be a D program, it can be a bash script, a bat file if you're Windows using Weirdo, who I'm not going to be focusing on in this talk, so if some of the shell commands that I give don't make any sense, just ask an AI to translate it into PowerShell for you. They're really good at that. Then just run it blindly, don't worry, it's going to be fine. Dustmite will actually tell you if you've made a mistake in the repo script, so that should be good. So I'm just going to walk you through the basic steps of how to use this. It's going to be a bit awkward because I usually read that off my screen, but right now I have to look at the wrong screen because the setup is a bit slapdash. Don't worry about it. OK, so you have some project, and the project has developed an issue. So what you want to do is you make a separate clean folder for your reproduction run. Then you copy your entire project into that folder, and you call that project 1 or source 1, or something ending in 1. Then, this is actually important, in the repro folder, you make your reproduction script, which I'm going to call repro1.shell, again, or .bat, whatever. This is going to be run from within the project folder, but it must be placed outside the reproduction folder. I'm going to explain that in a moment. It has to be executable. Now you can run Dustmite. Dustmite has a very simple syntax. It's Dustmite, source folder, repro folder. This will probably fail. This says it's going to create source folder.reduce. That's not true. It's going to give you an error. The error is probably going to be that you left some binaries in there. Dustmite doesn't like binaries because it has to keep everything in memory. So you have two options at this point. You can either clean up your binaries and just do a pure source run, or you can do what everybody does and just pass the force parameter and say, yeah, OK, you're going to have some difficulty with this. I don't care. I have 32 gigabytes of RAM. Go for it. So that's going to be fine. So Dustmite is going to run, and it's going to run for a very long time. DMD is not exactly a super fast compiler, especially if you're using templates, and it's going to have to do like 10,000, 100,000 DMD runs. So at this point, you want to take a coffee break, and then take another coffee break, and then go home for an extended weekend. So you're getting this folder out source 1 reduced. I want you to not even look at that folder. I want you to immediately take this folder and make a copy of it called source 2. There's a reason for it. That source 1 reduced folder is holy. You have to keep it holy, like the Sabbath, because also like the Sabbath, it may have taken you 7 days to get there. Don't touch it, don't even look at it, don't make any changes. There's a reason for that. And I will get to it in a second. But just to summarize, we're ending up with this folder structure. Right, and now the actual explanation. It is very easy to say, like, OK, I'm just going to take a look at the reduced folder. I'm just going to see what the actual issue was. Oh, I understand it now. I understand perfectly what the compiler is. No, you don't. I'm going to just make some fixes here. They're not going to break anything. They're just going to make the actual issue easier to see. No, they're not. They're going to make the actual issue disappear. And then you've already clicked save, and you've already closed your editor, and now 7 days of work is down the drain. Make a goddamn copy. All right. So that's actually it. That's how Dustmite work. You can go home now. We can do a very deserved OK, no, there's a bunch of more details. It's to understand how to get the most use out of Dustmite, it's important to have a model for what Dustmite actually does internally. So from Dustmite's perspective, what it does is it gets given this folder. And what it does is it reads it into a tree internally. Like every subfolder becomes a tree element, then every source file becomes a tree element. And don't worry about taking screenshots of this. Once again, I'm going to give you the markdown file later. Every file becomes a tree element, and then inside of that, every deconstruct becomes a D element. Every function becomes a tree element. Every statement in that function, every parameter, every node of an arithmetic expression, and all of that gets read into this giant tree that's just in memory. And now Dustmite tries to do, in a loop, again, this. It does a reduction operation. Like it takes one element from this tree, like one file, and it's like, OK, maybe I can delete this. Maybe I can just drop it from the tree. I make a new tree with that element removed. I write it out into a test folder. And then I run the reproduction script against that test folder. And the reproduction script is going to tell me if the bug is still present. And if yes, I'm just going to say, OK, great. I'm going to look around that area in the tree a bit more. Maybe I can remove the next file, and the next file, and the next file. And it keeps going like that. And once it can't find anything more in that area, it tries to recurse. It tries to go deeper. Maybe I can remove this leaf of an arithmetic tree. Maybe I can remove this parameter entirely. Maybe I can remove this function parameter. Maybe I can remove this template parameter. And 90% of the time, it's just going to immediately fail. But those 10% of the time, it's going to keep digging. It's going to keep digging deeper and deeper until it gets stumped by something and really can't continue. And once it can't continue, it just starts over from the start. And does that in a loop repeatedly, exactly until it gets a full pass through the entire tree without being able to remove anything. And then it writes out the reduced file and exits. So you may notice that this is determined primarily by the quality of the reproduction you get out is determined by the quality of your reproduction script. And there are a lot of issues you're running into here. The first and the easiest issue to run into is, I'm just going to give it the source file, and then I'm going to give it my binary. That's sort of the instinct, or like the DMD command. That's sort of the instinct everyone's probably going to go for, and then they're going to be like, I don't understand how Dustmite works. The key is that Dustmite treats the reproduction script exactly the opposite way around from the way you would think about it. If the reproduction script exits with a success, then there's a bug. If the reproduction script exits with an error, then we have lost the bug. So that's kind of counterintuitive, but it lets you do some cool things. For instance, if you're trying to debug a crash in DMD itself, what you're ending up is a script like this. So you just run the compiler, and if the compiler exits with an error, that's going to kick the script Actually, no, it doesn't kick the script in this case because we didn't say it exit on error. It's just going to keep going, but then it's going to do this test, which is the exit code of the previous command 139, which is the Linux error code for a seg fault. And if it is, then we get a successful exit because that's the last line in the script. And if it isn't, we get an error exit. The key is of that, for instance, compiler errors count as an erroneous exit, and so paradoxically don't confirm the presence of the bug. Like if Dustmite has inserted a syntax error, the bug has gone away. We are no longer seg faulting, so we get an error exit. We get a successful exit only in the presence of a seg fault. So this way, you're going to keep effectively Dustmite on target. Otherwise, it is very easy for Dustmite, if you're looking for an error, then it's very easy for Dustmite to create an error, which is, of course, not the same error that you went in with. And then it's going to reduce everything to that meaningless error. And actually, I've been in situations where I've been filtering for a seg fault, and at the end of the reproduction run, I got another seg fault, which was somewhat surprising, though it really shouldn't have been. You can do the same thing if you go one step further. If your program has a crash with DMD, you run DMD with program output, and again, if DMD gets an error, it just aborts the repro script. And then you run your program. No, actually, in this case, it doesn't. In this case, this actually has a very subtle trap in it, now that I'm looking at it. I'm wondering if someone can tell me what it is. Any takers? Now, once again, what is killing us here is that bash does not exit on error. So if you left the binary for test in your folder, what's going to happen is Dustmite is going to reduce the code in a way where it introduces an error, and then the DMD run is going to fail, but the script isn't going to exit, and it's just going to run the old binary. So you have to be a bit careful there. What that is actually going to do in Dustmite is going to get rid of all the source code, and it's going to be like, all right, I've reduced this bug to one binary, which is not entirely what we wanted. So usually what you would do is you would explicitly test after this DMD run, DMD test, OF test, or exit. Or exit one, actually. Yeah, and then it would work, right. That's the sort of thing you do run into a bunch, but most of the time what happens then is Dustmite gets rid of your source very quickly and you don't waste much time. Right, but these are all still kind of bad repros, because usually we have more information than that, and usually we don't want to just replace a seg fault with another seg fault. So for instance, if you can rewrite your program so that instead of, if you already know where the seg fault is, you just don't know why. You can rewrite your program so that, for instance, it does an assert for the seg fault just before the point where it happens. And now you have an error message. Now you have a specific file and line number. Now you can really drill down. Now you can, for instance, say, I'm going to run my program. If it's successful, I'm going to kick out the reproduction script with exit. I'm going to grab the standard error, and then I'm going to check for the actual error message that I put in. That's starting to be good. Like now, Dustmite runs out of places to go astray. You can do that with DMD error messages as well. Even if they have formatting in it, you just run them through cat, and then you see the exact thing. You can just copy-paste it in the file, in your repro file, and you can test for a specific DMD error at a specific file and line location. There's a problem then, which is that if you're doing that to test for a null, then what Dustmite is going to do is it's going to see the assignment to that variable in the first place, and it's going to be like, yeah, I can optimize that out. That preserves our issue, because then it's still null, and it still would produce a seg fault. Dustmite is not very understanding of the thing that you're specifically looking for. You do have to be careful. One of the ways you can work around that is you can just take the script, the one file where you're actually testing for the bug, and just move it outside of your repro folder, and then just import it with i ... The repro folder isn't like, the script isn't contained to it. It's just a Dustmite mechanic. So you can just move your file out of that, and then Dustmite isn't going to touch it. It's just going to touch everything else. And actually, if you think about it, that is exactly the reason why it was so vital to keep the repro script outside of your source folder. Because otherwise, Dustmite is going to be like, I'm looking for a successful exit of this repo script. And it turns out bash scripts are successful if you delete everything that's in them. And then you have a very, very short reproduction run that ends with not very much in your reduced folder. At this point, an important safety warning if you're on Linux. DMD can get into infinite loops. DMD can get into very funny crashes where it just sits there and it eats up memory, and the first thing first thing you start noticing that you have an issue is that your mouse starts moving sort of slowly. At which point it rapidly becomes too late to do anything about it. And when this happens at 3 a.m., when you've already gone home for the night, it's a bit uncomfortable the next day, partially because you have no idea what happened. So the first thing you want to do is just set ulimit. You just want to run DMD, look at your memory usage, and then say, OK, this took like 8 seconds. I'm going to limit it to 15 seconds, be a bit safe. I'm going to limit the memory usage to 4 gigabytes. That's not going to be enough. Limit the memory usage to 8 gigabytes, 16 gigabytes, whatever, as long as it's less than your free RAM. And you can use it. You can do that with timeout under Windows. I am being told by an AI. I'm also being told there's no replacement for the memory limit thing, so good luck. Maybe use WSL for that. Right, so that's some more things you can do to improve things in the source folder. First of all, you can just run dub in your repro script. You can just run reggae in your repro script. You can run make, whatever. I recommend going down to DMD. The reason I recommend that is because it puts the minimal distance between you and the actual command that leads to the error. And usually, as you're going through, you're at like source 2, source 3, source 4, you're at repro 3, repro 4, you want to make some adjustments. You want to maybe drop a bunch of files from the DMD run and just focus on the ones that actually cause the error if you run them. And that is all a lot easier if you just have the DMD command line in your repro script. Then, being a bit careful, but you should absolutely clean up all the build binaries that, this is specific, that come from resources that are in your repro folder. As I mentioned earlier, you can run into issues where a build step fails and it just uses the binary that's already in there. Dustmite, again, can clear these out for you by noticing that they're being rebuilt anyway, but why take the odds? Like, the first time you start Dustmite, you should already be pretty confident that it's going to get to a satisfying conclusion. And one of the ways you can do that is by rebuilding every binary that is in your folder with manual DMD steps. You can run dub.-v to see the actual DMD calls that it makes and just copy-paste those in. And then you have a situation where all the binaries that you want to test are created during the repro run, and that's the way it should be. An important side note, the source code that is being reduced does not have to be D. Like we noticed earlier, like it will absolutely replace the repro script with an empty file, but you can do it with everything. For instance, if you're importing like a list of modules with J, as is commonly done for unit tests, you can tell it that that's a TXT file or whatever. We treat TXT files as split at line endings or as split at spaces. And then Dustmite will absolutely take that file and be like, this is not a D file, but I know how to reduce this. I can take one line out here, one line out there, and see if it still works. So you can provide that multiple times as a parameter, and you can absolutely reduce anything. Like I'm being told people have reduced C++ with this. It's not D-specific. It just has D advantages. So right, you're in the middle of your first run. Right, this we've already done. Kind of skipped ahead a little. So we have source 1 reduced. And you're looking, and you've copied this to source 2. And you've looked at it, and it looks pretty small, but you wouldn't call it minimal. Like, this is still 200 lines of D. This is still 1,000 lines of D. You're not happy with it. At this point, you're going to have to help Dustmite a bit, because there are steps that Dustmite isn't good at. One of them, for instance, is mutual dependencies. Like you have one function, and it's calling another function with a parameter, and that one is calling the first function again with the same parameter. The reason this doesn't work is that Dustmite always does single steps. So Dustmite tries to take out the parameter in the foo call. Now it gets the syntax errors. Repro doesn't work anymore. It tries to take out the parameter in the bar call. Syntax error. Repro doesn't work anymore. It's semantics error, whatever. Repro doesn't work anymore, and now it's stuck. It can't get rid of them because it can't remove one without the other. But like as a human looking at source 5 and not source 4.reduced, just to emphasize that again, it will be tempting. Looking at source 5, you can now be smart about it, and you can be like, okay, I have a clean folder here, I can experiment. I can just take these parameters out entirely, or I can just replace them with an int parameter that takes 0. I can make this a lot easier. Another one is that if you have a template instantiation, there are several clever things you can do. One of them is that you can, for instance, say, OK, this type doesn't actually seem to matter. I'm going to turn it into an int and see if the error still occurs. I'm just going to take away everything that's specific about my code and see if you can still get the error. Anything here, this is sort of in university, like we were taught that there are formulas for differentiation, and for integration there's one that is called the method of looking real close. And this is very much something that Dustmite profits in this case. So however, the first thing you have to do is you have to look at the reduced source code, maybe rerun your repro command, and absolutely double check that the bug that you have now is the bug that you started out at, because that is not in any way, shape, or form guaranteed. So you just want to be sure of that. Right, this I've also already said. Whoa. All right, now you say your reproduction is good, but you want to go further. So the first thing you can do is like inline libraries. Very often you're now in a situation where there's a crash, even a DMD crash, and the first thing you see on your end is that there's a Phobos instantiation, like typecons nullable, for instance, or we have a parameter that takes this time. Like, and now you can probably file a bug against Phobos, but it's probably not going to be Phobos' fault, because no source code should be able to cause a compiler crash. And pretty much, if you're in safe code, no invocation of Phobos should be able to cause a runtime crash either. So now, this is still DMD's fault. It's just somewhere in source code that we can't see. The next thing we can do is we can just take that source code and just copy it into a repo folder. Like, if you're looking at DAB, I don't know where it is on Windows. I have not even looked it up, I'm sorry. But on Linux, this is in your home folder in .dab packages name version repo. This changes a bit. You may have to look around there. The version should always be correct. The Phobos sources are in your DMD distribution. They're next to the compiler in the source folder. So if you're importing standard typecons and you're seeing a problem with standard typecons, you just grab a copy of typecons.d, move it in your project, rename it, and this is actually important. You have to rename it. The reason why you have to rename it is because of the standard trap, which is to say, Dustmite, from Dustmite's perspective, it takes an input like standard typecons, and it's like, I can remove the typecons. The typecons part doesn't matter. I just have import standard, and it's just a bug in it, which is great from Dustmite's perspective. It's not great from our perspective, because now a reproduction run that took like 1 second or like 300 milliseconds per invocation, for instance, of standard math, now takes like 1.2 seconds because it has to pull in standard regex and standard UTF, big UTF table or whatever they have these days. And so actually you can do that in a shell script. I didn't have that in here yet because I forgot. But you can actually do an inverse grep, like grep-v, import standard any number of spaces semicolon. And this is a very common pattern. You can actually just exclude it outright. You can just, if you see that in your repro, you can just say bap Dustmite on the head, and it's like, no, bad Dustmite, don't do that. But the problem that it actually causes, instead of just making everything slow, is if you kept your module named standard typecons, then it's now basically random which one of the ones you get, the one you're having and the one from Phobos. And if you're hitting the import standard version, it's pretty likely that you're going to get the one from Phobos. And the one that you copied into your source is going to get reduced to 0 lines because it does nothing. So you just rename this module to import typecons or something and change your imports everywhere. Usually, stuff that you copy out of Phobos is going to throw a bunch of syntax errors at you, or semantics errors at you. Don't let that scare you. These files do run if you have them in your project. You just have to aggressively take everything that causes a semantics error and delete it. I'm not kidding. It's usually unit tests, because unit tests are sort of dubiously enabled in Phobos. You just take the unit test and delete it. Or like if it's a function that's throwing an error and it's not a function that's actually used, just delete it. I mean, just throw it out. Like, usually you do that 5 or 6 times, and then your import works, your copied import works again. So then you've made all these changes. You've changed package to public because your module is no longer in standard. You can pretty much mass replace all package with public, all private with public. Again, this doesn't have to be upstreamed. The purpose of this file that you're creating is to be annihilated. It's to be ground down to like one atom of bug. So like, don't worry about anything. Just get it working, get it compiling, and then rerun. Right. Another thing you can do is, this starts to get a bit into inside baseball. You have a template. You have standard typecons, for instance. You have nullable. It's instantiated at one point with int and one point with float. And there's a whole bunch of methods in there that can't be removed. Half of them can't be removed because the int side needs them. Half of them can't be removed because the float side needs them. So what you do is you just take these and you just copy the entire template, And instead of, you just remove the template parameter, just leave it an empty template, and you replace your instantiations with int with nullable underscore int. You replace your instantiations with float with nullable underscore float, and then you run Dustmite again. And that sort of lets it dig down into the specific template much more effectively, because now it's looking at two different things that are only used once. Optimally, if you're doing a reduction, you wanted to have it at a point, if possible, if that doesn't make the bug go away, you wanted to have a point where everything is used exactly once. And that's going to, once again, help Dustmite make things smaller and maybe make it even smaller than it was originally. Maybe one of them gets rid of immediately, because, again, Dustmite is looking for a path through reductions. And sometimes breaking things up like that lets it find a path that it wouldn't at all be able to find otherwise. And yeah, and as mentioned earlier, at this point, that's the part where, honestly, you're going into stuff that is too specific to note in a talk. Like, you want to make some specific magical thing where you just, sometimes it's just reordering two functions and the bug goes away. So then maybe you reorder in another way that makes the bug appear at a much lower level. Like, at that point, you're really down to experimenting around. And this is actually where the fun starts, because at that point, you're really starting to get into all your theories of what the bug was is going to be gone at this point. So now you can look at what the actual issue is, and you can form theories what the actual issue is going to be. And I've had issues where, at the end of it, like, I was left with 3 empty files. I'm not even kidding. There have been wild issues in the compiler. And like, as a user, it's very common to think of bugs in terms of what semantic meaning we impose on the code. For instance, if I get a crash with nullable instantiated with this struct, my instinct is going to be like, okay, something with null maybe. Like, does the null state not work correctly? When from DMD's perspective, it's very probably going to be something like, well, something went wrong with this struct like 100 lines ago, and I've left a cached version of it, and now this chicken has finally come home to roost. Like, it's not going to be anything at the domain level. It's going to be something from the perspective at the compiler, and it can be very fun, like, to try to figure out what that is. And if at this point you figure out that actually 2 iterations ago I went the wrong direction, this isn't actually my bug at all, at that point you understand why we've kept so many copies of the source folder. Also, if your final reproduction includes traits compiles in any form, probably with the struct in the expression, then you can take a drink. You have joined a very populous club of semantics, speculative semantic pass bugs. These are extraordinarily common. Yeah, join the club. And of course, once again, thanks to CyberShadow for its very excellent tool, which has given me many beautiful reductions. And that's it from me.
All right.
Yeah, questions?
Yes, we got one right down the front already.
Yeah, I completely agree. Dustmite is awesome. I went through this exercise, the exact exercise, just recently, and I have one tip to add. I did the reduction, took a good week, and wrote a bug report. And then it turned out that the nightly version, the unstable version, doesn't have the bug. So check the nightly version first.
Yes, very true.
Thanks for your talk. I recognize a lot of these things from my own Dustmite work. I wonder, do you sometimes use the set-e option in Bash? Because when you put it on top of a shell script, you don't have to check for errors. It will quit after one of the commands.
Yes, yes, absolutely. The thing is, the way I've written this talk, I've left it out because if you got rid of all your binaries, then set-e doesn't matter. Because what's going to happen is just the repo run is going to fail, because it's not going to fail with the segfault, it's going to fail with Bash telling you the file doesn't exist. But when you're creating the repro script, it is very beneficial to have the standard magic Bash invocation set -EUXO pipe fail, which basically turns on everything that should have been turned on in Bash 30 years ago.
Yeah, if I can continue, another thing I want to say about C reduction. I've done it to find some import C bugs where I compare DMD and GCC. And on one hand, it's great that in C, everything is order dependent, so you can it's easy to reduce from the end. But one bad thing is that the reduced C code quickly becomes horrible with missing return statements and reading initialized variables. So I also encourage to put on as many warning as error flags as possible to try to keep the C code clean. And one final thing I want to say is that to speed up your things, try to make your invocation as short as possible. If you know it's a front-end bug, you can pass the -o- flag to DMD, so it only does a syntax check. And so when the error disappears, it doesn't generate an executable for no reason.
Yeah, that's very correct. Generally speaking, you want to give Dustmite as narrow a path through your minimization as possible. Like you don't want to have it off chasing reductions that introduce dubious errors and warnings. You want to keep it focused on the bug as tightly as possible, so turning on warnings makes a lot of sense. Another thing, while we're on the topic of speed up, it should be noted, though I forgot to note it in the talk, that Dustmite has a parallel mode. And it should also be noted that if you run Dustmite with 4 parallel build steps, then DMD can run you out of memory 4 times as fast. So be careful about that.
Thank you, Marius.
What?
It may or may not be practical, but just maybe getting about what's realistic. You think that the process of simplifying your code that you can use Dustmite to help you, that's the sort of thing a language model tuned on?
Sorry, that again, please, a bit more into the mic.
So the simplifying your code so Dustmite can be efficient to find the bug, is that something you think you could use synthetic data, train a language model on to kind of just help you do that?
That is a good question, and I don't know. I would be very surprised if large language models help in this case, because I, as a human, have been very often surprised by the things that have come out. And I would...
Not to substitute for Dustmite.
Sorry, say again?
Not to substitute for Dustmite, but to help you simplify your code so that Dustmite can run. Like the template example you gave, that's probably something it could do.
Yeah, you can probably feed this talk into a large language model and just get stuff out from that. The amount of human work involved in doing this, and also the amount of human work that would be involved in setting up a language model to do it for you at 3 a.m. when the first run finishes.
Yeah, it's not very practical on a short run horizon.
If
Not excessively realistic.
yeah.
Think of it in the context of larger dev tools. Moving towards having better.
There's an argument for it, but however, the reason that I'm kind of skeptical is what you're going to notice is after the first run is the run that takes the most time, and usually after like the several day first run, we have things pared down enough that the actual DMD, the actual grinding through the reduction takes like an hour or 2, and then maybe 10 minutes. So. At that point, you might as well use your human thinking time just to stay involved in the process.
Yeah.
Thank you, Matthias. So I just want to add to your great talk. So one tip, if you want to get a little bit more performance, at least in Linux, is to run it on a TMPFS so that you don't waste time on I/O. And that's not, I'm not sure if that's something you can do on Windows, but on Linux, that's an option. I should also mention that dub has a Dustmite command. I haven't tried it, but if your project is like very heavy, it uses dub features, and you could have a look. Let's go to by Zunke, and it uses Dustmite under the hood. It just wraps it up in a nice invocation, so you don't have to extract the DMD command by hand. I also mentioned that the STD trap has been fixed in Dustmite master, and I just need to upstream it to the version that's shipped with DMD.
Beautiful, thank you. Thank you so much. While we added one additional hint, actually, if you're doing, like if you have Dustmite with a lot of binaries in it, which is the point where I/O starts to become a real issue, what you can do is you just run it for an hour or 2, and probably after an hour or 2, it's going to be rid of the binaries, and then you just cancel it and restart it. This is not usually something that's beneficial, but if you have the Dustmite process itself sitting there with like 1 GB of memory, so that it has to write out a gigabyte of debug symbol, including binaries every time. You want it to be able to cut off those parts of the tree, and the easiest way to do that is to just cancel it, and it will have created a partial reduction folder at that point, and then you just take the partial reduction folder and restart from there.
Thanks, good tip. And to add to Leith's question, so the parallel mode of Dustmite does use a predictor, and that predictor directly influences how efficient the parallel mode is. So I think there's something there, but you just have to dig more there.
I was just wondering if it would make sense to kind of use DMD-as-a-library to generate the AST for the code and then try to kind of prune the AST and run semantic and maybe code generation. I know it depends on the case. If that, maybe that might speed things up.
That might be beneficial. I don't know what the state of DMD-as-a-library is to that extent. And well, you're going to always be using the Dustmite with the DMD that it's shipping with, so I don't think there's going to be incompatibilities in that sense, but I think there is maybe an advantage to Dustmite looking primarily at the syntactic level, but I'm not convinced of that. It could be beneficial, worth a try, maybe. Not sure how much.
I can try to answer that question. So the reason why Dustmite doesn't use an existing compiler or deparsing library is that if you have a bug in your compiler, you can no longer reduce bugs in the compiler.
Oh, yeah, very true.
We have any more questions? Yes, down the front.
You explained it using source 1, source 2 as directories. I would expect you would real life, you would do it as Git. Branches, tags. Wouldn't you put the reduced folders, source files into Git? Do you recommend that or not?
Git is actually going to make a problem for you because one of the things that Dustmite is going to tell you is that this .git folder sure has a lot of objects in it.
Okay.
And I don't like those, and I can't do anything with them. So probably the first thing actually you're going to do is just get rid of your Git folder. I don't think anything during the reduction run is going to depend on Git, or maybe I've misunderstood you.
No, I was just trying to, if when you're worried of losing your reduced source code, you would want to put it into version control, right?
You could maybe, if you had the version control outside, you can use that in order to differentiate versions of the reduction. Yeah, you could do that. I'm not sure why you would. If you want to use Git tools, that is something. As long as you keep the Git folder outside of the reproduction folder, that is absolutely something you can do. Just take the reduced folder and copy it back over the original folder and then do a commit on it. If you really want to use Git tools, that's something you can do, but personally I don't exactly see the benefit because by the time I'm looking at the reduced bug, it's usually very far away from the original source.
Okay.
And then after that point, it's small enough that I can just see what changed.
Okay, fair answer.
All right, do we have one more question? Make it a good one. Right, what about an average question? I'm not picky. I think they're done, mate.
Yeah, that's
Give
cool.
it up.
Have a good one.
All right, and in what, what do we want to do it, Mike? 10 minutes, 20 minutes? 20, all right, we can do it in 20 minutes. The talk we were meant to start the day with, he's finally here. I hope it was a good sleep in. like we got about 1 minute. Yeah, about 1 minute. I'll kick it off in a minute. All right, everybody. You all awake? Timon, we awake? Well, he says I don't know. I think that's a sign of life. And we got some, what's going on here? We got a bit more issues? Ah, we're showing. Perfect. Anyway, it's that talk you were waiting for. We should probably make it a quick one so Timon can get back to bed. Yeah. Give it up.
All right, so I made it. Sorry about that. So I decided to one-up Walter and actually do my illustrations like online. So next to like stack lifetimes, there's a heap lifetimes, like GC heap lifetimes that basically are infinite. So I finished my slides now. All right, so what is this talk? I will talk a bit more about my ideas, how to maybe evolve the language. This is still a largely aspirational talk, like most of the times when I'm talking. You may, however, learn something about existing features and the limitations, and if you'd like to contribute to you may find some project here. All right, so why didn't I make it in time today? So this is, I mean, you may think that the issue is that those clocks are too close to the talk. But actually, this is my own Swiss time zone. This is an hour earlier. You may think the issue was that the volume was turned off, but it turns out that no, the volume was at maximum. So it can only be that the problem was that I only set 2 clocks. So next year I will set at least 3. Okay, so if getting up on time is not it, what does qualify me to give this talk? I actually received this important award at this year's PLDI for my contributions to the Rust programming language. If you're asking yourself what my contributions to the Rust programming language were, this is it. So basically, yes, I mean, I told them that this is my only contribution. They said it's an important typo. All right, and other than that, I'm also the lead developer of Silk, which is a quantum programming language, and in quantum programming, you actually have to care a whole lot about value lifetimes, because if your values live too long, your quantum advantage is gone. All right, so, and this is just like foreshadowing of what's to come. Maybe some of the slides will not be finished, because I intended to look them over this morning. Okay, so what is this talk about? Basically, there are locations and there are values. locations are memory locations, or stack locations, they're heap locations, maybe they're like manual C heap locations or GC heap locations, while values are an abstract concept. So a value may be stored in one or more locations. Locations and lifetimes kind of have independent locations and values kind of have independent sorts of lifetimes. You have lifetimes on the stack. Those are nested like this. So those are the lifetimes of variables, right? Whenever you declare a variable, it will be the variable in your function that is alive the longest time. And if you call a function recursively, you will have another nested stack frame that is even smaller, right? Then there's the GC heap. As I said, it has a virtually infinite lifetime. So hopefully, not a lot of your memory actually has infinite lifetime, but the GC abstraction is designed to let you believe that all your GC values have, or all your GC locations have infinite lifetime. And then there's malloc free, where you can do stuff like this. So basically, this is a non-nested lifetime. You can even access your location after it has been freed. And value lifetimes, this is what I'd like to be basically delimited between a constructor and a destructor. And then ideally, you can put your values inside locations, and as long as those locations are alive, you can kind of copy them around, maybe even move them, which will be another topic of this talk. What you shouldn't do is, as we've seen here, have a value whose lifetime is larger than the value of the location it's stored in. In general, value lifetimes may overlap arbitrarily, so they're a bit like the manual lifetimes. Right. So next we talk about copies versus moves. Copies is the default behavior in a lot of languages. It was copied from C, pun not intended. So basically, by default, if you assign a value to another value, you are then able to use both of them. For moves, it's a bit different. So basically, let's say a copy works like this, right? Where you create a new value, and then sometimes later you destroy both of them. For moves, you actually just get rid of the old value, and you only keep the new one. And then, of course, after that, you're not supposed to still use value A. So this is A, and this is B, right? So actually, right now, what this move here will do, so this is a Phobos function, and it is implemented within the language, and what it actually do, or a core function actually, I think given, it moves, it does the move, but then it also reinitializes this variable with the init value. So you're actually kind of allowed to access it, but maybe you don't want to. All right, so let's talk about constructors and destructors. Of course, how they work is you construct a value, then it is live for a while, and then you destruct the value, right? This seems kind of basic. Importantly, as far as I'm aware, nowadays stack variables are always destroyed if they are constructed. However, the previous slide was still aspirational, so actually stack variables can be accessed before being constructed, and it seems I didn't insert the example here. Or maybe it's off screen. But basically, what this was supposed to be about was that you can have some struct with an immutable field. And then you have a constructor. And you have some method foo that actually accesses the pointer p. And in the constructor, you first call foo, and then you initialize p. Yeah. And this works now, and this actually violates immutable because you access a memory location before it has been initialized. And for immutable data, that's actually kind of significant because then you can create pointers that are immutable, yet their value changes. It's a bit similar for destructors. So there's this pan function here. So what this does is it creates a locally nested struct S. And this struct S in its destructor escapes the pointer p, and then it has an immutable constructor that takes an immutable pointer, assigns its own pointer. And of course, what will happen here is if we construct an immutable S, then the unqualified destructor will be called on the value. We escape the pointer as immutable pointer, and so we can actually type pan in safe codes an immutable pointer to a mutable one. Now, the part below is also interesting, but it's unfortunately not showing. What we have here first is we create some immutable pointer, right? Then we type pan it to a mutable pointer. It's typed as an immutable pointer. If we write it, it says 2. Then we assign to the pans variant, we assign 3. And then we print the new value of x. So it's actually a good thing that this is not on here, so I can ask you, who thinks the value that will be printed for x is 2? Who thinks it is 3? That's more people. So actually, what is printed is indeed 2, because DMD knows that this is an immutable value, and of course, they're not changing. But you're able to hint it. So if you see here, I've added an assertion that obviously says that that p is x. So if you add this assertion, which will pass, then the value that will be printed for x is actually 3. Yeah, so this is what's known as undefined behavior, and we don't like it. And another point is you can actually destroy stack variables without constructing them. So who wants to guess what this code will do at runtime? So we have a local struct t. In the destructor, it accesses the local variable x. And then here we have a struct s. It has a field t. It does initialize t, but unfortunately it never gets there because something else happens. Okay, so I just tell you it will just take fault. All right. So let's talk about safety. What does safety mean? Safety means bad things do not happen. It means you get up on time when you're supposed to give a talk. But safety is often qualified. So you say we're safe against this kind of issue. So for example, if you're memory safe, you're not necessarily safe against someone disabling your clock, but it probably helps. Memory safety means that all behavior of a function is defined. And a closely related concept is type safety, which means that well-typed programs are memory safe. Languages like D or even Rust are not type safe, so they're well-typed programs that will corrupt memory. And the common aim that both languages have is conditional type safety. So basically, if certain things are assumed about the programmers, if they do certain things nicely, then the remainder of the program will be type safe. So it's important to note that memory safety is the lowest common denominator notion of safety, so it is required for any kind of safety. Walter has a question. Memory unsafe programs often suffer from remote code execution exploits, so you can cause any behavior you want.
Well, I disagree with your statement that memory safety means all behavior is defined. I think of memory safety as being there's no possibility of memory corruption.
Yes, but I mean there's a difference between undefined behavior and non-deterministic behavior. So basically, what you could do is you could say, if I do not initialize this stack integer, its value will be any value in the valid range of an integer.
That's correct.
What you cannot do is say, if you access a value that was uninitialized, like an uninitialized integer, then the behavior is undefined. That will not be safe, and that is what C does. So I think C and D differ here. So actually, you can create an uninitialized stack integer in safe code.
Yes, you can, but you cannot use it to cause memory corruption.
Yes, exactly.
Okay.
But that does mean it has defined behavior, even though the value is unspecified.
Okay, I understand your point.
Yeah. Thanks. Yeah, it's a bit technical because all those terms have clearly defined meanings, and they're not that intuitive sometimes. All right. So as we saw before, DSafe has some soundness holes. So and this is actually not surprising. So a good rule of thumb is if it is not formally verified, it is probably unsound. If it is formally verified, there is probably a bug in the specification. so your proof is meaningless. If there is no bug in the specification, then there's probably still some other part of your system that is not formally verified, and that is where you're attackable. If your entire system is formally verified, you can still have holes in the formal system itself. So there's still possibility for bugs there. This is one of the reasons why software licenses usually say absolutely no warranty of fitness for any particular purpose, which basically means my software is useless, do not try to use this. And the way that the programmers often cope with this is that they say, well, I just don't write bugs. I mean, this doesn't affect me, therefore, right? But I would say this is, without formal methods, basically delusional for any non-trivial system. So type systems are actually a lightweight form of formal methods, and they are widely deployed. So formally verifying them in turn can be quite consequential. But in practice, they're usually holes. So other type systems are unsound too. I'm not singling out D here. The Rust type system is unsound right now. There are some holes in the Java type system. You can essentially pan any class type to any other class type without the cast. Of course, the way it's translated, the JVM itself will actually do a cast and catch it at runtime. But in practice, this is usually the case, unless you take efforts to formally verify stuff. So I would like to take this opportunity to address common misconceptions about trusted. So a lot of people think trusted means this function is memory unsafe, do not even attempt to check this. But this is not the case. Trusted means this is memory safe, but not checked. So this is actually one of the few keywords indeed that has a name that makes sense. And this memory safety of trusted functions is actually the precondition of this aspired conditional type safety guarantee. So basically, if all your trusted functions are memory safe, then so is everything else that type checks. The precondition is, of course, vigorously satisfied if you do not write any trusted code, or maybe nobody else writes any trusted code that you're using, which probably won't happen as you're still based on the standard C library, usually. I mean, for now, it doesn't happen. Maybe at some point we get there. So therefore, @safe is intended to yield a type-safe subset of the language. So if stuff in safe type checks, it should not corrupt memory. Then let's address @life. So at live does not tie into this conditional type safety guarantee. So basically it does not give additional safety guarantees for code that is already safe. Of course, it may still help you with improving memory safety of a specific piece of system or trusted code. It basically depends on what you're doing. You should consider it, I think, to be a linting tool that is helpful with a specific, quite restrictive way of writing code. This is not really like a Rust borrow checker, even though it technically checks borrows. And it may be a good basis for future type system extensions that do give more conditional type safety guarantees. However, I think we should also consider, is this really the only kind of linting that you want in system and trusted code? And I would imagine that it would make sense to be able to enable the standard safety checks as well in safe and in trusted and system code, and then just disable them surgically. So I think that will also help catching memory safety bugs. All right. The GC variables also have lifetimes, and they're actually kind of interesting. Okay, that's the wrong tab. I think it is. It is here. I found it. All right, so we have this simple program. What this does is it allocates an infinitely long singly linked list. I don't have the right command here, so hold on. I mean, you can take the time to read the code and understand what it does. All right, so I limited the virtual memory that this process will take up so that my machine that is running my presentation doesn't crash. So who thinks this will run out of memory? Attila is feeling courageous. Okay, so that's surprisingly few people because I can now run this. And why did it terminate? That is very confusing. I mean, this wasn't intended to be there at the start anyway. Maybe, yeah, I think I just screwed up the syntax here. All right, so now it actually runs. Before it was just passed as an argument to the ulimit. Okay, so it runs out of memory. So Attila was right, and he was rewarded for his courage. Okay, so now let's not print heads, let's print char instead. So who thinks this will run out of memory? Dennis is feeling courageous. And anyone willing to join him? Nice. Yes, we have quite a few people now. So Attila was a trailblazer last time. He took a risk and succeeded, and so now there's a gold rush. All right, so let's run this. Oh, it ran out of memory. All right. So now let's not use DMD, right? Let's use LDC. Who thinks this will run out of memory? You're very confident about LDC's capabilities. Yeah, it ran out of memory. Right. Okay. So now let's enable optimizations. So who thinks this is run out of memory? Oh, we actually have someone who thinks with optimizations it will still run out of memory. Yeah. Yeah, I mean, technically, maybe Sebastian is right. We don't know. So basically, what may happen is that at some point we allocate a piece of memory that is pointed to by some random garbage on our stack. And at that point, it will run out of memory, but it's quite unlikely to happen on 64 bits. So yeah, who knows? Maybe someday in production, it will just blow up and run out of memory. All right, so that was my attempt to make you feel anxious about GC. So basically, if you don't run out of memory, also try it with optimizations disabled. You may then run out of memory. So basically, the issue here is that garbage collection in general is undecidable. So tracing GC is only an approximate heuristic, because it says data can be deallocated when it is no longer reachable, but in practice, actually data can be deallocated when it will no longer be accessed. And if the optimizer, so this is now how it works in practice, this is not how the language needs to define it necessarily, right? But in practice, the optimizer will be able to remove some variables that are no longer accessed, like that variable elimination. And then you will actually no longer have a pointer, and the tracing GC will not find them, and then we'll be able to deallocate. So therefore, that means that compilers can and do sometimes optimize a program that has a memory leak to one that does not. And such a program might blow up sporadically in a hard-to-explain way if a false pointer appears. So like I told you. But we didn't observe it today. All right, so now let's stop the FUD and talk about the nice things about GC. So in my experience, if I use the GC and if I avoid type qualifiers, then memory safety is very rarely a concern, even if I do not use @safe. So, and if I do not use @safe, the main potential source of unsafety is escaping stack references. And by the way, if I use @safe, still my main concern is escaping stack references. So what are the, okay, Phip?
I think also if you don't use the release flag.
Yes, that is important. I never use the release flag. It should be removed. It should be burned. It should be purged from the Git history. All right. So what are reasons to use @safe? And actually, there are two reasons that I can see, like two main reasons, and they're kind of orthogonal to each other. One of them is you want to have simple code that is obviously safe. And that is quite nice, because then maybe you can actually review code and the compiler may actually be able to ensure safety. And then the other reason is you may kind of need expressiveness. So maybe you're trying to do something that is really error-prone, and you want some assurance that it works. So even if you're drunk and/or tired, and you do not really want to worry about having a week-long debugging frenzy right in front of the release deadline, because apparently sometimes in a hard-to-explain way, your program corrupts memory. So what I think about this is basically that one of those is more interesting. Of course, I'm all about expressive languages, but the other one is both easier and more important for getting taken seriously in practice. Because if you do not get the basics right, then people may think you're not memory safe, even though you're essentially as memory safe as any language that exists. Right? Not exactly any, but like any sufficiently popular one, let's say. Okay, so this is about the simple safety. So are we type safe yet? And the answer is no. We need initialization safety, especially for immutable values. It would also be useful for non-null pointers if you ever add that. It would be good to have fully reliable stack reference detections. Like at the moment, if you slice a static array, that will kind of not be detected if you don't use DIP1000. And if you use DIP1000, you can, because it has some unsoundness as well, you can even get into situations where escaping an array literal gives you memory corruption. So it is not a strict improvement at this point in time. So maybe it may even make sense to promote all stack reference to the heap, not only those existing closures. This is what some languages do, but I don't know. So one thing that I think is here important is a GC that works better both inside and outside of single-threaded batch programs. So I think the GC currently works less well than it could in single-threaded programs because it still takes a global lock. And in multi-threaded programs, it doesn't work because like contention on the GC lock will just turn your multi-threaded program into a single-threaded one, and you will still have the lock overhead. Right? So I think it's really important to have a GC that doesn't suffer from this, and therefore I would like to thank Stephen and Amori for all their work in this direction. It would be good to find some way to deal with in-out. I mean, maybe take it into a shed, shoot it. I mean, that's just one way to deal with in-out. We should fix type checking for qualified delegate contexts. At the moment, I think that just has never been implemented, and it's kind of random how it behaves. We should fix closure allocation in loops. So at the moment, if you allocate the closure in a loop that accesses loop local variables, then you actually have a lifetime unsoundness because it will not allocate one closure per loop iteration, it will allocate a single closure. So one way to deal with this is to disallow this pattern. Another way to deal with this is to actually allocate the closures properly. Then finally, I think it would be good to think about ways to validate DMD against the formally verified implementation of the fully lowered D subset. So for example, we could create a small subset of D that has everything that is not related to metaprogramming, and this is actually not that big. And then maybe we can verify the safety checks on that thing. And then we can generate programs and check that DMD indeed rejects the same set of programs. And we should also fix all the other bugs that do not fit on this slide now. So in terms of expressiveness, are we expressive yet? And I think not really. I mean, DIP1000 has some significant limitations while also being quite confusing, maybe at first. I think it is not extremely complicated if you spend a couple of days with it, but probably you can find a better trade-off, right? So things I think we should explore is move semantics. So this is in DIP140 and also move constructors. Maybe we should have some. I actually forgot what escape checking for non-nested lifetimes was supposed to refer to, but we definitely need this. Yeah, right. At the moment, at the moment, the DIP1000 will only work on stack variables that are basically, I mean, it will work on other variables if you just pretend that they're on the stack, even though there aren't. This is what Dennis did on Tuesday. Or yesterday, I don't remember. I didn't sleep enough. All right. So DIP1000 works in this nested fashion. But I mean, in practice, you may have lifetimes like this, especially if you have memory management. But nothing stops you from doing this, and DIP1000 doesn't really help you all that much in this setting. Then multiple interactions would be nice, because right now DIP1000 basically tells you you're either taking the address of a reference or you're escaping the thing the reference points to, and that's it. Would be good to be able to have interactions beyond that so that you can implement the tree structures in some sort of safe manner, even though you may be using a linear allocator for all the nodes, and you want to use actual pointers. Then another thing that I think is quite kind of crucial is that at the effect system, it doesn't have effect polymorphism, and this is why Dennis had to break the type system. So actually, his GC allocator was no GC. And yeah, I mean, I can't see what's wrong with that, but maybe you can figure it out. So effect polymorphism, what this is basically you have to be able to say this function is no GC if and only if the callback that I'm passing to this function is no GC, or some other thing is no GC, and then. At the moment, I mean, we can kind of do this if we pass the callback as a template, but as I've heard, we're trying to reduce template usage, and I think to reduce template usage, we should really try to explore this sort of parametric polymorphic type system extensions. But I think we should only start doing this once we've verified what exists. Okay, then. We should have attribute inference for recursive functions. This is kind of hard to do efficiently. I have some ideas about how to do in a way that doesn't have efficiency guarantees. Maybe just conditional attributes would be nice so that you can specify yourself, well, this thing is safe if and only if this part of the input is safe. Then you can work around cases where inference just fails. And it would also be good to have better escape analysis in the front end. So maybe I've prepared another. Yeah, right. So okay. So who thinks that this allocates with the GC? Maybe I should show you the compiler options. I don't know how this works. Ah, okay. So this is it. I'm just supposed to have this as well. All right, so I mean, now you can probably see most of the function, and you see, well, no, it doesn't GC allocate. Who thinks I can make this function no GC?
The function of the program.
Like just the function foo. Can I make it no GC?
Foo's not called. Ultimately, it should be removed.
Yeah. Yeah. But I mean, I'm. Well, okay. I mean, so you say, yeah, can make it this no GC.
It has to. I'm saying it probably can't.
Okay. So actually, Mattis was right. I think he was the only one again. I can make this no GC. And yeah, and that will work. All right, so now let's do an equivalence transformation. Int y equals 2. And now instead of 2, we put y here. Who thinks I can make this no GC? No one. Okay, you're right. Okay. I cannot do this, right? It fails compilation. So who thinks this function allocates with the GC? Yeah, I mean, it doesn't. I mean, as you can see here. Yeah, it doesn't, because this is LDC and I've passed the O3 flag. Of course, if I remove the O3 flag, then the story is a bit different. Let's say alloc memory. Here is your closure allocation. But LDC will actually often optimize it out. So just because you cannot make something no GC, it doesn't mean it will use the GC. And therefore, that's what I'm talking about when I say it would be good to have better escape analysis in the front end. So like, it should be possible to use STD range without incurring GC overhead for simple things, even though you're not escaping anything. And I think it would be really good to have no GC exceptions, because in many cases the only reason why focus function is not no GC is because it may throw an exception if you call it with arguments that you shouldn't have. I mean, there is DIP 1008 here, which basically it's a reference counting scheme on top of throwable. I don't know if this is the right approach. Amori had some ideas, I think, where it just says, well, when are you ever going to actually leak an exception? So just delay the GC allocation to the call site and attribute it to the call site. So I think that would also make a lot of sense. And then finally, it would be good to have some way to express ownership, or that some graph of pointers is isolated. Okay, but I mean, we have what we have, and it's actually already quite expressive. So I do not want to discourage you from experimenting with what we have. One indirection is kind of enough for anyone, as Robert showed with his tuple of arrays approach. We have system fields. We can actually implement non-trivial type system features in the library. Not anything that requires polymorphism or dependent typing. It would be nice to have something like that. Then system fields would become even more useful. You can use fake stack references, like Dennis's arena design, where you just act as if your dynamically allocated pages lived on the stack. And that gets you somewhere. And then you can also do runtime checks instead of, or to complement type system features, because range checks are how we took care of buffer overruns. So we have like range checks on array accesses, right? We can also do this for use after free. There is like not much stopping us, except that, of course, for this sort of temporal property, you will need to instrument your program with additional data. So it is a bit more expensive in terms of data, and data is more expensive than compute, so the trade-offs are a bit different. But you can still make your program have a more predictable running time, right? Then with DIP 1000, we can actually use scope pure static callbacks, and kind of have this sort of continuation passing style that again only works with nested things. But this way you can actually prevent things from escaping. So this is an example of what you could do. We could have borrows that are checked at runtime. With this syntax, it's not the nicest one. And I was tired last night and forgot that return is actually a keyword. Yeah, so we can borrow, and then what do we do after that? We cannot return. That will be tricky. But I mean, you can't just do this, right? You can do this today in the existing language. This works. You can just add some flags to the vector, or maybe just some count of how many things have borrowed out. The details are, of course, maybe a bit tricky, but we can do this today, and this will be safe. So now I have like 4 minutes to talk about DIP 1040. So basically, it proposes to move the last use of a variable, and I, again, do not really know why there is no code here, but it is shown here too. So basically, we can move the last use of a variable, and that is fine. So I've disabled the copy constructor here. So if you actually have something that is not the last use, it will call the copy constructor. In this case, it will error out. And I think DIP 1040 is a big step up in the usability of move-only types.
Doing the move in the last use of the variable, that will also make the destructor run earlier. That could have like semantic side effects.
Yes, so it has effects on lifetimes, which means it is unclear how it will interact with DIP 1000, but I guess what it will do in practice is it will just leave behind the old memory location in the init state. And then if things access that, then it's maybe not memory unsafe, but it's still not nice. So it would be nice to be able to check this. But yes, that's what DIP 1040 does, right? I do have some criticism of DIP 1040 as well. So maybe I will actually have more than the 2 minutes it shows me here, because people have been interjecting. So we have actually been taking questions early. So move-only types can support like value type like referential transparency, which means they're efficient mutable updates and no implicit costly duplication. So I think this is quite a nice trade-off. You don't even have to think about how to copy your data without causing aliasing that will trip you up later. And they can behave like resources. So you can actually count, I've given out this many of this value, I've received this many. And D essentially supports some substructural typing via disable of special member functions, or even just via a system private on those special member functions. So in principle, maybe it will be possible to statically ensure that you return, I don't know how to call it, all your borrows, right? Maybe you return to the wrong vector without dependent types. You cannot check that, but you can at least check that it didn't forget to return stuff. And then it would crash at runtime if you're passing it to the wrong vector. So structs in D are always implicitly movable, and without the move constructor, this means structs cannot have internal references. This means C++ interoperability gets tricky, because I think STD string usually has internal references. And so it's good to have move constructors, which is proposed by DIP 1040. What is a bit dangerous about DIP 1040 is that the move constructor implicitly passes by ref, which means it just will not destroy the argument, and the caller will move it, so it will also not destroy the argument. So in this case here, a T is not shown, but the T is basically also a wrapper around a malloc pointer. And it has a copy constructor that just copies the data. And here, if we run this move constructor, we will correctly move X, but we will copy T. And now actually, if we run this code, what will happen is a memory leak, because T will never be destroyed. I mean, other will never be destroyed. So. Other.t, right? So I think destructor elision is very dangerous. In particular, consider this code. For this constructor, the destructor of arg will be called if and only if S and T are different types. So I think we should adapt this, because this might implicitly break resource acquisition initialization. It will cause memory leaks. I think a better approach is to be explicit about destructor elision, and it should only be possible to elide destructors from the module that is defining the type whose destructor is elided. Destructor elision is also useful for unpacking, because you may want to unpack a bigger struct into its components, and then So there are some things that are not addressed by DIP 1040, and yeah, that's it. You can ask questions. I will show this. You can ask questions about this.
I want to refer back to the beginning of your presentation where you talked about the desire to have programs that don't have bugs in them. And I found this to be a common idea among people new to programming, that they can write perfect programs. And the problem is you cannot write perfect programs. They always have bugs in them. And like when I was at Boeing designing airplanes, you cannot design perfect parts either. So what do you do? What you do is you plan for failure. Okay? You never bet your life on a single component or system being perfect. You always have a backup plan in case it fails. And the same goes with software. If you are writing software for something critical and you've decided that your program cannot fail, then you failed as a software engineer. You always must have a backup plan for when your software fails, because as Timon correctly pointed out, every step in the system has potential for failure.
Yeah, so I guess that means we will need a second D frontend.
Well,
I mean, I did
I
try
wouldn't
to start
object to
this,
it.
but the existing frontend stopped compiling my frontend at some point because of the issues that I was trying to address in my frontend. so maybe we can work on that sometime.
Well, it may be a pleasure. I might ask you, all of these complaints you found out about D, I have not heard of them before. Well, some of them I haven't. You've told me about others. But a list of these in Bugzilla would be really, really appreciated.
Yeah, I mean, I think they're mostly in Bugzilla. Maybe some of them are not. But I think really a better approach here is to systematically just ensure that what you have is solid instead of trying to fix holes in an infinite cheese grater.
Well, all I can do is fix problems.
Yeah, exactly. So that's why I think we should adapt the approach to type system soundness, so that we can actually say we validated this using a formal system.
I would like that, and I have no idea how to do that.
Yeah, I do. I don't know if I will have time to do this, but maybe that's an idea for next year's DConf.
Okay, well, I really value your help with this, because that's I have no expertise in type system proofs of any sort. I just have an intuitive grasp of it. That's it. All right.
We should have time for one question, so make it a good one. All right, fine. Make it an average one. Here we go. There's an average question.
Vijay.
Sorry, I don't have a good question, but I do have an average one. This topic of garbage collection and whether things are safe in the event of a throw, when you were talking about that, it made me think a little bit about when you start your program and you have like void main or int main, and then you have like arguments that are on the stack, like the command line arguments. In theory, like if throw new were a special keyword that like specifically allocated to something on the stack, kind of like args is an argument to the main function, or if it was a hidden global variable that it assigned to, could that make it possible to have like garbage or exceptions without having to allocate and avoid a lot of trouble?
I mean, in principle, yes, it's a bit tricky to allocate on the stack if you're going to throw, because the stack could be immediately unwound, so you would have to have some other place to put it. And then also in D, you can actually have an infinite chain of exceptions, so in general, you do need to allocate dynamically. So, I mean, it's a tricky question, but I think what can be done is like have some static buffer that you're using for exceptions before you do dynamic allocation, and you can use other allocation approaches before you resort to GC, and you only resort to GC when you catch an exception and then leak it somewhere else. So another issue for non-GC exceptions, by the way, is that the message of the exception isn't throwable. It is a string, and usually people just, well, they construct a string, and that uses the GC. That's another thing to consider.
All right, and that's that. Thank you, Timon.
Right, thank you. And thanks a lot to Mattis for doing the presentation too early.
Yeah, look, if you need it, we've got a cot set up out back for you, so you can have a little nap. Everybody else, sorry, you can't use the cot, but you can use the facilities downstairs. Back here in 10 minutes for the talk before lunch. It's another garbage collector one. All right, everybody, come back upstairs. You guys down front, well, Timon, we've worked it out. There's a spot right here behind the stage where you do the Ali maneuver where you can have a nap. Nope.
Yeah. And then I'll leave it over to you.
Rattle, 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 rattle.
Oh, we're on?
Rattle, rattle. Oh, rattle's over. All right. One more talk before lunch. It's another garbage collector talk. You already know these guys. It's like their 15th talk so far this conference. So let's just get on with it.
All right, so we're going to talk about garbage collection again. So I hope that it's of interest to you. This time we're going to go over small allocation, garbage collection, various runtime integration issue, this kind of stuff. Also ID for future work that we want to do. Yesterday we focused on large allocation, but actually when we look at the profile, large allocation is like a blip in the performance that we use for it. Most of the heavy duty work is going to be either the mag phase of the garbage collection or small allocations. So that's where like performance constraints are more important. For large allocation, the concern is more, do we accumulate fragmentation over time? So we go over small allocation first. Okay. So in a way similar to allocation class that we use for pages in blocks, we have size classes for small allocation. They work, kind of the same, not exactly the same. That wouldn't be fun otherwise, but mostly the same. So we have, a set of sizes, and as they get bigger, the step between them gets bigger as well. We find that in practice, and many other people have worked on that before us, right? We are inventing nothing here, but we find that doing it that way is a nice balance between what we call internal fragmentation. So it's like, okay, here is the size of the thing I'm trying to allocate, and here is like the size class is bigger than that, so there is some wasted space here. That's internal fragmentation. And external fragmentation is, well, if I had like one size class per size, for every single possible size, many of them would get like 1 or 2 allocation in the program, but we would allocate like a full page to do many of those, and we would waste a lot of space that we don't have demand in the program to fill, and that would be external fragmentation, right? So we have the concept of extend class, which is kind of the same, except it's like the size class plus 1, and 0 indicates that it's a large allocation. Those size classes have all kind of property. We have like a documentation that explain them and what we should expect out of each of them, but we don't want to cover that here. That would be too much material, right? So now small allocation, we group them into slabs, right? And so how do we allocate a slab? Kind of like a large allocation. A slab is going to be 1 pages, 2 pages, 3 pages. It depends on the size class, but like a small number of pages. And we're going to cut the slab into smaller chunks in there, and we are doing small allocation from those small chunks in the slab. The slab is also represented by an extent, just like for large allocation, except some data in the extent are interpreted a bit differently to indicate which slots are used, which slots contain metadata and finalizer, this kind of stuff. Because there is a limited number of bits in there, on smaller size class that have more elements in there, some of the feature we do not support. For example, the smallest size class is going to be 8 bytes, which is like the size of a pointer effectively. But in that one, we can have 512 elements in the page, and the slab is 1 page. And so we don't have enough bits to support finalizers, for instance. But at the same time, the finalizer would use 1 pointer size, to be described in the slot. So it would be good only to allocate the 0 size things with a destructor, which is like a bit suspicious as a use case. But generally, like all the features are not going to be supported for the smaller size classes. And when you need them, then the GC is going to just bump you to the next one that support the feature. All right. We separate the slabs into 2 categories, the one we call dense and the one we call sparse. The criterion is very easy. It's like, are there more than 16 elements in the slab? Why is that? Because if we have less than 16 elements, we have good chances that they all go away at once and that we can free the slab. If we have more than 16 elements, there are good chances that the slab is going to be very long-lived or even immortal, because the probability that all the elements that compose the slab are freed all at the same time without new ones being allocated in there becomes very low. And so we put the dense slabs in their own blocks, right? The blocks that contain dense slab are going to contain only dense slabs. And the sparse one, we put them in the same blocks as we put large allocations, because those are allocations that are likely to go away, and the block is then likely to be freed. All of that is obviously like heuristics that's probably going to have to be tuned as we try with more applications, but it's worked well enough for us. All right. So now I want to introduce the concept of arena and bins. We lied to you slightly yesterday when we presented the patch filler. We said there is like 4,096 on them, but actually there is 4,096 arena, and each of them contains a page filler. And in addition, the arena contains a set of bins for each size class for small allocations. And kind of like the page filler has bins for block, the arena has bins for slabs that are not full. So that subsequent allocation of a given size class, we can go in the right bin, see the heap, and extract slab from them and allocate from there fairly easily. So the arena is going to be chosen based on the CPU you can run on, and yeah, pretty much the locking granularity is going to be on the bin. So if we have even many threads that touch the same arena, if they don't touch the same size class, then they don't run into each other. So that's roughly what it looks like, and look at those colors. Isn't it beautiful? So we have the page filler in small that we saw yesterday. So if you cannot quite read that, it's okay. We'll, just go watch the talk from yesterday, and you're gonna have the same picture in way bigger. But otherwise, in addition, we have this set of bins for each size class that contain a heap of all the slabs that are ready to be allocated from. So the slabs that are not full, and also not empty because they would be freed. All right, so we go back to the page descriptor. We saw the same slide yesterday, but now we have a couple of things in there that makes more sense, right? We have, so first the 6-bit extend class here. So as we've seen, if it's 0, it's a large allocation, and if it's 1 or more, it indicates which size class for slabs you are looking at. And arena index, we told you that, well, it allows us to retrieve the page filler. Really, it allows us to retrieve the arena, as the name indicates, and the page filler is going to be in the arena. The 4-bit index is where this page is, in a slab or in the large allocation. So because it's just 4 bits, we cannot really do anything with that for large allocation because they can be more than 16 pages. But we have no slabs that are bigger than this. So when we are talking small allocation, we can rely on the index to find the beginning of the slab. And that gives us a very nice way to compute the index of any element in the slab from a pointer with just the information that we have in there, which is quite important because we don't want to be chasing a bunch of pointers, for instance, when we free. So to do that, we are pre-computing, a multiplier and a power of 2. It's the good old trick to avoid division. Division, by the way, for people that don't know, division are very, very expensive on modern machines. We are talking sometime up to 80 cycle for a 64-bit division. It's really, really expensive. Short of a memory miss, a memory cache miss is probably one of the most expensive things you can do. It's more expensive than the branch miss prediction, for instance. So what we're going to do, if we start from a pointer, wheeling it down to find the page, the pointer is on. Then we use the index of the page descriptor to find the beginning of the slab. And then, between the difference between the pointer and the slab, we find the offset we are in within the slab. And then with those pre-computed constants, we multiply, we shift, and boom, we have the index that is in there without any kind of division and without fetching a bunch of data around. We can do all of that from the page descriptor, which is quite important because in terms of allocation, this is where we spend 90+% of the time in the GC on doing this kind of stuff. All right, so then we have a thread cache for every single thread. within this, so what we do, like, the arena and the stuff like that, they are shared data structure. Even if they are pair core, there can be some contention in there. And also, they are concerned that you cannot stop the word when you are in the middle of an arena operation because you can hold some logs, but then, the garbage collection process might need to take those logs, and then you end up with a deadlock in your application, right? So there is like overhead costs that are associated into going into like common data structure. So each thread have its own thread cache. There is a thread bin also for each size class in the thread cache, and we allocate in batch from the arena, and then we flush what we have in our cache in batch to the arena, and we store the result in the thread cache, meaning that in the fast pass, really, when we allocate, we go see if there is something in the thread cache. If we didn't mess up things, it's going to be true most of the time. We just read one pointer from them, return it to the application, done, the allocation is finished, right? So we are talking like 3-digit number of cycles to do an allocation on the fast pass. Yeah, so, and when freeing, similar process, we put them back in the cache. When the cache is full, we flush that to the arena. All right, so roughly this is what the thread cache looks like. Notice the beautiful color again. We have an extent map cache. I don't know if I want to dig too much into this, right? It's going to be too long, but essentially it's a way to speed up the reverse lookup from the pointer. And then we have like a series of thread bin for each size class that points into a buffer that is also in the thread cache for locality, and so that we don't have to allocate a new buffer. We don't want to allocate in the GC because we have a recurrence problem here if we do that. And in that buffer, we store pointers that we allocate in batch from the arena and that we retrieve. And then we have what we call thread bin state. It's like more state associated with each bin that we don't use that often. And so we want to put them at the bottom so that as much as possible fits on one page, so that when you allocate on the fast pass, you're just going to touch one page of memory, at least for smaller bins, which is the one that are the most used. All right. So periodically, we're going to call what we say recycle the bin. So once in a while, we're going to look at the bin and run the small maintenance algorithm on them, if you wish. So what happened is that if the bin has been emptied, maybe I should show that first, right? So that corresponds to the thread bin and the thread bin buffer, right? So we have the buffer in which we store pointers that are allocation of a certain size that we are ready to give over to the application. And when the application frees something, the buffer, like the pointer, returns into that buffer as long as there is space. And we keep like a series of pointers from that. Obviously, top and bottom is just like the range in the buffer that we can use for that size class. There is no magic business there. The current one is like where we are. So if we were to free a pointer, it would go there, below. And if we were to allocate a new one, it would take, the bottom one and move the current one up. And the low water mark is the lowest value the current has taken since the last recycling operation. That allows us to track a few things that we use for maintenance. So I'm going to go back to this. So when we recycle a bin, if the low water mark reaches 0, and we also refill the bin since the last recycling process, we know that we are not filling that bin enough. Like there is very high demand for that size class in the application. And so we're going to increase the amount of element we batch from the arena every single time we do that, right? So we avoid like running out of element in the cache and needing more. On the other end, if the low water mark did not reach 0, we know that we allocated too much element in the bin, right? Because since the last recycling, we don't even use all that we have in there. And that means that we're keeping way too many things around and using memory for no good reason. So in that case, we're gonna flush part of the thread cache, and note that next time we need to refill, we're gonna refill a smaller amount. And this way, over time, the thread cache is going to adapt its behavior to the actual demand of your application in terms of different size classes, to try to not retain too much memory that it's not going to use, but try to also improve performance for the size class that you heavily use. This worked very well in practice. We didn't make it up. Like, this whole mechanism exists in geomalloc. We modified it a bit because most of the existing literature about that is about malloc and free, where you have a well-balanced amount of allocation and freeing. But we also want to support the case where people just allocate and never free. So we had to tweak the algorithm a bit, but not that much, and it works well in practice. All right, so we've seen that. As I mentioned, I'm gonna go quickly over that, but on the fast pass, when we allocate, we only touch one page, on the happy pass. It's like, we go in the thread cache, we look at the proper bin that we need. If there is some element in there, we return it, we adjust the current one up, done, like end of story. And just touch one page of memory, just return a couple of thread cycle. When we free, we're gonna touch one page in the extent map to load the page descriptor, and then touch the thread cache to put the pointer back in there, and done as well, right? So it ended up being very, very, sporadic in resources use. It doesn't clutter your TLB entry for GC-related stuff, which means you have more TLB entry for your application. And if the cache is full or empty or whatever, for some reason it cannot fulfill your request, then you go into some smaller path that does more, more expensive stuff. But if we do that well enough, and this is what we see in benchmark, this basically, never happens in a statistical manner. All right, I'm gonna hand it over to Steven for appending and finalizing.
Okay. So, in addition to allocating, we have features in D where we have appendable blocks, meaning that you allocate an array of data and you append to it. It just extends what's actually valid in the block and doesn't have to reallocate that value elsewhere. A lot of you have seen my array article about that. Also, we also have blocks that have, or objects that we allocate that need finalization, or the destructors to be called. So we need to store both things for metadata for both of those things. So we need to store a finalizer, which is essentially a pointer, and a used size. And D-runtime, the way that the D-runtime GC works, is always stores those things in the allocated space. So it has a bit somewhere that says, yes, there's a finalizer, and another bit that says that it's appendable. And if those bits are set, then it has the data stored in the block, and we'll read that when it's needed. This GC stores the data differently based on the size of the allocation. So large allocations are pretty easy. We have this extent record, which is 128 bytes. And if you have a large extent, you don't need most of that, because most of that's used for bits saying whether the slot is allocated or has metadata and stuff like that. But we just have one big segment. So everything can be stored in there. We can put the finalizer, which is just a pointer, and the use size directly in the extent. And you can extend a large extent without having to touch allocated memory. So the extent record itself just says, okay, you need more data, we're going to extend the extent, and we don't have to write some value inside that block. Slabs, however, don't have enough space in the extent because you have all those bits that are needed. So we need 8 bytes to store the finalizer pointer, and we store this inside the allocation at the end. D-runtime does basically the same thing, except I think in certain cases it will store it at the front when it has a large block. But in this case, we always store it at the end. As we said before, 8-byte allocations can't support appending or finalization because you would have to take up the entire allocation just for the pointer. So if you allocate, let's say, an array of 4 bytes and you want to append to it, it's going to reallocate even though it could extend in that block. That's just the way it's going to be. Unused space instead of used space. So in dRuntime, I think I actually wrote this code like in 2008 or something to do the appending and put that stuff in the block, and I store how much data is used. And Amaury came up with a clever way to do this. Instead of storing the used space, you store the unused space. And the benefit of this is the more space you use in the block, the less space you need to store the unused space. So as you get to the end, you only need, it's like I have 1 byte left. Well, you only need 1 byte to say I have 1 byte left. So, and in fact, you can use up the whole block by just removing that, and now it's no longer appendable. So it's pretty clever. And it turns out we can actually store both the finalizer and the appendable unused space in the same spot, because the max allocation size for slabs, remember this is only for slabs. Large allocations just get everything gets put in the extent record. But the largest slab is 14,000 bytes, and that only requires 14 bits for the unused space. We like to use all the bits we can. We have 16 free bits in the finalizer pointer because it only uses 48 bits of address space. So we can stuff the 16 bits at the top, or the upper bits of that pointer. We have to set, we have 14 bits. We have another bit to say whether the finalizer is valid or not. And we have a second bit to say whether we're using 1 byte for the length or 2 bytes for the length. When the finalizer is present, so when we have a finalizer, we're always going to use those last 8 bytes, whether we have, regardless. So you can't append into the finalizer, or else it would overwrite it. So that's going to be the maximum size of the block of the allocation. But if it's not present, then we can go all the way up to the last byte, because as you get larger, that used space gets smaller, and finally you can get rid of it completely. So what this looks like in memory, remember, does everyone know like little endian, big endian differences, right? So in memory, we have the finalizer pointer. The 48 significant bits are little endian, so they're first. They come first. Then at the end, you have the 2 size bytes in big endian form, because we don't know if that first byte is actually used by the allocation, because if you only have 1 byte of free space left, that designates free space left, then that could actually be data from the block. So we have a bit to say whether that's valid and a bit to say whether this is valid. And when you load it into the register, it kind of looks like this. So there's some really funky code in the garbage collector to do like a byte swap and figure out what things do we have present. It's actually really clever. All right, so when we finalize an allocation, the first thing we do is we look up the metadata. And if the metadata is present, either it's in the extent or whatever, and the finalizer is not null, then we pass the finalizer and use size info to a handler function. In the SDC code, the SDC code just calls the function as a pointer, right? So that you pass in a pointer saying, okay, I allocate this, and here's the function pointer of the thing that will deallocate it. And it will store that and then call it when you're done. But dRuntime hook must do something different, because we do everything based on type info. So we're going to get to the, I think, more of the dRuntime integration in a later section. I'm just going to handle this part.
Yeah, so before we go more deeply into the dRuntime integration, we are going to talk quickly about how we do garbage collection, because have you noticed we've been talking to you for like an hour and a half about garbage collector, and we have not said anything about garbage collection, which is, quite a feat. So here we go. the GC right now uses a stop the word, parallel mark, and sweep garbage collection. All those words are important. They mean something. First, during the garbage collection process, we stop all the threads of the application, except the one that triggered the garbage collection, but it's also not doing anything related to your application. It's, orchestrating the garbage collection. So effectively, your program is stopped. Mark and sweep, it's, a two-phase garbage collection process where first we are gonna explore the heap from a set of roots. So the roots are gonna be like the stack of your threads, the global data, and this kind of stuff. And then we track pointer and we mark every single allocation that we find that way. And then we sweep the heap, meaning we go over the whole heap, we look at every single allocation, and the one that doesn't have the mark bit, they are dead, we free them, right? And the word parallel is also important, meaning that this mark phase especially, which is the second thing that is quite important in terms of resources, like the allocating small stuff and mark phase is like literally dominating the profile. So making it parallel helps quite a bit with performance. We're gonna start one thread per CPU core that you have, and all those threads are gonna start marking the heap in parallel. Ready, so let's go into more details over those various steps. The one that was the most tricky to get to work was stopping the word. So to do that, first we had to hijack the pthread create function. So if you link the GC in and you call pthread create, it doesn't call the pthread create from pthread, at least not initially. It calls a function that we defined, and that will do some magic and then forward that to the real pthread create function. Then we use signals, like unique signals. And we use the SIGPOR and XCPU signals. Why? Because those were old signals that were used in the mainframe time and that have not been used for literally decades for their intended purposes. But they've been used by Bohem to do exactly what we're doing. So we pretty much consider that the de facto standard to do that, right? And Bohem is like quite widely used in the C and C++ world. So it's like there is no standard saying you need to do that, but it's a bit the de facto standard in the space. Obviously, we do not want to suspend a thread in the middle of a complex operation. For instance, in the middle of a GC operation, for instance. When it's playing with the thread cache, it's no problem. But when it's starting to go into the arena, the page filler, the region allocator, all of that, we don't want to stop in the middle of this, right? Because we're going to mess with the state of the GC itself from under the feet of the thread, and bad things are going to happen. But also, during thread creation, we don't want to do that because all kind of risk condition can happen. And users may also need to tell the GC, like, do not start my thread during that portion of time, because this is very important to me that this is not interrupted. So we have a mechanism for that, and a lot of complexity come from that, because there used to be a mechanism in the runtime to do that, but when we tried to use it, we figured out that it did not work. And nobody was using it, apparently, right? So nobody noticed that it didn't work. So we got rid of it in the runtime, and we had to implement our own stuff. All right. So in the happy path, when you can suspend the thread, it receives the signal, go into the signal handler. The signal handler sees that, OK, we are in the state with that thread where we can suspend. So it's going to just suspend with SIG suspend. We don't even need to dump the state of the CPU on the stack or whatever, do this kind of magic, because we use, like for people that are familiar with the signal IP, the SI SIGinfo flag, which are going to cause the system to push the state of the machine on stack before calling your signal handler and pass a pointer to you, like pointer to a U context. Anyway, all of that ensures that the state that we need to scan is already on the stack, so we can just suspend. It's fine. But let's go with the buzzy state first. But if the thread is buzzy, meaning like this is what we call the state where you cannot suspend the thread. It's buzzy doing something important. Well, when you enter the buzzy state, you set a flag somewhere in the thread local information. Hey, this thread is buzzy, right? And it's actually a counter, so you can make it buzzy several times and exit several times. So when the signal is received and the thread is in a buzzy state, obviously it won't suspend, but it would set another flag that would say, hey, you know, we requested suspension here, but it's not possible to do right now because the thread is in a busy state. So we're just gonna, you know, remember that and resume execution of the thread right away, right? So that we don't stop, you know, whatever this thread is doing that is so important. And then the thread continues to do its thing, and when it exits the busy state, it checks, hey, you know, is this flag that we are supposed to suspend, has it been raised? And if not, then just resume execution, you know, exit busy state does nothing, fine. But if the state is set, then we push all the state of the CPU on stack, and we call suspend, like suspend, to suspend the state of the thread, right? So we're gonna wait, basically, until we exit the busy state to suspend the thread. All right, so how do we hijack pthread create? That's an interesting one. It's a bit of an explanation here, but it's simplified because, you know, with sanitizer and stuff like that, we had to make that work with that as well. But basically, the idea is like you define pthread create in your library, and because your library is linked in before the system one, then it's got to call your pthread create. But now the problem that you have is like, how do you call the real one? And to do that, we call what's called a trampoline. So a trampoline is going to be a global function pointer that initially point to a function of ours, and that function use DLSym, which is, you know, a library provided by the dynamic linker, to find the real symbol. And once the trampoline finds the real symbol, it's going to replace itself by the real thing, right? So the first time you call the trampoline, it's going to do some symbol resolution and then replace itself by the real guy. And any subsequent call to the trampoline is directly going to call the real pthread function. So that's a way to, like, we don't need to do anything special for initialization. It's, you know, fairly cheap except the first call, and it intercepts like any thread creation, unless you do like syscall to the kernel directly, but then, you know, like, if you do that, you're on your own. All right, mark phase. This is the bulk of the work that the garbage collection process needs to do. Like, everything else is very cheap in comparison to that. So it was quite important to make it parallel. Otherwise, I mean, we can do everything much better than the current GC. If that is not parallel, it doesn't matter, right? we're just much worse. So we're going to create one thread per core in the machine, and those we call worker thread. And then we're going to start to put the root into some work list. And all the threads, they are in the loop where they are, you know, is there some work for me in the work list? If there is, I'm picking it. I started to scan, and, you know, when I'm done with that, I'm going to wait on the work list again. And so we put stuff on the work list. It's like very, you know, very simple. It's a stack with a log, essentially. And when when none of the threads have anything to do anymore, then all the worker thread exit, right? Because it's not because there is nothing in the stack that, you know, there is not something that is going to come later, right? So as long as one thread is still scanning stuff, there might be more stuff coming in the work list. But when all the threads are like, okay, when all the threads are waiting on the work list, effectively this is done and they exit. What does the worker thread do? Well, if the worker doesn't have, the worker has its own work list, right? So there is the worker work list and there is the shared work list, right? And if the worker have nothing on its work list, then it's going to go to the shared one and pick one element on there, right? Each element is going to be a range to scan for pointer, so it's going to do that. And do lookup in the extent map, check that, well, first check that it is in the range, that it could be a hit pointer, because this is very cheap. This is one subtraction, one compare, and we can evict the vast majority of false pointer that way. Then we're gonna do lookup in the extent map to find like what is in there. Is it a slab, a large allocation, or nothing? And then depending on that, you know, we're gonna, if there is something, we're gonna mark it. And then, you know, we're doing something maybe a bit clever, but we find to get like a lot of performance would have that strategy. So if we find some further pointer to scan in there, what do? Well, if our own work list is empty, we just add it to the work list and keep going, right? But if we have item on that work list and what we scan is a large allocation, we're going to put it to the shared work list. And if it's a small one, we are going to add it to the workers' work list. Yeah?
What does it mean to find a pointer? How to distinguish between a couple of bytes and a pointer?
Yeah, so effectively, we're reading the memory, and yeah, something are going to be pointers in there, and something are going to be like random data. So we have a two-step process to recognize what is a pointer. First, we're going to check, we have like, what is the higher possible pointer address in the heap and what is the lower possible address in the heap. And if it's between the two, we consider that it may be a pointer, but if it's outside of that, we eject. And then we do a lookup in the extent map, which is, we presented it yesterday, but yeah, that thing, right? So we do like a two-level lookup in there. And if we find a 0, then there is nothing there, right? It happened to be in the heap, but there is nothing. But if we find something, it's going to be a slab or larger location or something like that, and we are going to consider that this is a pointer to that thing. And that could be a false positive, but what we find by measuring is that it happens a lot on 32-bit system, but on 64-bit system, you don't get that many false positives. Because the address space is just like big enough so that it just doesn't happen as often. Right. Yes. This one. All right, so for small allocation, we put it back on the workers' work list. That allows us to blast through graph of small objects, right? If we don't do that for small objects, we're going to run into a performance problem. But for large one, we give the opportunity to another thread to pick it up and scan it. All right, and obviously, because we have our own work list in the worker, if it gets too big, we flush it to the shared one. And that's how it works. We get like very good fan out of that. It's much better than the current GC. So if there is like, some fan out in your graph of object, we're gonna like destroy the existing implementation. If there is no fan out, then it's gonna be pretty much the same because you are following a linked list effectively. And there is not much we can do, right? It's gonna be loading memory that is the limiting factor. All right, and then we do a sweep phase, very simple. We go over all the arena that are initialized. In those, we go over all the page filler. We go over all the blocks, all the allocation in each blocks. If it's marked, we keep it. If it's not marked, we throw it away, right? And then we go over the block and we purge the page of the block that are unused if there are too many of them, right? Very simple. There's a bit more details in there, but essentially, like sweep phase, very simple. All right, so we're going to go back to the runtime integration with Steven, where you left off.
Okay, so for those who don't know, STC is the compiler that we use to build our GC, and hooking the STC GC from druntime is somewhat complicated for a few reasons. STC GC does not have access to druntime, so I don't even think STC supports classes or anything, right?
It supports classes, yeah.
It does? Okay.
Yeah.
Well, there's a lot of things that STC does not support, and there's no way it would be able to use the type info properly. So we have our own scheme for array metadata and finalizers. So when we first wanted to look at integrating this stuff, I looked at the interface for the GC, and the interface for the GC has a lot of implementation details from the existing druntime GC. So we're doing some stuff differently. You saw how the metadata works. The way it works in druntime is mostly different. So we have our own way of doing it, and druntime has an expectation in the array runtime that the GC is doing certain things, and it's going to use those things to implement array appendability and finalizers, which we are taking over in the GC. So what we need to do is move that functionality from druntime into the druntime GC itself. So it's an abstract piece of functionality. This qalloc function, which is something I think I added actually, I think you were saying, Attila, like you look back, who did this? Oh, it was me. that was added when we did the array runtime back when I created it, and that function basically returns a structure that tells you information about that block that is very specific to the current GC. So we kind of have to deal with that, because if we're going to implement that, we have to replace that thing. There are also odd API functions that were required. I found out there was a function called collect no stack, and when I looked at what it did, it does exactly what it says. It runs a garbage collection without scanning the stack, which seems like a really horrible idea, but it was only ever called from the end, from GC destroyer, or the thing that says, okay, the GC is going away. And the reason I think that was done is because people would make an application, allocate something, and then people were trying out the language. Hey, how come this didn't clean up my block? The GC is not working. It's not cleaning up this block. And it's because some leftover piece of stack data was pointing at it. So I'm assuming that at some point somebody said, well, we'll just not scan the stack at the end of the application, and then those problems will go away. So I decided we shouldn't have this function, because to have a public API where you could just totally destroy all your memory and corrupt it is a bad idea. So we've actually got that removed. And of course, the SEC API is different from DMDs. So for instance, the arguments are passed in reversed order, which is the way that C does it, but apparently DMD has a different API for that. All right, so I'll speed up a little bit here. So in order to accommodate our new way of doing array allocation, I created this interface, this array metadata, that now the GC is going to be responsible for this stuff. So it passes you back this generic struct, which allows it to, when you call these functions, it's actually going to call into the GC and say, okay, do your thing to do the array metadata. And that's all handled now by the D-runtime GC, and then also by the SDC GC in its own way. So now all that functionality that was built into the array runtime is now all in the GC. It should provide a way to eliminate a lot of code. I think eventually we're going to get rid of the file in RT lifetime that does all this. It's not there. It's not done yet, but we'll get there. So removing implementation details from the interface, we have the GC interface accepts type info for a lot of things, for malloc, but really the only things it uses are the precise scanning bitmap that's stored by RT info, which is a template that runs on every type info, and stores basically the bitmap pointer from the compiler, which is kind of crazy that we do that for every type info. But now that we have templates to do all the allocations, we have that information without needing type info, so we can just pass that bitmap directly in. It's only needed for the precise scanner in D-runtime, but it's still needed for the API. We don't use it because we're completely conservative. And the other thing is calling the finalizer from type info. So this piece we still have to do, but at some point I think we might actually still use a template to generate a specialized function that does the deallocation. That might be more effective than using type info. Because I think you said yesterday that one of the bigger things that we're dealing with is just in the glue to call SDC GC is looking up things in type info, because it's just so painful.
So quickly, as we've seen for allocation and freeing of small allocation, which is the vast majority of allocation in practice, we touch one page on allocation, two on the allocation, except we also touch the type info, we touch the static data where the pointer to the GC object is, and then we touch the GC object, and then we touch the virtual, the virtual function table of the GC object, and then we call into our stuff. So we end up touching memory all over the place to then call that function that is super optimized. As a result, this code that doesn't do very much except fetching various data ends up taking half the time.
So eventually we're probably going to get rid of that. deprecate the qalloc function. I don't think we need it anymore, especially if the GC is handling mostly used for the array runtime. And the struct final bit is no longer has to be part of the API because SDC GC is doing it differently, but it's still internally used by druntime to mark, hey, this block has a finalizer in it. Quickly, miscellaneous hook problems. Like I said, the ABI is different, so we have to use external C functions for all our hooks. Yeah, this took a while to figure out, but there's actually a function in GC proxy, if you look it up, that basically says load a function pointer to all the GC registration functions and compare them, and doesn't do anything after that, just so that it could keep a reference to the GC in there. Otherwise, it'll say, hey, I don't know where this function doesn't exist because you're never calling it. We had to do some extra hooks for stopping the world because we needed those features. And obviously, class finalization doesn't fit with the SDC scheme because the finalizer pointer is not stored in the block, it's stored in the class. So I store a finalizer of 1. And that just is a signal that, hey, the finalizer is in the block, so that works out pretty well. All right, future possibilities. We don't have a lot of time to pile on more stuff, so I don't know if you want to quickly go over this. I think
yeah, so we've structured everything so that we can use a strategy that's been pioneered by Bohem, which is essentially like put a write barrier over anything in memory that may contain pointer, do the mark phase concurrently with the program still executing, then stop the word, and redo a mark phase starting from the pieces that were touched by the program during the time you did the first one. And if you do that, everything is already marked pretty much, except for a couple of race conditions. So the second one is very, very quick, and as a result, you can get like a mostly stop the word situation there. You can even like statically bound how much you stop the word because if the second phase takes too long, you can like degrade it into phase 1 and redo a second phase 2 later. So you can like put a hard limit on how much you stop the word. We have designed all the data structure and everything so that we can do that easily. We can do it better than Bohem actually because we split the allocation that contains pointer and the one that do not, but Bohem cannot do. So we have very good hope that this is going to yield interesting result, but it's not going to be in the V1.
And this part is a little controversial, I think, but we are looking at possibly replacing the C allocator with our allocator. So this means you can use C libraries, and they'll also use the GC to allocate. And theoretically, you would no longer have to worry about pinning memory that you pass to a C function because everything is still, the functions are all scanned because we're hooking pthread create, and the data that structures that it might use are all allocated by the GC, so it would be scanned as well. So it's still experimental, and like if you don't turn this on, it segfaults immediately. Or if we do turn this on, it segfaults immediately, so we have to leave it turned off for now, but it does work when you just run SDC.
Yeah, it does work with SDC when you don't have DRuntime, but DRuntime is doing something weird that crashes when we do that.
And a couple of miscellaneous items. This is not exactly ready yet, but there's a couple PRs we got to make for DMD to enable an actual dub package. So you should be able to download a dub package and run this GC as a test. More platforms, Windows and OS X. Do tweaking heuristics and telemetry for tuning would be nice to have. I think as somebody mentioned yesterday. And that's it.
All right, Walter's going first, and then you can go, Attila.
Thank you. The original GC I wrote is, very old, and its major feature is it worked. No, I'm not kidding. Its major feature, it worked, and it was, bug-free. But obviously, a modern GC is needed, and after listening to your presentations, you two are the most qualified people to do this kind of work. And I thank you, and I really appreciate it.
Thank you.
So, if I may rebound on this quickly, a lot of those techniques we didn't came up. We actually like dug into geomalloc and tcmalloc and bohem and memalloc and like everything, you know, that existed in the space. And some of the things they do is documented, but most of the things they do is just in the code, right? So we've been on the reading like a lot of various allocators. Do you know that? So some of the tricks are from us, but like 90% of it, we actually like look at what the big boys are doing and Thank you.
First of all, what Walter said. Secondly, pthread create and everything that you're hijacking in the signals, how does that translate to Windows in any way, shape, or form?
Very good question. So the technique that we use to hijack pthread create, we can use also to hijack the thread creation on Windows. The signal one, like, it's one of those things, there is a very nice API on Windows to suspend threads. So it's actually quite easy to suspend thread on Windows. On Linux or other Unix system, you have to use Signal or some like other mechanism. It's full of race condition. There are like a lot of snakes in there. It's horrible. But, you know, such is life. Sometimes Windows is better.
Yeah, just to mention also that the current druntime uses thread signals to do thread suspension on Linux and also has a mechanism for Windows. So, and bohem also does very similar things.
Cool. And the other thing is the things you were talking about, like deprecating QLoc and blah, blah, blah. Has that been merged already?
No, that's what I'm saying. I need to make these.
Right.
So I've made a complete branch of, or a fork of DMD just to test these things out to get it to the point. And now that I know what needs to happen, I need to go make PRs for the actual runtime.
We've merged a couple of them related to stop the word functionality, to like, you know, not stop certain thread. We needed some modification in the runtime, but yeah, for the array support, we have not started merging.
Looking forward to it.
Howdy. Sorry, I was making a list of questions while you're speaking. So I've got a bunch, so if you'll indulge me.
Let me sit down.
My first question is, what about 32-bit systems?
What?
Do you have anything to say about 32 systems, or is this just that's just a write-off?
Yeah, exactly. That's just like we don't plan to support those.
Yeah,
like, you're gonna have to use the old GC if you want to use those.
Okay, that's a shame. But next one. Can you? So what would actually be really cool and interesting to me is to run the GC as kind of a leak detector. Like if I write software that does explicit memory management, having the GC there to find leaks is pretty cool. How are your data structures compatible with storing metadata and allocations, for instance, like line file references or, you know, alloc frequency references and things that might come from like debug info injection?
Yeah, so right now we don't do that. I don't know what would it take to do for small allocation. We probably would have to reserve another pointer for small allocation to store this kind of information. For large allocation, it wouldn't be a problem at all to do. We have plenty of bits here and there to reuse to do that. That's an interesting idea, though. I would be careful about using that because you're going to have some false positives in there, right? It's not going to be a perfect oracle, but I know people use bohem in that way and find value of it, so that's yeah.
Yeah, it's a handy tool. It's probably worth thinking about just making sure that's possible. You mentioned having thread pools and things like that. I don't think I've ever worked on a project where I don't have a set of like a thread pool with a bunch of workers that are as many as there are threads on the system. Could you conceive of an API to allow your work to run on my 3 existing thread pool rather than having a whole nother separate thread pool?
No, and there are reasons for that. The reason is like the C runtime is doing funky stuff when starting and stopping the thread with memory that might be allocated on the GC actually if we use malloc and free. So we need to like start and stop those threads in a very, very specific manner or everything explodes spectacularly. So yeah, that doesn't sound realistic to hook that into a third-party thread pool.
Okay. One more. I think I was trying to follow along at one point. You were describing, doing array concatenation and expanding arrays and stuff. Was it to say, there's like a long answer here, I'm sure, but short answer, is the allocation layout optimized to expand, to like improve the probability of a successful expansion? Like, are you filling memory in a sort of a linear fashion, or are you filling it in a scattered fashion so that an array expansion might not need to move when it reallocs?
So there is a feature in the existing GC and the new GC to take a large allocation and say, I want to just keep extending into further pages.
Yep.
And we are going to allow that for large allocations. For slabs, you can't concatenate two slabs together, slab slots. So you'll have to reallocate at that point.
Okay, and I was also going to want to ask about Windows, but Attila beat me to it. Cheers, thanks guys.
Do you recognize thread local storage, or is it one big heap, or how does it work when you have a thread? Can you? Because
No, I get it. It's one big heap, and the reason is if we want to eject malloc free and get the application going, we're not gonna have the information as to whether the memory that is allocated is shared or thread local, right? So you end up not being able to separate thread local heaps. Though in practice, because the worker recurs on small allocation on its own work list, it tends to even though there is no explicit specification, it tends to create a situation where each worker, scan its own subgraph or object that's going to correspond to your application thread.
Yeah, if you think about you create a data structure with a bunch of nodes, you're just going to allocate a bunch of these things in the same page, right? So this one points to that one. I look at that, it's in the same page. It's going to take no time at all to scan through all those things.
That's really a dumb question, maybe it's fine. If you have a statically linked executable, the Golang style, how does the DLSym work for pthread create?
Oh, the what works?
If you have a statically linked executable.
How does the DLSym for pthread create?
DLSym?
How does that work okay, or does that?
It looks, so DLSym will look up your symbol as linked. So if it's even though it's statically linked, it works fine. Yeah, it's statically linked, but it still is linked to the pthread shared.
Yeah, so in the case of pthread, it's always a shared library. And there is even a .a, like if you look on most Linux distro, there is a .a that appears to be a static object that you can statically link, but actually that's a linker script that dynamically linked the one from the system. They are quite smart. And the reason is the implementation in pthread is like heavily system dependent, right? So if you were to statically link a pthread version, you share the executable to another person with another computer, it's not gonna work properly.
Cool, thank you.
All right, I think we're going to cut off the questions there because it's about midday. So I'm sure you guys can harass these guys downstairs if you have anything else to ask. But until then, round of applause. Before we all run off to lunch, just a couple of things. First of all, we have the T-shirt giveaway going on, as in we're literally just giving away the T-shirts. You see the table outside where you got your shirt earlier? You want another one? You want another 5? Whatever. We're giving them away. Go get them. The other thing is, after lunch, we have the lightning talks. If you have a lightning talk signed up, and you know you do because you asked Mike for a slot, we'd like you up here at about 1:15 so that we can start arranging that. I'm going to hijack the stage at 1:25, in fact, so I can sneak in my own lightning talk. So eat, be merry, and then be back here for that. we'll get the next speaker set up. And oh, hello, I'm live. Can we get the second headset up here, please? Let me. Perfect. All right, I think we're all done with testing. Yeah, let's plug me up. Plug me up. Cool. Yeah, we'll get the next speaker wired up. All right, we're good to go. All right. Let's go. We back from lunch? Mike, are you on the mic? Let's get some volume on Mike's mic for a second.
Hello, hello, howdy. Okay.
Hello, hello, hello. Yeah, I'm hijacking the conference for 5 minutes before we get into the lightning talks proper. Should we explain how the lightning talks work before I start? Go for it. You don't want to do it? You've got the mic.
All right, each talk is 5 minutes. Each speaker has exactly 5 minutes. If they are not finished in 5 minutes, they get gonged off the stage. Yes. And so I've got gong duty while Ethan is speaking, so
cool.
Go for it.
I haven't done a talk in a while, so I'm going to try and race through this in 5 minutes. Let's get the screen up, please. We're good? We're good. Yes, the return of the revenge of the tales of the performance training branch instructions, blah, 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 blah. You can all read that. I have a tale about branch predictors that's going to make you scream. So I've had an incredibly busy year. You know, this has been my side hustle for the last year. I have now become an official part of Doom and Doom 2, specifically my multi-threaded renderer. It is still a pure software renderer. It's also not the first time that that software renderer has been released in a commercial product. That would be my last year's side hustle, Rise of the Triad, a game from 1994, which also used John Carmack's rendering code. And just to give you a bit of an idea of what it is, here we go. Woo, yeah, that looks like a bit of an old school game. So, now we did have a bit of a small problem here, though. See, these floors here, this is actually not Carmack's original code running. I completely rewrote the floor renderer for a number of reasons. And we started getting reports from users that the PlayStation 4 was incredibly inconsistent in terms of performance. And I'm like, why would just the PlayStation 4 be a problem? Like, it's basically the same CPU that's in the Xbox One. It shouldn't be a problem. And we can't just ignore the PlayStation 4 as much as we would like to. It's an 11-year-old system that's still used about as much as a PlayStation 5 is today. Look at that graph. That's insane. Nobody's upgrading to the PlayStation 5, basically. So I asked some people, I don't have access to the Sony hardware to profile this because I'm a Microsoft employee. Can somebody please run the profiler over it? And they came back saying that this little function here was taking up all the time in the renderer. And this is basically a little templated function so that I can generate really, really optimized floor rendering for different texture sizes, different functionalities and all that. And it does that by unrolling a loop. And using this little sampler sample here, that's a templated argument, and it'll just go off, 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 off. Unroll the loop. Cool. And it didn't make any sense to me as to why this code would be weird. That's the code that gets inlined, right? So I'm just like, okay, I need to see the disassembly of this. And somebody gave me the disassembly, and then I worked out, PlayStation's a clean compiler. Same output on PC, in fact. So if I come over here, stick a little breakpoint in it, go to disassembly, And I'm just thinking, please don't be what I think it is. Please don't be what I think it is. Anything but what I think it is. And then I'm scrolling down, and it's what I think. Hey, what are you doing? Come back. It's exactly what I think it is. Can anybody tell me what looks wrong there? Yeah, compare jump less. Now, just for reference, that's what the code looks like. There shouldn't be a jump in there. So I'm like, okay, what is the min function doing? No, that actually looks sensible. It's an inline function. It's a ternary. That should just compile down to a conditional move. Why is it not doing that? I don't know. Maybe it's code generation. It's 2024. Maybe it should be a const expression. Same result. It's still doing the branch. Okay. You know, they've been wanting us to replace, defines.
1 minute.
1 minute. I mean, wanting us to replace defines like that, still the same. There's no move intrinsic. You know, you've got to completely rely on the compiler to do a move intrinsic like that. So what I had to do, I had to write assembly to make sure that my conditional move got inserted, and then it finally worked as I expected. And yeah, see, that's the actual code output. That's what I wanted. I had to write assembly for that. Now, that makes me happy. But why is this all relevant? Well, that would be the discussion that Manu started on the forum there. Now, this is a modern branch predictor, and working in the microcontroller space, you're going to work on worse hardware than that. And every single good programming practice you have out there will not survive whatever the compiler outputs, whatever the hardware does. We need ways to control this. So please, by all means, listen to Manu in here, and let's get something moving on this front, because this will be valuable addition. Yes. All right.
Sorry.
He's first, you're second. Yeah. All right, so we can do a quick question while we're setting this up. If anyone has one, Nicholas has one.
Yes, I already merged that.
Sorry?
I already merged the solution for that.
Oh, perfect. Well, if anything else comes up that Manu's working on, fast track it. Do you need the clicker?
I don't think so.
All right. Well, I will do a trick. Stick it in here anyway.
Okay. So, hi everybody. My name is Eyal. I want to talk about how we use D at Weka. But before that, I want you all to know what Weka is, so I'll start with a small sales pitch. Now, I'm not a sales guy, but I'll give you the elevator pitch. So, as we all know, we're entering the AI era. Whether you want to or not, as a company, you have to invest in AI these days. Now, every data center, for AI, but even not for AI, has to have these three basic components: compute, networking, and storage. Now, compute and networking has made huge strides in the last 10 years. Maybe even the last 5 years, you have like 20,000x on compute. On the other hand, storage has kind of been stuck in the past. You have 30-year-old solutions using NFS. They can't saturate the huge networks that we now have, and it's become the bottleneck of many data centers. So here comes Weka to the rescue, and Weka basically brings the storage to the level of compute and networking that we have today. So Weka has a wide variety of customers already. So for example, 23andMe and Genomics England, and I can't expand on a 5-minute mark, but a lot of very interesting use cases. A very large autonomous vehicle manufacturer that, for example, had a machine learning cycle of 1 year reduced to 12 days with Weka. We have generative AI as a very common use case. And one of my favorites is the Vega Sphere. If you've heard of it, it's like a huge theater with the most pixels in the world and the hundreds of thousands of speakers. And the data requirements of this thing made them just impossible to use anything but Weka. Weka is basically the only thing that comes close. And actually, they use Weka to serve this theater. So back to D. Like, how does Weka use D? So D is a very versatile language, which fits many, many domains. And we make full use of that because we innovate in many domains. We have our own super efficient network stack. We have our own high-level RPC abstraction. We have data protection and erasure coding, all in D. Everything I'm mentioning is implemented at Weka with D. We have similarity-based data reduction across exabytes of data. It's pretty crazy stuff.
We have a distributed consensus algorithms implemented in D, failure-resilient file system with POSIX semantics. We have concurrency primitives, an ecosystem around fibers, scheduling. We have a tracing system that without which we'd be hopeless in debugging our sophisticated solution. It's impossible to debug a complex distributed system without it. And we have this very, very strong performance case, super optimized hot paths. We use advanced profiling, and we're basically the leader in data storage in performance. And for that, because we have such high demands, we do have to use the release flag. So, what other unique features make Weka make it so valuable for Weka? So metaprogramming. D is awesome at it. We use it for our RPC layer. Basically, we just declare functions as regular functions, regular data types, and it works with RPC that's auto-generated. We have automatic upgrade code. I'll expand on that in a bit. We have compile and testing. I'll expand on that as well. We have other languages that want to interface with Weka. We can just generate automatic Python code or Java code or whatever from our data types easily with metaprogramming. And of course, convenience. If we find ourselves writing some boilerplate, which I think in every project do, we can just eliminate it with metaprogramming. So another feature of D is the mix of system and GC. You don't have it in many other languages. And most storage solutions, other companies, they actually use a different language for their cold control path, and C or C++ for the hot path. And this language barrier is very difficult and costly. But in D, we can use D for both, because we have the hot path, no GC for the data path, and we have the GC part where it can be slightly less performant for the control path. And of course, the integration is seamless. And the entire code base is available to both our control and data path systems. So let's dive into some examples. Let's imagine this unit test. This unit test might require compiling and linking quite a large subsystem before we can actually run it. That makes our dev cycle, edit, build, and test, very long and annoying. But see the very subtle difference. Unit test became UT exclamation mark, and now it runs at compile time. And we can just do a very short -o- compilation of our module and get the unit test running as part of that. It's amazing. Automatic upgrade and downgrade. Imagine you change a struct in a way that breaks upgrade or downgrade. You basically get a compilation error forcing you to put these annotations. And then you get auto-upgrade, auto-downgrade across the boundaries. And basically, and whenever you basically rolling upgrade, you have all the new software talking to each other, and it just works. So we are hiring, and I think there's tons of very interesting stuff.
Before I get to do this.
Any questions?
All right, we got Mike. Yep, good. We're already moving, and we got a question here that we can take.
Where? Got a question?
You got a question? Yeah, there's one there.
Here's one.
Do you have your Raft code open source by any chance? Because I would be interested in that.
Sorry, we do.
Raft code.
I heard the Raft. What about the Raft? Sorry.
Your Raft code, your Raft implementation. Is it open source or is
it? It's not open source. Right now, Weka has only open sourced one component, the Mecha reactor. It's a very small portion. Basically, we would love to open source more stuff, but it's an investment to make, and it's easier to do once we see there is interest on the other end.
All right, we're all set up there. Can we get audio on the feed up there, please? And you good? All right, screen. All right, and your time starts now.
Hi, everybody. I'm just going to tell you about everything I have been cooking up in D-Lang for the past year. Well, first of all, the Facebook group has grown. It currently has 615 members. Yes, good, thanks. A woman from Kenya, Africa, contacted me on Facebook to ask about D-Lang. I told her about it, And then she told her classmates at her university, and they started a project. They are creating an operating system written in D-Lang. The DMD GUI has been improved. Wait. Now it has some. Wait, are you guys able to see my screen?
Yeah, that's the screen there.
I have to change here. I think it's gonna be now. There, now you guys can see it. Now it has some more options and it shows error messages here in case you do something wrong. It tells you the error messages. And yeah, I can use this DB. No. I don't know about you, but I work with those lithium batteries that you can put together to build packs, so you can make an electric bike or something, and therefore I have made a battery counter using D-Lang here. So you can add more, so you can keep track of how many of each of them you have in your workshop. You can tally them as well in order to know how many of the oranges you have. And it shows the total right here. And the neural network creator has been improved as well. Here, neural network creator. Now it makes sounds too. And there. A software for floating point math, which is hardware independent. It uses strings instead of using, oh, what a shame. I had to close the GitHub.
1 minute.
Here. This one here, the decimal calculator. Here. It has the functions add or subtract, multiply, divide, power, and root. You write the number as a string. You can set up how many decimal places you want. That way, it is not affected by the loss in precision caused by the hardware, which means it will always give you the same results regardless of on which computer it is running. Oh, and it is very fast. On my old computer, it can do tens of thousands of operations per second. No. So just a question, why isn't everybody... Thank you. This was the very last slide. Why isn't everybody using the link for everything?
All right. Do we have any questions while he's getting off the stage? Start moving your stuff off. We'll get questions.
No questions?
Doesn't look like we have questions. So thank you again. All right, what are we thinking of the lightning talks so far? Good? Yep. You ever think you should do one of these? Like next year?
Of course.
I think we've kind of had more lightning talks than we could realistically fit in this year, didn't we, Mike?
Yeah, we had overflow this year. This is the first time that's happened.
If these are actually really popular, maybe we should consider a double-length lightning slot.
That could be possible next year. We'll see. But
possible.
we are going to be sprinkling a couple of more lightning talks throughout the day today.
Yeah. Walter's got one coming up. He wants to talk about something. I think you're ready to go, Adam.
I am.
Good.
All right. So I like to read. And I don't always read about D, which is unfortunate, but there's not a whole lot to read out there on D yet. So I read other things. And I read a book recently called The End of the World is Just the Beginning. So this is a demographic profile. Females on the right, males on the left, youngest at the bottom, oldest at the top. Do you notice something interesting about this chart, though, besides the fact that it's got the China flag on it? There in 1990 and 1970, there are two big areas of people that were born. Okay, great. This is Japan. Uh-oh. Japan is 20 years ahead of where China's going mathematically. Okay, so we've got, what, 1975 and 1950. And another interesting note about Japan specifically is that block is double the size of their block of their young people. Okay, so what does this have to do with D? Well, programmers are humans, last I checked. Some of you might be LLMs, I don't know. But we need humans to write code. And so, okay, so, I'm working on Asia right now. So why don't we take a look around at somebody from Europe? Uh-oh. So most of Europe also looks like this. You've got a nice large chunk of people who are in that 65, 60, 70 age range, and they're retiring. And the interesting thing about these people is they're the ones who built the world we live in, the internet, cell phones, all of it. And okay, so, well, yeah, by the way, France is the exception to this. I don't have a chart for them, but theirs looks a little better. So we'll go to the United States, because the United States, that's going to save everyone, right? The United States loves to save everyone. Uh-oh. Right down here in 2025. The United States is starting to go down the same path as Japan. This is a problem for us. We might be a little later, but we're going to get there. So what does this have to do with D? Over the next 25 years, we will probably lose about 3 million programmers. If just on the basis of people get old and die. It's a sad fact, but that's what's coming to the world. So any language that requires high numbers of these highly educated humans is going to become very costly to use. And yes, I am looking at you, Rust, because as much as we all love to rag on Rust here, it's a very complex language that requires, well, higher IQ than I am. And I mean, there's people in here who could do it, but, I'm not one of them. But also C++ kind of fits into this basket too. C++ just requires a large number of bodies thrown at the problem to be able to solve even a smaller problem. So the universal case for D is that in a world where programmers are an increasingly scarce resource, programmer efficiency is going to become the driving factor that determines how we pick the languages that we use. And D is multi-paradigm, memory-safe, systems programming language that is programmer time efficient. And that's my lightning talk. Sorry, Ethan.
Don't leave the slot unfilled.
Questions?
Do you need the...
We have a question here, Adam.
Okay, there you go.
Adam?
Yes?
So you said we're going to lose 3 million programmers. How big is the population at the moment?
For programmers?
Yeah.
27.3 million.
So more than 10%, yeah.
Yeah, it's about 12.5, 13%.
I'll stand there.
Yeah, you're good.
More questions? All right, thank you, Adam.
Now, just give it a second.
Good.
All right, I think we're ready.
Yes.
Switch over and your time starts now. Sebastian, take it away.
Yes, thank you very much. 2 years ago, I did a talk about structured concurrency, and I want to give a little update. Now, a lot of things have happened in 2 years, but I haven't been working on this all that much. But anyway, some things do have happened. A quick refresher. So the aim is to get any concurrent or parallel work to be encapsulated by whoever starts it or owns it, so that it's a lot more easier to reason about things. Any errors that might pop up, there's someone to send it to, right? If you need to cancel something, there's always a parent that can kind of handle that stuff. So it makes it a lot of more easier to reason about already complex code, right? Because a lot of this concurrency, if you have many things going on, it's going to be complex enough. Hence that. A little update. One of the goals I had was to kind of clean up and fix up and redesign bits to kind of try to propose it for inclusion into Phobos. But one of the problems I had was I had lots of, well, not lots, but I had a few external dependencies. I dragged in a bunch of code, was unnecessary. So I had to remove those. That turned out to be rather difficult. But with those extra constraints and with those libraries gone, I was kind of forced to redesign things a bit, and it turned out a lot better. So fewer memory allocations. Some of them were just removed. Some of them moved to the stack. And it made things simpler, less moving things, right? And it resulted in a performance improvement. There were some issues around the streams concept, mainly around back pressure. So I rewrote them into sequences. Not my idea, but it turned out to be a great one. And they don't have that issue anymore. And after that stuff, I kind of went into the I/O and fibers and that kind of thing. So when using it, we saw that it was safe, performant, composable, and it also integrates correctly. So if you have some existing asynchronous code, we've always found a way to kind of wrap that or include that. And I think that's because the sender-receiver model captures the underlying essence of an asynchronous computation so well that it just fits with a bunch of other stuff correctly. But it's not all great. It can be very daunting to write sender-receiver code. You're going to have to learn some new things. Some things that you already know might not work, right? So you're forced to kind of reshape your code in a way that you might not want it. And that's difficult. But what if we can give up a little bit of the performance? Maybe allow some allocations, maybe some indirections, maybe some type erasure. Then what's the next best thing that we can do? Fibers. So the fiber here that you see and the yields, those actually operate on senders receivers, right? And with fibers, you could just program synchronously. You don't have to learn any new things. You use fors and this and that. By the way, the code here is just, I shrunk it down. It's don't write it like this, but you get the point. Because you can use them interchangeably, you can do half of your work here, half of your work there. You have a choice, right?
1 minute.
Which means that you can pick one approach and then later on decide, hey, I'm going to refactor this and get it all going. By the way, all the algorithms, all the sender algorithms, they work on all of that too, right? So you can start it one way and then slowly fix it others. Fibers, really? I don't like fibers. They have a few core issues with them, but it is the best that we got. So that's what we have to do with. I am sure that if we get something else, let's say stackless coroutines maybe, then we will be able to integrate them the same way and get like the same kind of trade-offs.
So that way you have a choice. You can write things like you want to, and then refactor if you need to, kind of mix and match things, and everything is just going to work. Done?
We have a question from
Any questions?
Vladimir.
Any questions?
Not really a question, but I just want to say that the .yield calls looked a lot alike like .await calls or like await in JavaScript.
Yes.
So I just want to say experiment with that concept and premises, and I think you're on the right track.
Cool, thank you.
Anyone else?
Do we really have to do this one, Mike?
I'm sorry, Ethan, but we do.
Yeah. Well, I said that I'd only let it go ahead if I could gong after every joke. That's right, he's back. Can I put him on 4 minutes at least? No, fair's fair, but you will get a gong.
Right. Well, why do I feel I'm in the middle of some like weird kind of thing? So no, well, if you want to, kind of like to start. I mean, I guess I'm not talking about D so much. So yeah, am I the diversity hire or something like that? No, anyway. Okay, yeah. So those of you remember from last year, you kind of generally know the score. Yeah. So 5 minutes of pain, and then it'll all be over, and we'll be on to the D again. Okay. So when I first heard about lightning talks, I thought it was a bunch of people standing up on stage for 5 minutes bitching about Apple charging cables. If I fork the Wikipedia page on Yak and create my own list, does that make me yet another compiler? If a self-driving car goes from London to Paris to Berlin and back to London and nobody notices there's a driver, does it mean it's passed the Turing test? I've always thought the song When I'm 64 should have been sung by the Commodores. Not popular, right? More technical stuff. Okay, if I take 8 drill bits and I put them in a box, does that become a drill byte? When people first learn C++, they sometimes ask, what's the difference between char and wchar-t? And I say it's really easy. Char is for narrow characters like an I or a 1 or et or L. And wchar-t is for wide characters like a W or an M. Simple. I thought I'd get back into C++. I thought I'd do some intensive training on undefined behavior. It was a crash course. I've also started working on my own concurrency primitive. If the thread enters and there's already one there, it basically just terminates it. I call it a hemlock. I've never understood why people overload the plus operator for string concatenation. I mean, it just doesn't add up. The longest programming book I ever took to read was one called Algorithmic Complexity by somebody called Owen Squared. I think functional programmers are all arsonists. They spend all their time playing with matches. Yeah, I had a friend who started drinking and smoking and basically staying out heavily and decided to get out of web development in Ruby. I think he's gone off the rails. But it's okay, he decided to become a property developer. So he spends all day writing getters and setters. Is a polyglot somebody who boasts about how many programming languages they know? Wrong audience. I once wrote a bash script with just a hash and an exclamation mark. That was it, the whole shebang. There's a maximum rate that you can write characters to a console window known as terminal velocity. I recently met this guy who described himself as a prompt engineer, but apparently just spent all day playing with ChatGPT trying to tweak his PS1 bash variable. I always struggle to create digital certificates. In fact, every time I try, I just make a hash of it. Somebody in InfoSec came over to us and said, do you do key rotation? I said, yeah, every 3 months we run it through Rock 13. I once had to configure a VPN over our new fiber optic network, but I had to give up when there was no light at the end of the tunnel. Upper management said that we were losing market share and we needed to be more disruptive. So I dropped the production database and deleted all the source code. Our enterprise architect is a big fan of object orientation. If you try to use F#, he objects. If you use Haskell, he objects. We once hired this guy, this DBA called Sisyphus, but he was rubbish. Every change he made got rolled back. People who joined Twitter after the 23rd of July 2023, known as Generation X. The other day, my timeline was full of tweets from John Carmack and John Romero about the state of the games industry. I felt like I was doom scrolling. Is that it? I've got time left. Oh, okay, I'll do one more. Okay. If I write a for next loop in BASIC and I put loads of comments in between it, would that be REM sleep? There you go. I feel the pain.
Yeah, go on. We are not taking questions for that talk. All right, getting back on with our regular programming. Tell me you've got some Ario up there for us.
No, it's something really bland compared to what we just got. But
well, I mean,
hopefully you're still interesting.
Whatever it is, you've picked the right talk to start after because it's going to be an improvement. All right, so off you go.
All right, so this is like the director's cut of my talk. As I alluded to in my answer to Timon's question, I had a whole chapter on the DIP 1000 limitations that I scrapped, so here is some of it. So we're in a situation where we want a safe language, a simple language with simple pointers, and use stack memory, and we can only pick two. So currently we have simple stack memory, pointers are simple, and we can use stack memory, but there's this glaring hole in safe where you can return a static array, a local static array. So with DIP 1000, we added scope checks, so now it's safe and caught, but it gets scope pointers, complex, some people don't like it. And there's been the alternative where it's simple and safe, but there's no stack pointers, which is Robert's idea, which is so you don't accidentally have to deal with scope pointers. You're just straight up told, nope, it ends here. So we're not really sure yet what the next direction is going to be with additions. Currently, DIP 1000 is in the preview flag. And the idea was first to make it a default, but maybe in the next edition, we're actually going to do Robert safety, and we'll see what happens with DIP 1000. So I, of course, want to keep DIP 1000. I think there are some value there, but there are some issues. So last year, I presented them. This is the basic idea. You have the three primitives, taking the address, just returning value, or dereferencing it and not escaping it. So some issues I presented last year was the implementation at code duplication. This is, these two functions are supposed to do the same thing. I factored them out in this PR. Since then, I've also refactored escape.d this year, so the number of if statements went down from 310 to 240, and also fixed some latent bugs in the process, which is nice. But it's still, it can still be reduced a lot further. And this refactoring does allow more new features, new bug fixes, because currently it was such a tangle that it was hard to improve. Last year I presented this limitation with nested functions. This particular case has been fixed, but there's still lots of other ones, so don't try, you're not safe when you're using closing over scope variables in nested functions. Scope inference is still killed by assignment. That's PR still is in limbo, but we have ref variables now, and those don't kill assignments, so you can use that. By the way, that also fixed an old issue where std.array, while duplicating it, duplicating a stack array would still pretend it's still scope, but now it doesn't anymore. So that's a slight improvement. But other than that, there's still fixes necessary. Yeah, we don't. People complain about the scope annotations, and I always said you shouldn't write them most of the time. It should be opt-in. Paul Beckett has been working on a dip about inference on default, but in the meantime, I think it would also be great if we could apply auto just to a scope. Currently, it says, oh, you can't have both auto and in a return type, but maybe if you allow this, this could allow you to write less scope annotations. We want partial and transitive scope. This is, I tried the arena approach on my C2D. program, and it has a big context struct with, for example, a symbol table and a source. And you cannot say, oh, the source is scope, but the symbol table is GC allocated. Or you cannot arena allocate the hash map because the keys and the declarations are the reference level deeper, so scope doesn't apply to them. So maybe better inference could help, but it also raises the question, what syntax is gonna say, oh, this field is scope, this isn't? Can we explicitly write that if we need to? So that's still an open question. Ricky has been working on a new proposal with more complex syntax. It's a bit longer, but it is more explicit and allows you more detailed descriptions of things. So that's worth checking out. And yeah, last is a call to action. Share your opinion. Ricky has made a survey where you can kind of give your opinions on what kind of, how much complexity versus how much expressiveness and safety and stuff you want. So yeah, do fill that out. You can find the link there. You can find it also on my GitHub DConf repo, or it's recent, so you can also just find it. And there's this thread for more qualitative analysis. If you have specific issues that we haven't encountered yet, share your DIP 1000 woes, and we can take that into consideration as well. And that's it.
Any questions?
Any questions while we get the next guy up? Oh, it's Stephen again. Bruce has his hand up.
Yes, I appreciate your work and your posts on this topic. But I did note that you said, okay, DIP 1000 is simple, and then you gave like 3 pages of tables explaining why it's simple. And I said, okay, thank you.
I think the primitives are simple, but you need to know the existing features of static arrays versus dynamic arrays and ref parameters of struct this parameter and the class. Like, it's the existing language which makes the primitives more complex.
Yeah, the actual question, as opposed to me trying to be cute, is are there qualitative differences in terms of what can be covered by the different systems? My impression was that Ricky's system had the possibility of getting its arms fully around the problem, whereas there were some difficulties with getting, really solving it with DIP 1000. Is that accurate or not? I haven't gotten into it.
Sorry, what do you mean with the last part?
Basically, are there cases which Ricky's system will handle the DIP 1000?
Ricky's specific case is for multiple outputs, because it currently return is only for returning, but sometimes you return it by an out parameter. And currently, there's one special case where you can return by assigning to the first parameter, but not the last parameter.
Right.
So Ricky's proposal primarily gives more accurate information on which parameter ends up in which parameter or return channel or global variable.
It's a fully enumerated graph. Yeah, okay, got it.
It's more detailed on the assignments.
All right, thanks. We've got to get this rolling. So you ready, Stephen?
I think so.
I mean, you should be ready. You've done this several times already this week. Good?
Yep.
All right. Time starts now.
All right, so I just wanted to show if everyone remembers the little demo of the heap that I wrote yesterday. I showed yesterday. That was all written in D. I wrote it in about an hour while we were waiting for the talk to start. So I just wanted to show you how easy it is to make like a little game-like thing with raylib. So I'm going to start from scratch in code D, make a new empty console application. It's going to say select a folder. So I'll just create a new folder here called, come on, Lightning. Open that. And now we get a new D application. Click on that, and now we'll get our dub dependencies in a second here when the thing starts up. We're going to add raylibd. All right. And the only odd thing we have to do, I'd like to fix this, is we just have to run a little thing that will pull in the libraries. So dub run libd install. And that'll pull in all the libraries here. And it'll also update your JSON file so it adds the proper directives. So now we have a raylib program. And it's as simple as writing a few methods. This is like, when I learned how to do this, I was like, I can't believe this is this easy, and I haven't been doing this for a long time. Okay, set target FPS 60, while window should close. We're going to begin drawing. Exit and drawing. Oops. And we'll just clear the background first. And let's see what happens now. We should be able to build this and run it. And there we go. Oh, I made it white. I wanted to make it black. I'll just switch that real quick. All right. So now let's say we wanted to do something a little interesting. We'll write some text on the screen. Draw text. This is basically going to run, this loop is going to run every frame. So we target 60 frames a second, so you can do whatever you want in that frame. And 10, 50. Color stop black. And the font that's going to, or white, we won't see it otherwise. And the font that's going to use is the default Raylib font, which looks horrible, but it's nice and already included in the library for you. You can load other fonts, though. And I was going to do all this stuff when I was, well, I can at least show how the image is loaded, but I'm going to kind of cheat at the end of this here. So let's say we want to load an image, load texture, and I'm going to use this logo. 512.png. And I'm going to drag this guy into there. So now we're going to draw that image. Screen height. Sorry, width. Minus.
1 minute, no pressure.
That's okay. I'm going to cheat at the end here. I knew I wasn't going to get through this in 5 minutes. And color is now white. The tint just basically can color the thing. So if we do this, we should get a nice thing with the image on the bottom. And then to cheat here, we're just going to load. I did a little animation, so when I basically push the key D, it's going to do a takeoff animation where we rotate and then fly off the top of the screen. I'll just show you how that works. But it's all this stuff is pretty simple. So hit the key D, and there it goes. Thanks. So yeah, if you want to use Raylib library, it's available. I am porting that to D, as my talk said last year. So eventually it'll be a little bit easier to start up.
Questions? Any questions?
Questions? Really?
I think
All
I
right.
answered enough questions today.
Yeah, ask something about the garbage collector at least.
Oh, we have one. We have one from Vladimir here.
So you say port, or is it a binding?
Sorry?
Is it a port or a binding?
That's the binding.
Okay.
The port will eventually be, so you won't have to run that Raylib install. You won't have to install a library. It'll just be all part of it.
Carsten Rasmussen. Yeah.
All right, I think you're done, Stephen. Thank you again. Carsten.
Yeah.
Look at him. He's ready to go.
So yeah, we're doing a decentralized database. So what is important when you have a decentralized database and you don't know if you want to store something decentralized, you have to have the same format. So we have developed, we have defined what we call a hash invariant binary object notation, and we have a page for this. So this is just a standard, and you can in principle write this in any language. They are inspired by Bason, but in principle it's much simpler. So you can read about it here. And what we also use it for is has invariant remote procedure calls, because when we have, it's important that we can sign contracts when we send, or messages when we send it back and forth. So we have also a utility, which I'll show a little in a little short. Where is it? Anyway, so we go here. So this is an example of how we do it. So we just put up a struct and then just display it, and then this mixin would then make a serializer, a deserializer. And I think what is important is that because we use a lot of those objects, so what is important is that because the way it's actually very simple, the only thing we do is we sort the keys in the object so we get the same binary map, so we can make a hash, so it's as invariant. So it's in principle very simple, but we found out when we have two different classes. We have an immutable class, which is just a binary, where we have a lazy search on the keys. So when we first have it serialized, it's very efficient. But when we construct it, it's not efficient because we have, or at least less efficient because we have a class for this. So we have a mutable object. So we render this. But in this case here, where we have just a simple struct, we just need to serialize it. So I'll see if I can find this. What's called? Yeah. So we actually just make it. So we make actually, what we do is that we actually make the keys in compile time sorted, so it's already sorted when we had to serialize it. So it makes all those objects very fast, so we don't need to sort. Or actually what we had in the runtime is that we have a red-black tree, and it's not very efficient. It also makes a lot of cache misses, but this one is actually very efficient. And what we do is that we also, so everything is, so when we have serialized it, we can also take in a mutable object, instead of just rendering everything, we just put in the immutable object into a mutable object, so we can serialize it together. So we just take the string and then put it into the system. Yeah, so yeah, that's actually it. Then I will just to see if I can find, this one maybe. Yeah, so, and then we have defined, because everybody's using JSON, so also for debugging it's nice, instead of having just a hex code, we have a utility which can serialize a JSON in a specified format, and it's actually, you can serialize and deserialize it. So you can go back and forth, because it's, for a lot of applications, it's easier to do this. So you have the type information in, and this is, so everything is info, the type information is also in the JSON, so we can do this back and forth. Yeah, that's it.
Any questions?
Any questions? Doesn't look like we got questions.
Luis?
Oh, do we have one? No. Oh.
It's clear, I think.
Okay.
Right. Thank you, Karsten.
Come on. Set your stuff up. This is our second last speaker in the lightning talks today. Good old Luis. He's been here a couple of times before, so he's no stranger. What do you think of the lightning talks now? Any better? Yeah. So should we have a show of hands if we should have a longer one next year? I think that's pretty unanimous, Mike. I think we should do that.
All right, done deal.
Should have what? Multiple set. Oh, like split it up like one a day or something, right? That might work.
That's a good idea, yeah.
Yeah. All right. I think we're just about ready. You wired up? You ready to go? Cool. Here's the start button.
Yeah. So I'm presenting the improvements on the LDC lint. This is a project that I started to make last year. This is basically a plugin for the compiler to run post-semantic analysis in your code. The reason to do this is because the compiler, we don't want to run the scanner after the compilation. We want to run in the compilation phase, so we save some time. So this is some new features that I had from the previous run. So one of the things that we don't really want to do when we query the AST of DMD is mutate the AST, because when you query the AST of DMD, you might mutate the AST. So I did a tiny query wrapper of the AST nodes, so I ensure that they are immutable calls. And I also had it in the case that we can't resolve the calls, I had a resolve wrapper, where if it's resolved, you get the result. If it's not resolved, it says, yeah, it's not yet resolved in this phase. So currently, we only do after the semantic phase, so nothing is supposed to be unresolved, but if it is, we have it. And basically, this is how you have the resolve code. So it's a pretty simple thing. And the querier, it's a bit longer, but it basically wraps the AST node, and you can implement some custom methods that use this resolve wrapper. So another thing that I had is the ability to have lipdparse nodes alongside with the DMD. So it's a good thing that you can port these kind of linking rules for you. But one of the biggest advantages is to have some things that you don't have on the DMD AST with the lipdparse, for example, formatting stuff and stuff like, for example, comments that you don't have. So you can have something like override with a visitor, override the DMD AST or the dparse AST, and the visitors. It's basically a wrapper of either of both visitors with a query object. So the query object is always immutable, and you visit with immutable, so you'll never mutate the AST. And I also added some other rules. One of them that is in progress, it's rule unrolled fortified checks. So, for example, if you want to have you have some parts of the code that you know that it will fail at runtime after the unrolling, so you do some checks there. Another thing that also beat us in Weka, it's we have, for example, sometimes you have bitwise operations on booleans, and like 99% of the time, you don't want to do bitwise operations on booleans. So we have a check for that. Also, another thing is the integer overflow before conversion checks. So if you do an operation with a larger and a smaller type, it will convert to the larger type, and then it will cast back to the smaller type. So after the conversion, it will overflow, and you don't know it, so I created a rule for that. And also some internal coherence check for the compiler. So basically, I check if anything is unresolved. If yes, I just raise a warning for that.
1 minute.
And future implementations is not only running just post-semantic analysis, it's also running pre-semantic analysis. One of the cool things of running pre-semantic analysis is having constants unfolded, because after semantics, the constants are folded, and also more rules to implement. This is how you supposedly define, this is not yet compiling, but I want to compile it soon, trademark. So you have metadata of the rule, and you can say, for example, it's the news rule, if it's enabled by default or not, if it runs on HAL modules, like imported modules and also your module, and the priority of the rule, and then you override the visitor and do your check. So yeah, that's it.
Questions? Okay, we have a question.
We got a question down in the front.
Are there already any rules, lending rules, related to the use of the standard library or places where the standard library maybe is not used but should be used, or maybe even where the standard library ranges are used in a potentially unsafe way?
Yeah, like we can have those rules. Currently, we want to add some rules that is, for example, calls from foes that is known to be error prone. Maybe, I don't know one example, but if you have any example, you can raise an issue there, and we can have the rule. Currently, I'm mostly focused on having a good infrastructure for adding rules easily and also interacting with them correctly. So yeah.
Oh, thank you again. And to wrap up today's lightning talks, guess who? Seriously, I heard applause and not a guess. Guess who? You still applause, but it's Walter, come on.
Well, I had an idea, and I don't know if it's a good genius idea or a really stupid idea, and I bounced it off Manu, went and bounced it off Attila, and they both said I should do a lightning talk about it. So here it is, half formed, and we'll see how things go. There are multiple ways of returning errors from a function. There's error codes, there's throwing an exception, and there's option types. And none of those really seem to appeal to me. And then I remembered something from, long ago when dinosaurs ruled the earth, and I programmed all in assembly language. The convention for signaling an error was to set the carry flag. I thought, wait a minute, why can't we do that with a high-level language? It will work like an option type, except it's really, really cheap. So if your function returns and the carry flag is set, then the value returned is an error code or a pointer or whatever you want it to be. And if the carry flag is clear, then it's a return of some other thing and not returning the error thing. And this could be worked into, well, if you're not testing, if the carry flag is set and your code doesn't deal with it, it just returns again, setting the carry flag, and it propagates the error up the stack. You can catch it by having a catch statement or a finally statement. It'll do a jump on carry to the catch or to the finally. And so it kind of works a bit like exception handling, but without all the overhead and all the costs to it. Downside of it is I don't know if any code generators support this kind of programming. I know DMD doesn't. Of course, it could be fixed to do that, but I have no idea what the level of effort in converting GDC or LDC would be. But I think it's an interesting idea. It's very lightweight, very fast, and I'm amazed that it isn't already being done somewhere. Somebody mentioned maybe Zig was doing it. I don't know if Zig's doing it or not, but I think it's an idea that we can explore. Maybe we can do something great with it. So, questions? Well, ARM has flags. As far as I can tell, ARM uses a similar ABI to the x86 where values are returned in registers, not in flags.
My question is, when you're starting your function and you're basically like you have all your parameters on the stack, but often at the end of the function, you're basically adjusting the stack pointer, you're having to add to it. Doesn't that set the carry flag and overwrite whatever was set earlier in the function?
Yes, you would have to clear the carry flag at the end if you're not returning an error. So I was thinking maybe, you know, we have extern C and extern D and extern C++ function types. A fourth function type could be the one that has the carry flag.
But I mean, after you set the stack pointer and whatnot, if there was an error, how would you basically set the carry flag?
Well, throw. You repurpose throw to set the carry flag and return from the function. So, you know, you throw an exception. Well, the exception in D is one word long. So you already have the syntax in D to make that work. You have throw, new, exception, whatever. And you could, the way that would be implemented in the compiler was it would load that payload into the return register and set the carry flag and then return.
And is the carry flag guaranteed to be stable in the event of you being interrupted? Like, let's suppose there was a context switch and then you resume execution?
Nope. So if you're trying to, oh, you mean across an interrupt?
Yeah.
Oh, of course. It couldn't work otherwise because lots of use of the carry flag is made in the program between multiple instructions, and if an interrupt between those two instructions changed the carry flag, it would be worthless.
Yeah, that makes sense.
Yeah, well, I'll try just a quick grok level check on ISAs, and carry flags are prominent in all of them. You know, going back to like even Spark and stuff, but RISC V is not. You might have a little bit of difficulty there. They have a kind of a weird way to express it. So, but yeah.
Okay.
Yeah.
I really know next to nothing about RISC V, so.
Okay, this has to be the last question here.
So what would be the real benefit of having this? Because you're not expecting exceptions to happen very often. So you're essentially optimizing a part of the code that doesn't get executed only very few times.
All right, so what you're saying is, what is the cost of having this and not using it?
Yeah, maybe.
Yeah, I think the setting and reading the carry flags are really cheap operations. Number one, and I kind of think a lot of code should be returning errors, and we don't because it's just too clumsy to return errors. Or we return errors using option types and things like that. And when you think about it, isn't it actually costing you even more code to deal with those cases? Like if I do a string search for something and it returns -1 if I didn't find it, isn't that more expensive than returning a carry flag that I didn't find it? You're still going to have to do you'll have to do a test and branch after you call the function as opposed to jump on carry. So it may kind of work out that it'd be hard to tell if it worked out cheaper or not overall.
Yeah, I think it makes sense if you.
It's an idea. Manu, I was told one last question.
Go really quickly.
You could eliminate the require to do this stuff probably with something like no throw.
Yeah, no
throw. So
throw.
then the function can't actually return an error in an error case.
Yeah, we got to cut it.
Thank you, Walter. Of course, you can ask him questions about this during the next 10-minute break that we have here. Obviously, they won't be recorded, but hey, we have the forums for that, so chatter more on there as well. But otherwise, next talk in 10 minutes. Go do your thing. All right, everybody, we're going to get this puppy on the road. Mike Shah, welcome back. Don't applaud or anything, come on. All right, you guys, it's talk time. Everybody, come on, talk time. You do need to talk, just go downstairs or something, but right now, Mike has the stage. So, take it away, please.
All right, thank you, everybody. Good to be back here. And today's talk is going to be a little bit of a continuation from a DConf online talk, but doesn't so much matter if you've seen that before, doesn't so much matter if you've done graphics programming. Just want to kind of get you excited about thinking about D in domains where I think it's really useful. So anyways, there's the abstract about this. Here's me, if you want to learn a little bit about me. But the real important thing here that's kind of neat here, I recently changed jobs. So, a little D community announcement. At my university, now at Yale University, I'm teaching my Building Game Engines course in the D programming language. So, it's, very exciting. The students, are really enjoying it. And for those who are at DConf last year, I brought some students. And for those watching later, you can, see their perspective on, was it worth it? The short answer is yes, it was worth it from both student and my perspective for productivity and all sorts of reasons that we're going to talk about. So again, last time I talked about some graphics, and again, the standard thing to do is use a API like OpenGL or maybe Vulkan or Metal or Direct3D these days and render some object like this. So we discussed some of the bindings that are available, GLFW, rendering a bunny in the object format, and using other techniques like multiple rendering targets if you want to do other stuff like deferred rendering and kind of get into the fun part of graphics, where you can basically build a system that supports the artists building your game and so on. So again, sort of just part two of the previous talk here, just to again have the goal of really just getting folks or graphics programmers some motivation to give the D programming language a try. Again, I've done a lot of C++ work, both professionally, teaching, research, and now I'm sort of, again, doing more and more D programming, and I've really just enjoyed the productivity benefits that I've found, and not really with any trade-off of speed, right? It's all running just on the GPU. So again, I found D really well suited for graphics work, and I hope other folks will, again, get excited about it. So here's a little demo or a screen capture, again, of a classic scene in graphics. This is called the Sponza. That's the sort of building, and then you've got the bunny, or most of the bunny there, in the middle rotating around, and some other objects here. And there's a little bit of lighting and some other stuff going on. And what's interesting about this is the size. It's 260,000 triangles, which is reasonable size. So it's a good sort of benchmark to see, are we running fast enough in this type of application? Is D generating fast enough code? The answer is of course yes. It can handle this. Our GPUs can handle this. Where a lot of the computation's happening. And it's also a purposefully sort of unoptimized data set here. Meaning that the world or the object files that I've loaded are art assets that have all sorts of interesting issues. The textures need to be flipped. Sometimes they're not aligned. There's the actual model is made up of many different pieces of art here. So it was a really interesting challenge to try to put something together, go through that process of what you might do on, say, game team working with assets that are coming in on the fly, and sort of see how resilient is your system, your sort of pipeline of getting graphics into the scene here. So just diving in a tiny bit just to see what's going on here, or what's sort of interesting about this problem with a sort of simple scene even as this here. Just putting my sort of graphics hat on. You can inspect these scenes using tools or GPU profilers like RenderDocs, a pretty popular open source one. And basically what it does is it allows you to capture a snapshot or a profile of that scene. So you can see all the API calls, where your allocations were on the GPU side of things. Again, it works just the same if you're coming from a C or a C++ background on D here, this profiler here. And then, of course, your other profilers like perf and so on are also very useful in this sort of graphics stack. And of course, don't forget about D's built-in profiler and the, I actually like using that tool a lot as well. But within this tool, RenderDoc, you can inspect the geometry and the data that you've allocated. Again, so sort of, I don't have to read it here, but there's a bunch of interesting maybe things going on here, some function calls, all the OpenGL calls for this example that are going on. So pretty standard stuff here. And you can see some outlines of the geometry and kind of debug things, which is nice. So anyways, what's sort of interesting about this scene, as I alluded to, is you kind of take this in or interpret this as two pieces of data. Again, the bunny sort of in the middle of the picture, small and rotating there in the animated version, and then the world here. But again, scrolling through your profiler, you find that this world, the Sponza scene, that's what this castle thing sort of looks like. It's actually made up of 23, again, objects that are oriented in different ways. They've got different textures of different dimensions, and it's just a really interesting kind of data problem to try to solve. So you want sort of a productive environment to iterate and eventually solve and get the textures right and the lighting and so on. So again, here's the same screenshot, just a little bit bigger. And what's, kind of going through here, each of these different models here, you can see the 23 different pieces or some, the wireframes that make up that world there. Again, just sort of showing the different chunks of data here and what's collected as a object file. That's the 3D format. So not like the compiled binary files, but OBJ is the common static 3D format. So, looking at this object file format was kind of interesting. And again, I talked about this a little bit in a previous talk, but the basic idea is you have a list of vertices or some attributes for the geometry that you parse through. And then they might be grouped in some interesting way. That's the second group here. So you have a list of the faces, sort of defining the connectivity between the geometry, and maybe even different materials here. And I just think this is a really interesting problem, and it's kind of interesting how you get interested in this stuff, but trying to think about how fast you can parse through this data, because this would be an important part of, again, iterating very quickly and being able to see changes as maybe an artist gives you a new 3D asset that you want to see. So what's really neat is you can parallelize this process, relatively easy in some ways, or at least it became apparent to me having some experience of D and just having threads available in an API to do this, where I could maybe parse this list of geometry, that's this top section here, and then as soon as I encounter these sort of blocks here that have use MTL, which is a material or the image or texture data, you can actually start processing that in parallel as well. So if you have a large enough file where it's worth making that decision if you want to parallelize and kick off some threads, you can actually do that. And again, this was just some of the things that I thought were really interesting, having the experience with a D programming language that just were apparent how I thought about the problem. It goes back to, even on the D language tour, you see dot parallel for parallelization. So it's in my head, I'm already thinking about these things, and it's easily accessible. So this is setting up a little bit of a larger experiment for me in the future of a large data set. I think it's something like 2 million triangles, the Caldera data set that I'm investigating now with some students to see just how fast can we load data, essentially. So again, if you're not interested in graphics, maybe you're interested in sort of the data side of this. How fast can you load your data? And some of the things we've learned about DConf, pinning your memory and using fast I/O and these sorts of interesting things. So stepping back just for a moment to thinking about the sort of graphics engine and the design, it's just been, again, a pretty pleasant experience working in D here. Because if you think about the core sort of application loop for a graphics program, it's basically something that looks like this in the top right. You have run, an infinite loop that just keeps running and running and running. And you can break this and sort of abstract it into maybe an advanced frame or have some control over how things work here. And again, just really easy kind of abstraction here to set up your program and start thinking about how can I be productive? How can I structure something that, once I have the core here, is maybe a little bit extensible and interesting if I want to build a game or graphics application. So, of course, you probably want more power than to run through that loop and just sort of put everything there. So of course you can define an interface and have some sort of callback, which again, I really like having an interface that I can program into. I can have my classes here and make up some callback to maybe print something or have some action in my game or simulation that happens at the start of a frame or wherever I want these entry points to be. So again, a D language allows you to program to an interface, which is really nice, self-documenting code, and works quite well. And of course, if you don't want to do callbacks everywhere, you can have an event queue or something like that as well to push events into. But this is just one example of a structure here. So some other interesting things, though, thinking about interfaces and programming to interfaces. More recently, I've started thinking about these projects that I'm doing using OpenGL to create portable graphics projects. And I wanted to start targeting the web, for instance. And for me, an easy path to do that was through Better C. So that way I can distribute graphics applications on the web for students and so on to see. And as soon as you use Better C, one of the things you do lose is the runtime that's provided. Now, of course, that's by design so that you can basically target different devices. So anyways, I got to thinking about this and searching around. I found Attila's project, Tardy, which was really nice, which basically lets you use runtime polymorphism without, you're just using structs here, which is really cool. So I've started developing something similar in that vein as well, which was a great thought experience and also showed the flexibility and the power of the language, which was cool. So now I can target web here with Better C. And with that, now I can have my callback system and everything. So I'm not really sacrificing anything, and I'm getting all the speed, performance, and now portability for graphics applications. Okay, getting back to the graphics story here, I found a lot of just productivity gains in the realm of graphics programming here. Don't have to sell this crowd here, but maybe for people watching, or you can send this to somebody who's thinking about D or how to get involved. They're just little, tiny, in some cases, large life improvements here for programming. I try to keep a better blooper wheel, but these are some, graphic experiments gone wrong here. There's, something wrong if you look hard enough at these pictures, because graphics programming, sometimes you're just getting a blank screen. Sometimes the textures, messed up. So you get lots of different, strange errors that you want to, iterate and fix here. So in that way, graphics programming can be a real challenge, and sometimes the graphics APIs don't offer many great tools for debugging. If you've done some OpenGL programming, you basically have GL get error, which gives you an error code. You might get a callback if you're using a later version and so on. But it is nice otherwise to be able to iterate quickly. So as a graphics programmer, you have some tools for iterating quickly. You can, within a graphics API, just recompile your code on the fly. So it's sort of like a hot reload system, you would call this, where you can just recompile the shader or the graphics driver in the sense of your application on the fly while your game logic is still running, for instance. So, thinking about it from that side, another common thing you might do in a game, or is becoming more common, is to say, well, what if on the CPU side I write some D code and I want to sort of hot reload that side, and be able to just load in code that can execute maybe game logic code or your application logic, and you can certainly do that. So I came up with a little. I think this is my first take at a script here in this image here. But the DMD compiler is really fast, so if you want to just reload in a shared library, you can do that pretty much instantaneously, or very, very close. And LDC and GDC have also used, which are also very fast for adding in little game code or simulations that we have here. So if you're able to do that, and you have your little callback system, you can really iterate quickly on your graphics applications or your engines here. Now, if you're loading code and unloading code, you do have to take some care with memory and who sort of owns these resources. So those are a few of the gotchas you can read or talk about. But it becomes really nice. So all of a sudden, I have this system where basically I can have my game running forever and change things on the GPU side or the CPU side and just view the changes. And I know there is some infrastructure for this kind of stuff, or was previously at least in LDC2. Last I checked with dynamic compile. But otherwise, you could cook up some system like this in no time to compile shared libraries and just load them in. So these are really appreciated and kind of cool features. And again, maybe if you're not interested in games or graphics, maybe this will be useful in one of your systems as well to think about these ideas. So a few other handy things that have just sort of saved me on the iteration time here. D has support for contract-based programming here, so things like postconditions and invariants and so on have been very, very useful. I spent some time building a tiny math library for this application, so I could rotate and move around and stuff. And basically, every time I get a NaN value for a float because I divided by 0 or did something silly, I basically want an early exit. So it's nice to be able to just do that, similar to what was just being discussed in the lightning talks about carry flags and basically getting some indicator very, very quick that something's gone wrong. And again, you should load in some new code or recompile and find the bug. So these were just some handy things here. D, as we know, or folks in this room know, it's very easy to template code, maybe too easy in some cases, so you get a little template crazy. I probably have. But being able to template lots of functions and add different constraints can be very valuable, especially when working with some of these APIs, these graphics APIs like OpenGL. So here's a simple example here. In OpenGL, you have different shader programs that are doing the graphics work, whether it's the geometry, we call that a vertex shader, working with vertices and transforming them, and a fragment shader, working with the pixels. So those are two of the types that you can have here. Now, if you're just working in the sort of C API, you basically have an enum that you specify, but if you put in the wrong thing, what's your feedback? Well, you might get an error if you query for it. So it's kind of nice if you can template for the type and put in some template constraint. Now, whether you enumerate these or write a little function that checks all the types is up to you. But again, that's just very nice for having some fast feedback. So again, maybe I've gone a little bit template crazy here, but it just kind of saved me from these silly errors. So for my OpenGL programmers, you don't see error 1280, right? And that's your only feedback because you have a wrong enumeration. It's much, much nicer to just not have this code compile and be able to check that. OK, so getting towards the end here, a few more pictures and thoughts before we leave this little graphics experiment. I did some more porting of some of my C++ code, again, to the D language. Here's sort of standard. Here's a normal mapping example, some lighting, some experiments with instancing, where you repeatedly draw things and animate them. And really, the goal here for me is both from a teaching and also from a serious perspective, because I think D is a serious language for putting out commercial products in games and graphics applications. It's just to start generating a large library of sample code for other folks to draw on. So things like I'm working on a little math library that I'd also like to distribute, and also starting to take a look at Vulkan and talking with folks about what that looks like in D and if we need wrappers or bindings. So there's lots more to explore, but it's a really exciting space, I think, to be in the D programming language and working with these APIs. So the tool stack that I used for today, and I'll distribute my code that I have for, I use the BindBC projects, which are excellent for just getting started and work on Windows, Linux, Mac pretty much out of the box. I have my own math library and also found InMath and the GL3N library is very useful for linear algebra. So you can use those. And kind of wrapping us up otherwise, again, there's a lot of different graphics APIs out there, and we have bindings for them, so you can check those out. If you watch the lightning talks, Steve's talk, like Raylib is a great API otherwise for doing graphics programming. The GLFWD bindings are also excellent, which I was using previously. So there's a lot of great resources out there already for people to get started and to start doing work in graphics or compute. So, the high-level takeaways of this talk is, D for real-time graphics, I think, is an excellent win. For me, at the least, the productivity gains have been enormous. The safer code, the code that's being run is still being run very fast. It's the same GPU code, can use the same tools that I've already learned. So in some ways, it's been almost effortless and just a fun experience rather than wrestling with bugs and the less fun stuff with programming. So I hope this gives you some encouragement if you are a graphics programmer or thinking about it to try this out with the D programming language. You don't have to do the standard, write everything in C or C++. There's many, many examples of games in D and other languages. So that's what I tell folks to make the brave decision and give it a try. And I think you could really build a nice tool stack here for a competitive advantage with the D language. So I'll add more graphic stuff to YouTube. That's my plug there. There's been, again, tons of talks here on games and graphics from folks that are in the audience here in the past for, again, commercial games or indie games, for fun projects, other game engines like Supreme Engine and so on. And I've given some other graphics talks if you're just interested on non-real-time graphics as well. So with that, that's sort of the case for graphics. There'll be some sample code available after the talk, and thanks for your time and attention, and hope you consider D for graphics.
All right, we got time for a few questions, and then we're going to have another quick lightning talk. So first with Bruce.
Fun talk. Thanks. I had just a few questions, which will reveal my ignorance of your expertise, actually. Are mesh shaders going anywhere? Is ray tracing going to affect the architecture of game engines in your classes and going forward? And third, is there any benefit now that we have heterogeneous memory management to make it simple? Is there any benefit to having like compute shaders, like picking up decompute as an augmentation phase to, I don't know if the compute shaders are actually used in graphics or not, but those are the three questions. Mesh shaders, ray tracing, and utility of decompute, yes or no?
Yeah, so the short answer is sort of yes to all three. So mesh shaders are starting to appear. Not as much in OpenGL. I mean, there are some extensions like 4.6, but the new APIs, for instance, are working with mesh shaders for giving more power and sort of levels of detail for how much graphic stuff you can basically put on your card. So mesh shaders, yes, these are relevant things. Sort of goes with the second question, too, with ray tracing. Again, the modern graphics APIs and their pipelines are having actually specific shaders for things like ray tracing. So those are coming. I think they're here to stay. I think folks will find maybe other use cases beyond ray tracing, but definitely here. And as far as, let's see, the compute pipeline or compute side of things, if I understand the question, I mean, I'm thinking about compute in terms of new APIs like Vulkan, for instance, which has compute pipelines. I mean, OpenGL does as well. Yeah, definitely accessible, definitely things I think folks are using. I think folks are trying to look a lot how to use compute, for instance, to just make it look like the regular language. So that would be interesting to see in D as well.
More questions?
So I believe the question on Bruce regarding compute shaders is pretty important because I have seen an increase in the usage of compute shaders on the gaming industry related to cinegraph building. So this can bring like much better performance. So I would guess this is a thing to start thinking more about now.
Yeah, if I understand the comment, yeah, compute, I mean, yes to all three, all are important.
Any more questions?
Hey, we're in sync. I think that's a no more questions scenario. Yeah. All right, well, thank you there. All right, we'll now have another swap of speaker. Up you go, mate. This is lightning talk territory here, so I will put the 5-minute timer on again. Ah, 2 hours left. How are we all feeling? Yeah, there we go. That is the liveliest anybody has been all conference, and you sounded like a zombie. Maybe for the photo, we should just have the zombie later on. Like, yeah. There we go. Oh, it looks like we're ready.
All right.
Ready? Yes, we're ready. 5 minutes starting now.
Okay. So this talk is about a small improvement I made to my workflow in the last half year, I think. And it's a thing that I've been thinking about for quite some time, having in my daily programming with D. So how many of you are using on-the-fly syntax checking, at least in your everyday working experience with D? Okay. And how many of you are using VS Code, opposite to other? And how many are using Emacs and Vim? Okay, so it's about equal. So this talk, fortunately, the tool I'm about to present you is completely agnostic of the editors, so there's not going to be any fights here, hopefully. So syntax checking is probably something we've been all aware of, exists, and it's a very useful thing to have when you're developing, so it catches lexical and syntactic errors, and in the case also semantics. So if I mistype something here, you can see that in the bottom here I got lots of errors, and this is the variant fly check with an extension in Emacs, which is very convenient because you can click and navigate in various directions here. And it's also, so this is a lexical error. This is often instant and large code bases. And if you do like that, it's going to be semantic error, but it's going to be, what did I, that's strange. Didn't I catch? Okay, hang on. So this didn't happen before. This was very strange. Okay, hang on, I'm just going to check one thing here. Okay, so that seems to be none. Okay, so the thing that I want to present to you is an extension of what kind of errors it catches here. So obviously lexical and syntactic and semantic analysis, something we want to have on the fly. But what about tests? So there's been a couple of extensions to fly check that does this. When the idea is that not only does it do the checking via the -o-, flagged via DMD, it also runs the unit tests and overlays in the output the result of those unit tests if they fail. So what we can see here is that if I change this value and save, hopefully I'm going to get an error. So this is strange. Why didn't I? So am I using do I have a syntax error? Yeah. Oh, okay. Oh, okay, sorry. No, I forgot to remove that. Sorry, thanks. Okay. So now we're back to business. And hang on. Oh, it's... oh, okay. Oh, sorry. Okay, that's the reason. Yeah. Okay. So if I change the value here, we don't have any syntax error, but we obviously have something that fails the test, right? So, and this is not new. It's just that the diagnostics is, in my opinion, what I've seen quite new. So what happens here is that it shows you not only that what the line failed, but also what the expected and the actual value is, which is very, very useful. Okay, tests.
1 minute.
Moreover, what about if we change this to 0 and then remove this code? So what would we like to have in this case? Well, we don't have any coverage on our sources, right? So what if we save here? So what happened now is that what was executing was not DMD, but a wrapper script that I've constructed in D that basically compiles the code with -main, -unit test, -coverage, runs that test, parses the output of the LSD files, and converts that to compiler diagnostics. And then you just feed that as an argument to your syntax checker instead of DMD. So this is completely agnostic to any editor. So under the hood, it does everything and presents the data, the results, as compiler diagnostics.
All right, we can do a question or two. Do we have a question or two? Oh, then two simultaneously.
Yeah, the tool is available in my GitHub repo.
That's a question? All right. One question.
So the tool is, it's my name, Nordlow, Nordlow -xdmd.
Okay, I've noticed that when you show the example when your test failed, you get an exact message with the comparison that failed with the values specified. When my test failed, I only get a message, assert failed. Is there anything that's...
There's a flag for that.
The flag in the compiler?
Yeah.
Why did I not know about that? What flag is it?
Yeah, it's an awesome flag. I use it everywhere. I don't remember it. Check action context. Search for that in the DMD manual.
All right, let's call it there. Thank you, Per.
You're welcome.
I think I mangled the pronunciation, sorry. All right, we've got just over 15 minutes until the next talk, so be back here 3:30. Alrighty, we're ready to get back on the road. Maybe not everybody in the crowd is. We've got a first-time DConf speaker up here. Check it out. All right. So, how you feeling? You feeling good?
Yep.
Anxious?
Nah,
Panicking?
not yet.
Not yet. All right. Well, the good news is, nobody here is going to, make you feel like you should panic.
Yep.
But yes, Ludwig is here to give us his first DConf talk, so take it away.
Thank you. So, greetings everybody. My name is Vladut, and I'm going to talk about DScanner migrating from lipdparse to DMD-as-a-library. Now, before I begin, let me tell you a few words about me. I graduated just this summer from University Polytechnic of Bucharest. I completed a 4-year bachelor's program in computer science and engineering. I've been with Adobe for over 2 years now. I've met some awesome people here, and my main programming experience lies in the JVM world, so Java and Kotlin, but I also did plenty of other interesting stuff, such as operational work. Now, I got in through this project. To be more specific, in my 3rd year of university, I had to take an introductory course into operating systems and went to Răzvan Nițu's laboratory. And there he talked a lot about about how it is such a cool language and that he has some interesting projects to work on. And naturally, I was intrigued, and that's how I got here. Now, with that out of the way, let's begin. So what exactly is this DScanner? A static code analysis tool. Basically, it reads your code and gives you various insights about it. To be more specific, it's used to detect several bad practices or perform some style checks. Overall, I'd say it's used to detect questionable code. Now, DScanner is pretty feature-rich, offers over 50 code checks, and it's a pretty important project for the community. To give you an example, it is actively used in the Phobos repository, and the Phobos contributors take the warnings that DScanner generates very seriously. So let's take a quick look at DScanner's architecture. It actually uses a third-party parser called lipdparse that implements 2 compilation phases, the lexical and the syntactic analysis steps. And the way it works, it reads your code, it passes that code through those compilation phases, and it emits an AST, or abstract syntax tree. Now, this AST is passed down to the static analysis step, and the way the checks are implemented is using the visitor design pattern, and the way that works is the visitors traverse the AST, stop on the target node, and perform some checks there to emit some warnings about your code. Now, the objective for this project is to actually remove this lipdparse dependency and replace it with DMD-as-a-library. Now, since we're changing our compiler library, we can expect that those compilation phases will change a bit. We'll also gain access to a new one, the semantic analysis step. And obviously, since those compilation phases change, we can expect a different AST. And since we want to keep the same behavior going on in DScanner, we're going to have to go through each check and migrate it so that it can actually detect the same warnings on this different AST. Now, why exactly should we use DMD-as-a-library? The most obvious reason is that it's going to be easier to tackle compiler updates. So to give you an example, let's say we reach the point where we implement deep 9999 in the compiler, but before we can start using it in our project, we're first going to have to replicate those changes in this lipdparse dependency so that we can go ahead in DScanner or any other project for that matter and upgrade the library version so that we can start using it. Now, if we actually use DMD-as-a-library, we can bypass this whole intermediary step of having to keep the third-party dependency in sync. Another important benefit that we get from using DMD-as-a-library is that we gain access to its semantic analysis step. Now, semantic analysis is a fairly difficult compilation phase to implement. You need a lot of information about the code. And while you can go ahead and implement some parts of it so that you can use in your project, still going to be fairly limited compared to what DMD-as-a-library has to offer. And since it's already implemented, why not use it? Now, this will allow us, at least in DScanner, to implement more comprehensible checks. And to give you an example, think of string mixins. Without semantic analysis, all you can see is a string expression, but with semantic analysis, we can actually extract more meaning out of that expression. There's actually an additional bonus for DMD-as-a-library. Now, DMD-as-a-library has only been out for a few years now, so it's in early stages. The compiler interface still changes. Sometimes those changes are breaking changes that break our code. But by using it in a project that's actually used, we can get some real data about how this interface should look like. Now, let's take a look at what has been done for this project. Before me, Lucian Dănescu has also worked on the same project. He also held a talk about 2 years ago at DConf, where he talked about integrating DMD-as-a-library in DScanner. And he focused more on showing what DMD-as-a-library has to offer and how several checks work. If you haven't seen the talk, I recommend that you do. Now, I started working on this project in the fall of 2023, so about 1 year ago. And when I started, 24 out of 54 checks were already migrated to DMD-as-a-library. A few other checks were almost finished, so there were several pull requests open that I had to merge. And the code infrastructure for using DMD-as-a-library was already there. And by that, I mean the code necessary to parse modules using DMD and run the DMD checks. Now, if you take a look at the work required, I can say that I started working on this project when it was about halfway done, so a fair 50%. Now, what I've done is I have actually finished migrating those checks to DMD-as-a-library, and I also did some other boring stuff, maintenance work, such as upgrading dependencies or improving a unit test here and there. If we go back to the work required chart, I'd say I've done about 49% of what was left to actually integrate this in the upstream, but there's still about 1% left that I'm gonna talk about later in the talk. I actually went ahead and benchmarked the changes that we made during our migration on my personal laptop by running this scanner on the Phobos source code. And actually, I've noticed an improvement in around 15%, so maybe 2 seconds by using the library as opposed to lipdparse. Now, whilst Lucian's talk was more focused about showing the details of DMD-as-a-library and showing how several checks work, what I'm going to show you instead is what our workflow looked like, several challenges we have encountered when dealing with DMD-as-a-library, and the efforts necessary for keeping up with the upstream. So for our workflow, we followed a pretty standard model of open source collaboration. We have forked the official repository, we made our own main branch, and we also had to update our build files in order to include DMD. Now, for the migration process, we had 2 main concerns to keep in mind. First is that whatever checks we migrate, they still work as expected, so we don't break anything. And at the same time, the changes that we are bringing in do not affect other areas of DScanner. So for that reason, let's take a quick look at the flow for analyzing code in DScanner. It starts from the code, the module is parsed, then the specific checks are selected based on what the user configuration looks like, and then those checks are run. What we did was actually we cloned this exact flow, but made it work with DMD instead. And we kept the same, both flows running in our program, so whenever we migrated the check, we simply moved it from the lipdparse flow to the DMD-as-a-library flow. Now, for our testing pipeline, we have used GitHub Actions, and we have decided to do whatever the upstream DScanner is doing so that we have an easier time integrating our changes with the upstream when the time comes. And for that, we had to make sure our application could actually compile. And we did that on a combination of platforms, compilers, and build systems. So think of Windows, macOS, Ubuntu, DMD, LDC, GDC, Makefile, Dub. After that, we made sure that our unit tests pass. And we finished off the pipeline with integration tests. Now, the integration tests are actually implemented by running this scanner on the whole Phobos repository. Since I said in the beginning that these kind of warnings are taken seriously by Phobos contributors, we should expect that a clean DScanner run should not generate any additional errors on the Phobos repository. And this is how a successful pipeline looks like. Now, let's take a look at a few challenges I've encountered when dealing with DMD-as-a-library. The first one is that it's not always intuitive when you have to go and read the code, and since you don't have documentation, you're going to have to dig through the code a lot. So to give you an example, I had to look for the function parameters, and naturally, I thought I can find the parameters in the function declaration AST node. And there is actually a class field here that says parameters, and the DDoc says array of var declaration for parameters. However, when using it in my code, I actually find out that this is null, and it only gets initialized after semantic analysis. So I started digging back in the code, but it was starting to take quite some time, so I asked Răzvan for help. And we looked in the parent class, which has type field. And for our functions, this is actually a type function. So not only it contains the return type of the function, but it also has the parameter list. Now, there's been another issue when dealing with DMD-as-a-library strings and the D strings. Naturally, as a D applications developer, I just want to use D strings and not worry about anything else. So immutable char arrays. However, for example, if you need to get the string representation of an identifier to see, for example, a variable name, there's this convenient toString method that returns a const char array. And if you want to use it in your code, you're going to have to perform a cast. Another issue I found is that there's a lot of external C++ in the DMD-as-a-library classes. So if you want to use those classes in your code, you're going to have to external C++ as well. But if you want to use D strings in your function parameters, you're going to have to external D. Now, this is not necessarily a big issue, but it can pollute your code if you have a combination of the two, where, for example, you have a check where you have to work much more with strings. There have been a few checks that we have deleted as a consequence of using DMD-as-a-library. The float operator check and the comma expression check are actually two checks that warn against the usage of deprecated language features, but those features have been deprecated for quite some years now, so DMD-as-a-library will not consider this valid code. It will actually throw a compilation error, and that compilation error would break our application when we would try to parse the module, so we had to delete them. Another check we have deleted is the state attribute check. It looks for two of the attributes on functions. But again, this is now a compiler error. The code will not compile with two of the same attributes, and this will also break our code, so we had to remove it. There's an additional check that we removed that's related to the if statement check. This actually warns against redundant if conditions in nested if statements, but it was actually disabled in 2015 because it was generating too many false positives and hasn't been touched ever since. And in order to clean up the code base a bit, we have decided to remove it. Now let's take a look at the efforts that were required to keep up with the upstream. Rebasing. So we monitored the changes that were going on in the upstream project, and we were noticing many of them happening, so we thought it would be a better idea to rebase at the end of the migration so that we don't have to work that much. However, we reached a point where our testing pipeline would fail due to some conflicts with dependency versions and compiler versions, and the upstream repository did not have those type of issues, so we thought that we can rebase the changes that were made in the upstream repository so we can fix our pipeline. And on January 29th, a rebase was started by Eddie. If you're wondering why it looks closed, it's because he used this pull request only to test the changes he was bringing. And during this time, I was kind of stuck with merging my checks. So I was chatting with Razvan, and I was asking, hey, how long is this rebase going to take? And Razvan was like, don't worry about it, just a few days. After a few days, I'd ask again, how long will this rebase take? And he'll just say, just a couple of days, don't worry about it. Eventually, the rebase was finished by this commit on 19th of February, so about 3 weeks. Now, the reason this rebase took so long is because besides other small changes such as bug fixes or test improvements or small features, some refactorization was performed in DScanner that changed the constructor arguments for all of the checks. So Razvan and Eddie actually had to go through each file and make sure that they only bring the changes that we are interested in and not the constructor changes. Another issue when trying to keep up with the upstream we have encountered is that DMD-as-a-library updates a lot, and sometimes those updates break our code. There are a few checks in DScanner that look for redundant parentheses, and conveniently enough, there's a parents field in the expression AST node that tells us whether or not the expression is parenthesized. But it got removed from the node by Walter. The purpose was that it wasn't necessarily needed, and in order to clean up the code, it was removed. However, this not only caused issues in our code, but also caused some other issues in a bug regression regarding string concatenation, and Theodore reverted this change, and we could fix our code then. There's also an issue regarding our integration pipeline, so we had to show our pipeline works in order to be as close as possible to the upstream. And in order to use DMD, you're first going to have to generate some configuration files, so the sysconf dir and a version file. And when you install the DMD compiler, those automatically get generated for you. But if you want to use it in your code, you're going to have to run a small config file in order to generate those. And with LDCM DMD, you can actually run those files on the fly without worrying about an executable. But with GDC, you cannot do that. So we had to fix our makefile in order to create this special case for the GDC compiler so that we generate the binary, execute it, and then remove it. Now, let's take a look at the conclusions for this project. So as for the missing 1% I was talking about in the beginning and future work, I got to fix autofix. Autofix is a feature that has been added in DScanner that allows you to automatically fix your code in place so that you don't have to manually go there and fix it yourself. The no-lint user attribute, this is actually used for only a few checks, so it shouldn't take that long. It's actually used to disable linting at local scopes. And there's a new project idea that we use semantic analysis in DScanner and implement some cooler checks. Now, as for proper conclusions, DMD-as-a-library is actually usable, and the proof is this project. Obviously, it's not in a perfect state, but you can go ahead and build awesome tools with it. DMD-as-a-library could benefit a lot from public and proper documentation. At the end of the day, yeah, you can still go and search through the code and find your answers there, but it's much faster and much easier to open a public documentation page and find your answers there. And once we integrate those changes with the upstream, we invite you to go test them out, report any bugs you find, and maybe you can even come up with new ideas or just tell us whether you like it or not. As for some personal thoughts, I believe compilers are fascinating. It's awesome to see the journey your code takes from text to a bunch of zeros and one. And I think it's even more fascinating that you can hijack those compilation phases to build tools that are only designed to improve the life of developers. I believe D is a cool language, primarily because it's not that opinionated, so you can shape your code purely on your need. And rebasing is not fun at all. Now, I'd like to end this presentation with an open question, whether or not is it a good idea to share the same code base with the compiler. Because from the perspective of a library user, you just want to get the most out of that library, and at the same time, get long-term stability, so little updates or updates that don't break your code. But if we look at it from the perspective of a library and compiler developer, you don't want to have to maintain many features that your users come up with. And with long-term stability, you lose your freedom to freely refactor the code as you see fit in order to improve the compiler code base. And if we pair this up with the additions coming up, I can only imagine the amount of work a compiler developer has to go through in order to keep track of all of those issues. So that would be it. Any questions?
What are some of the differences between DScanner and LDC-lint?
Between what?
DScanner and LDC-lint.
I'm not sure what LDC-lint is. I haven't checked it out, so I cannot say.
Okay, me neither.
So did you mention a performance benchmark where you compare how long it takes for the decompiler to do a syntax check opposite to, or a syntax semantic check opposite to what DScanner takes? Because you only compared against lipdparse. I was just curious, what is the overhead of running DScanner inside the compiler by default?
Sorry, can you ask the question again?
What would be the overhead of running all these checks inside the decompiler as a default? Is that something you measured?
I don't think so.
Yeah.
So maybe I can think about it, but I cannot even come up with an estimate, maybe just a guess.
Okay. So one other question. So last time I looked into DScanner, it has a separate pass for every check. Is that correct?
A separate what?
A separate visitor for every pass. One thing that I experimented with detecting unused variables a couple of years ago in DMD,
And I came to the conclusion that it would be very nice to have some kind of high-level API to the visitor where you can feed inside the visitor a set of transformers or checkers on the AST, so you don't need to traverse the AST over and over again, because that would give better memory locality. The problem is that maybe some of these visitors modify the AST. But I think in a very long, if I were to design a compiler, I would have this in mind. So be able to pass a set of transformers or statistical collectors to a set of a parameter that's applied to each node in just one pass.
So I did kind of think about it, but at least in this scanner, I don't think we mutate the AST in any way. But in order to, let's look at the extreme example where we move all 50 checks in a single visitor. It's so much state and so many things that you actually have to care about, and you're going to have to visit pretty much the whole AST in order to cover all the checks. And this would take out the freedom for the user to choose what checks to run. So if you only want to run 2 checks, you're still going to have to visit the whole AST. So I'm not sure whether or not that's a good idea for the user. And regarding the state, like, there's so much state that you have to keep track of. I wouldn't say it's impossible, but the code would be very ugly.
Okay, thanks.
So I can answer about the LDC lint part. First, the biggest thing is that this scanner is usable in production and LDC is not. LDC lint is not. And another thing is that the scanner runs the whole semantic phase again, and the LDC lint, the main objective is to run as part of the compilation phase. So you compile and then run the linter after compile.
I was just wondering if it would make sense to add this to the list of projects that get checked in CI for DMD so it wouldn't break.
Yeah, we talked to Razvan and we think it would be a great idea, but once again, it's the compiler developer against the library user. Do you want to include any other projects that come up, or?
Well, we'll see. I don't think there's going to be that many projects using DMD as a library. I'm planning to write one myself, but yeah. I think it makes sense. I mean, we could maybe do some log-sec changes in the compiler and then this so that we can transition things.
Yeah, I think it would be a great idea.
So my question is why DMD as a library code is not being shared with the compiler right now, because this would make things way simpler and also always up to date, and even every benefit the DMD as a library has, the decompiler ought to have to.
So is your question, why is DMD as a library not sharing the code with the decompiler?
Yes.
Well, they do. They are the same thing.
But you said you right now has to rebase every now and then, and I was thinking if that's not just a build configuration that could be applied to the upstream code.
So when I talked about rebasing, I was talking about the changes that were going on in the DScanner, the official DScanner repository. So changes that are related only to DScanner. And DMD as a library is another issue. It only receives updates. That's it.
Yes.
But it's the same exact code with the decompiler.
Okay, thank you.
All right, do we have any more questions? Going once, twice. All right, looks like you're done. Thank you.
Thank you.
Now, we've only got one more talk, don't we, Mike? That's at 4:30.
Yeah, but we can do it earlier if Razvan's ready. Yeah, how about we say 4:15?
4:15. You guys have 20 minutes then. Have fun. All right, everyone, get back upstairs. It's the last talk of the conference. You don't want to miss it. Maybe you do. I don't know. People don't want to miss your talks, don't they? They like your talks.
I hope so.
Yeah, well, you keep on coming back for doing more talks. What's this, like your fourth now?
I don't know. I stopped counting.
So I think your first one was in 2019, wasn't it?
2017, I think.
2017, yeah, in the before days, before Corona.
Yeah.
Ah, jeez. Ah. I've had enough bad jokes for the day, please. Just no more. All right, so Razvan, bona fide D legend at this point, I think. He's involved in everything, and now he's going to give us a talk about D features, complexity versus benefits. So take it away.
Thank you. Yeah, so for those of you who know me, I'm Razvan, and yeah, initially the title of the talk was kind of different. It was kind of more pretentious, but then I just realized that it can be made much, much simpler, and the short version is D features, a rant, right? So prepare yourselves. Yeah, but before we go into that, a few things about me. So I've been contributing since 2016. I've been a pull request and issue manager since 2021. In early 2023, I finished my PhD. I'm also an associate teaching assistant at University Polytechnica in Bucharest, and I try to kind of preach D to students. And as of this year, I'm also a software developer at Chinopi, which is a software company that tries to tackle disinformation. Okay, so now let's get to the interesting part. So every line of code you adds complexity, right? And that is also true for the compiler. But that's okay. Like, the complexity is justified if there is some benefit, right? Some return on investment. But since I've been a part of this community, I've seen that a lot of features where, at least from my opinion, it seems that the return, what you get from that feature, is much smaller than the investment that goes into it. Like, there are some features and people get like very, very opinionated about them and they want them to go in certain directions. But at the end of the day, it just feels like the complexity that they add in the compiler, it's just doesn't worth it. And for the rest of the talk, I'm just going to give you some examples. Some of them are like big features and popular features. Some of them are like quite niche, but I just want to show that like the main point is that every line of code we add to the compiler adds some complexity, and it has to be justified. There has to be like some big benefit out there, and we have to have some people that actually benefit from it, and not just implement stuff and then go on and say, well, you know, if you don't like it, just don't use it. Now, I'm quite curious. How many people have heard about the line directive? Okay, quite a few. Did you know that we also have it in D? Okay, so it was implied that in D. Okay, yeah, well, there are a lot of people that don't know about it. So essentially, you can just like use the hashed one. Is that all of the error messages that you get? I don't know if people can see it. Basically, at line 6, the compiler is going to treat it as if it's like line 100. And you might ask yourself, like, why do we need this? Like, what use case could possibly arise? And sorry? I can't hear you. Yeah. So the thing is that essentially, like C's preprocessor, like when you include it, you include a file. If you have an error in that file, essentially you want the compiler to output an error at the line and the file name where in the file that you included and not in the file that the file was included. Does that make any sense? Okay, so, but like in D, we don't have includes that way, so why do we even have this? Yeah.
It's used extensively in diet templates for Vibe. So you have a diet template, it's kind of a different language, and it transcodes that into D, and it puts the line directive so when you get an error, it goes right back to where your source is.
Yeah, sure. I mean, I guess you could find some use cases, and also it's used, I mean, the only uses that I've seen is in DMD's test suite, right? So you put hashtag line 1000 in this case. I mean, that's essentially all of the file. I don't understand why you would do this in this case. Like, I know that, of course, so how things work for those of you who are not familiar with the code base, like you have the test output and you have like a script that extracts the test output and then it runs your code and it makes sure that the output is essentially the same with what you have, right? But I mean, if you didn't have line 1000 then you would get, yeah. I know what you're going to say, but yeah.
Well, you said you didn't know why. You said you didn't know why, so.
Yeah, were you going to say that if you have like large files, you can just, and you add some code, you don't want to modify it?
Yeah, it reduces the diff when you add more error messages, which go in the top, and push everything down so it changes all the line numbers, and you got to fiddly fart around with it.
Yeah, okay.
So when you see the diff, all the error message lines have changed, except the only thing that changed was their line numbers. So this is an attempt to reduce the diffs.
Yeah, but I mean, when you look in GitHub, at least, it's just going to show you only the code that you added, right? So, and we do have a script that automatically fixes these errors for you, right? So yeah, and you can just run it, right? So I really don't understand why a line is used, and I actually hate it because when I review code, I have to, do math in my head to find the actual where the error message should be, and sometimes it's really not that obvious. So it really kind of makes my life harder. So if this didn't exist for me, like it would be great, and we would. I mean, it's really not a big deal. It's not complicated to implement the compiler, but still, I feel that the return on investment for this is. Like you're not really, we're having a feature that really isn't that important. So, and it's actually used quite a lot. So it's used like 339 times in the test suite. And yeah, I noticed that you are the only one that uses it, Walter. Okay, so moving on, another thing that, another feature that I don't really like is on mass attributes. So essentially, you have the possibility of putting at the top of your file, or actually everywhere you want in your file, private, no throw, or any other attributes, and those are going to apply to all of the declarations where it makes sense to apply them, right? So the function is going to be private and no throw, the class is going to be private, and the struct is also going to be private. So this is very, very annoying. Like if you're in the middle of imagine that you are at line 2000 and there's like, I don't know, a safe annotation or a no throw annotation at line 5. You essentially have no idea of that, right? You're probably going to discover it, but this has bit me in the past. So at some point I was fixing a bug where some private symbol was, so it was essentially something like, you could access a private symbol if it was selectively imported, right? So, and I fixed that, so you weren't able to do that. And there was this project where I was getting an error, and it looked like a public symbol could not be accessed anymore because of my patch. And I wasted some time until I realized, well, like that symbol was defined somewhere at line 1000. And I realized that there was a private somewhere at line, I don't know, 700 or something like that, right? So I really don't get, I understand that it's easier, like you can just annotate with trusted an entire file, and then your code is going to compile and it's going to be safe. But I just don't, that's just not good practice, right? And it makes it much easier to have all of these attributes or access specifiers at the declaration site for the person that it reviews it. And yes, it makes it a bit harder for you because you have to annotate it. But there was a famous quote last year from Attila. He said, "You may not like to wipe your ass, but you just got to do it." And I feel that this kind of applies in this situation. And you see, complexity has a way to kind of breed complexity, because now, because of this, people are arguing that, you know, we should also add impure to the language. We should also add GC, because what if you have like this en masse attribute and you have like one declaration and you know that uses a GC? It's like super hard to copy paste that declaration somewhere outside of the unmasking. You just need, you know, another attribute for it. So from what I've seen, like you have these features which have questionable value, and then people just start building things on top of them, even though like the alternative is much simpler. Like, I'm just curious, who here for who here not having this in the language would be a deal breaker? Like, you wouldn't use D anymore. This is like a super small thing, but we have it, it adds complexity, and like the value is kind of questionable. Right, so moving on. Oh, okay.
I think master attributes are very helpful, for example, when I'm writing safe code, and I want to ensure that my entire code base is as compliant with safe where it can be. And in case I forget the attribute, it's actually going to bite me in the ass a lot later. And this actually helps me catch it very much earlier. And so I do think it's helpful. Essentially, it actually ensures that my code that is supposed to be memory safe stays memory safe. But in my case, I always stick it to the very top of the file, so I will agree with you when it happens in the middle somewhere, all right?
Yeah, I mean, you can argue either way, but it really depends on how you approach things. Like, for example, maybe it's a very unpopular opinion in this room, but when it comes to safety, yeah, I mean, we're not in that really good shape, right? So my point is, like, if you really need memory safety and it's critical for your application, like, you might as well use Rust, right? So yeah, so I mean, I get it. Like, people argue for all sorts of things. I know that what I'm saying is controversial, but yeah, I'm just trying to provoke people to kind of see beyond. Yeah. Sorry.
Testing, sorry. A brief question on that topic. So in C++, for example, it's like a stylistic convention to have, like, in a class, like a private section and a public section. Do you have the same feeling about that usage?
Yes. Yeah, just put private everywhere.
Okay. More like Java style.
Sorry, I didn't.
More like Java then.
Yeah. Yeah, I mean, I really don't see that much of a benefit in it. Yeah.
Sorry, I just want to say that the main use case for TIS is putting things at the top of the module, so we could just accept it on the module declaration, call it a day.
Yeah, I mean, that could work, but you will see that later in this talk, I'm also against attributes in general. Okay, now let's talk a bit about public and private overloads. So there's this long-standing bug. I think this bug might be older than some people in this room. And it's kind of embarrassing, at least from my perspective. So essentially, if you have like a file over.d and you have two overloads there, one is private and one is public, if you just import the module, you're going to be you're going to be able to call the private function, right? And this has been like, this bug has been like forever in D. Yeah. Now, when I saw it, it was like, I don't know, 4 or 5 years ago, I wanted to, yeah.
Well, yeah, that's a bug that can be fixed, but it's not. I'm not sure that means that there's a design error. It's more of a bug.
Well, it depends. Like, just let me go on a bit. So, I wanted to fix it, right? So the sensible thing to do here, so actually what happens here? So when the compiler sees like the invocation of fun, it searches for the symbol. If it's not in the module scope, it starts looking at imports. At imports, it sees that fun is defined in module over, and then it says, okay, I found a match. Now, actually, I found the symbol. Then, if the symbol is an overload set, it gets the most, then it just tries to match the function. I mean, if the most visible overload is private, then it says like, no, you cannot access it. But if the most visible overload is public, is accessible, then it goes on to the next step where it tries to do a function called resolution, right? And it sees that the private one should be called here. Now, how to fix this, what was missing is to add like, to check the access specifier after you've done all of this, and that fixes the issue, right? You just say, well, you cannot call it because it's private. But if you fix it that way, then you're also going to break public aliases to private functions, right? So essentially, in this code works today, right? So if you do a public alias to the overload set of gun, actually it doesn't even have, it doesn't need to be an overload set, right? It could also be like private void gun, and you do a public alias t, and then you just call t, and this should work. Now, when I tried to fix it with the previous fix, it broke this code. So this code didn't work anymore. Why? Because the compiler substitutes aliases eagerly, right? So when it found when it found t and saw that t is an alias, it immediately replaced it with gun, and then yeah, gun. Gun is a private symbol now. So if you do the check for the access specifier, you're going to end up with an error. And yeah, I would argue, like at that time, I was like, why do you want to, like a symbol that is private, why do you want to make it public for an alias? Sure, there are going to be people in this room and they're going to say, yeah, well, it's this use case and yeah, it works, but it just doesn't seem like a correct thing to do. But either way, this was the case. So still, we need to fix this bug, right? So an alternative to this would be to simply do not allow mixing public with private overloads, right? Or overloads that have different access specifiers. And that is going to fix the initial bug, because if the most visible overload is private, then obviously you're going to say, well, you can just access it from over too because it's private. And it also lets this code, I mean, this code is not going to work, but you're going to get an error that you cannot mix the private version of gun in the same overload set to the public version of gun, right? And you just put out a deprecation and you suggest to people that they, rename the function differently. That might be a bit complicated for constructor overload sets or special functions, but yeah, you can just rename them like that. Yeah.
Thanks. I don't think I understand the problem here. This should fail to compile as far as I'm concerned.
This example?
Yes.
What should be the error?
The error should be you can't call gun because it's private.
But you have a public alias to it.
Sure, but you can't call that particular instance of the overload set because it's private. The alias is public, but what an alias is isn't.
That's what I argued also. So, but there are people in the back that want to contradict you.
Well, the problem with them is they're wrong.
Who was first? I think you were first.
The error should actually be argument mismatch error, because we moved away from accessibility to visibility a while ago now. So when it does the resolution, it shouldn't even consider the private one. It should see it as a subset of the overload set that is only visible to it.
Yeah, but if it's not an overload set, like if it's just a private void gun and you make it public, should that work?
Okay, so the alias thing is another thing that there's literally thousands of lines in DMD to work around that issue. So if you ever want to fix it, I'd be very happy.
Looks like it's a good thing we had all this extra time for Razvan.
Yeah, so I was going to say, if you remove the public overload, then it should be, it is an error, right? Because you try to compile with the...
No, it's not. Under the current rules, it's not.
If you remove the public
yeah,
and it's just a public alias to a private function?
Yeah, it works, yeah. It compiles.
Really? Yes. Okay. Things have changed then, I guess.
I think it has been so for some time. And the same problem applies, like, for example, if you have a templated function which receives an alias, template parameter, and you pass like a function which is private, then with the check that I implemented, you would get an error, but right now you don't. And I remember you, Matthias, arguing that this code should work, like if you have just a private overload. Like, you are the one that closed my PR. So I'm really glad that you changed your opinion on that. Yes.
I mean, I have to side to some extent with Razvan here. I'm not sure what is the use case for a mixed visibility overload set. On the other hand, of course, you can merge overload sets from different modules. And then there's a question, what does it mean for the visibility to be compatible?
Yeah. Yeah, see where I'm hinting at. Yeah, so anyway, I tried this solution with not allowing public plus when things, in my opinion, start to seem that they're very complicated, like, just do the most restrictive thing, see react, and then maybe see how you can extend it in a way that makes sense and doesn't add too much complexity to the code base. Because, yeah, I tried disallowing this mixed qualifier thing in the overload set, and like all hell broke loose. Like, there were tons of projects on BuildKite that were failing. So, yeah, and I remember your comment, Matthias, where you said something like, looking at BuildKite should give you a pretty good idea why this is a bad idea. But still, I think it's the sensible thing to do. And we can figure out like the thing with the alias and merging overload sets. Yeah, either way, moving on to the next topic, like mixins. So if I got some pushback at when I talked about the line directive, I'm really wondering what's going to happen with mixins. So my main problem with mixins is that they tend to get complicated. Like, whenever I think of mixins, I think like, well, I don't know, you just go on the street and you just leave guns, like automated guns. And yeah, some people will just use the guns to defend themselves, but there's probably going to be a lot of people that they just, they take the guns and they start shooting people. So I actually, the code is too little. Oop. So this is actually the implementation of bit fields in the standard library. So I don't know if you used bit fields from the standard library. So it's basically a templated function that returns a string, and you're supposed to mix in the string that the bit fields function returns. So it's a very clever way to kind of allow bit fields at the library level, but like, look at this code. Like, if you want to maintain it, if you have to maintain this code, I really, yeah.
Testing. I've had similar problems with the mixin using strings, and I've tried to use like the mixin template, which has better syntax checking wherever I can. Although I found some places where I can't. Like, for example, if I need to declare a variable that is related to, or to make a function that's related to a variable. Like, let's suppose I have some annotation that when processed will make a cached version of a lookup function, and I need a way of declaring a function based on the name of the variable. Like, using mixin template, I'm not aware of a way to do that.
Yeah, so the thing is with mixing templates, you do have some visibility issues. I don't know exactly what the state is right now, but sometimes it happens that you mix in some functions or some variables, and the compiler just kind of fails to see them when you try to access them. So I don't really have an answer to your question. Yeah, was there? Yeah, my only point is that if you go crazy on mixins, like code ends up like this, but on the same time, I understand that they're very powerful, and they're actually used a lot in Phobos. And if you're using mixins for like small portions of code, it makes sense. But if you're going to try to, I don't know, generate a lot of things, then things are going to be a bit wild. And there's a lot of issues with mixins. So I counted like 234 Bugzilla issues. Yeah, there are some questions. Walter and Robert?
Yeah, the observation I think what you were getting at is you know the trade-offs. What's the benefit, right? Cost benefit. Kind of
Can you please repeat the question because I wasn't seeing it?
Yeah, it's a cost benefit thing, right? What I will observe about mixin is that mixins can actually be the most readable solution in certain settings. For example, if you're in a leaf function, you know, generating something code and it's like the last level of elaboration or extension, right? Then it can be incredibly readable. But of course, the problem is that you're on your own with respect to basically the type system says so long, sucker. I mean, it just basically you have to take over at that point, right? But this is a characteristic of anything that is sufficiently general as an escape hatch. Whenever you have an escape hatch kind of functionality like this, it's certainly tempting to abuse the hell out of it. And so, yeah, I kind of feel your pain a little bit, but I wouldn't want to see it go away.
Yeah, sure. So I'm not advocating to, apart from attributes, which is the next thing, I'm not advocating that we just like delete these features. I'm just trying to point out that all of these features, they add like complexity, and in some situations, it's like really hard to deal with all that stuff. And an alternative, like up until now, our approach to this was like, yeah, we're flexible. You can do whatever you want in D, right? We're supporting everything. And I'm thinking that, yeah, but this has led us to this point where we have like a lot of issues and a lot of our language features don't actually compose very well. So I'm just asking, like, maybe it would be better to just start off, you know, with a subset of what you want to implement and then see how things go. Yes.
So this is one of the use cases that we targeted for interpolation. And we should try and figure out a way where we can use interpolation directly instead of having to pass it to text so that it runs a bunch of CTFE. But yeah, that would make that file a lot more readable because you could use token strings and make it just syntax highlight everything.
Yeah, indeed. But there's also there are these issues with forward declarations, right? So you see this example here. And currently, it's not, I mean, there is a solution, but it's not quite obvious. So what happens here is that this is going to be an error. So B is going to be an undefined identifier, because when the compiler searches for B at module scope, it just sees the mixin, right? And yeah, a solution to this would be like, just do a different pass where you're just expanding mixins and static if and yeah, static conditions and so on. But yeah, that adds more complexity, right? So yeah, Walter?
Oh, well, yeah, that was, I've been long aware of this problem, and that's what string interpolation was supposed to mitigate. I've also written my own little function that runs in compile time that will that produces a string as output and makes it easier to read. So, you know, there are solutions available for this. But I looked at the C++ one, that's even worse. So I don't think we're in terrible shape here.
Don't ask for questions, just enjoy your talk.
That was definitely worth waiting for. Thank you, Robert. Please continue.
Okay, so moving on. This is like the star of the show, alias this. So I don't think there's a feature that since I've been contributing, gave me more headaches than alias this. So let's begin. Like, I don't know if everyone is familiar with alias this, but how it is branded is like manual subtyping. So essentially, if you have like this object, let's say it's like an object in some sort of in a library, which has some functionality. In this case, like it just has a field, and you want to kind of wrap that struct. But also add like some other functionality, right? You basically want to extend it somehow. Alias this gives you this possibility, right? So you can just declare, you can just declare a my wrapper, and then you can use it as if it was like a library struct, right? And if you would have added like other fields and other methods, you can also use those, right? And this is probably immensely useful in some situations. But because alias this wasn't, I mean, I don't really know the history of alias this, but it seems to me that it wasn't properly designed because you don't really know how it interacts with other features, right? So for one thing, like, let me give you an example with classes. So alias this works with classes, but on the same time, like, we don't have multiple inheritance. Right? So multiple inheritance is not defined in D. But now, if you use alias this, then you suddenly have undefined multiple inheritance, right? Why I say undefined? Because you don't actually know how all of this is going to work, right? So in this example, you have like a class which has a function, and then B, which is a completely different function from A, which also has it. And then you have C inheriting from B, but you also have like a field A, and you manually subtype it, right? Now, when you call c.fun, which fun should be called? I mean, this is not defined in the D documentation, right? So it could be argued both ways. So yeah. Sure, this could be defined, right? We can talk about this, but if we don't want, multiple inheritance in D, why do allow it with alias this? Yeah. Ivan.
I mean, we do have multiple inheritance in D. It's called multiple imports, and we actually solved this problem there. And I think we should use the same solution. And the reason why we don't is not breaking code. So we should do this in addition, I think.
Again, I think, yeah, every problem has a solution, right? But you're still adding complexity to it. And I'm not convinced that, I mean, I know that Walter is against multiple inheritance, and I'm kind of with him on this. So.
You're not adding complexity by using an existing rule somewhere else.
Yeah, I mean, not from a maybe not from a design perspective, but like from a code-based perspective, you will need to add some code, right?
You will need to delete a lot of code in this case, and reuse the existing one.
Yeah, still, this is like one aspect. Oh, Walter?
We got a question here first.
Okay.
I mean, to my knowledge, because I've done this once, actually using alias this inside a class issues a depreciation warning.
It used to. I made a pull request, but it was reverted.
Okay, then never mind.
All right. What alias this does is very important. The problem is we screwed up with it. The first thing is the syntax. I can never remember if it's alias this A, alias A this, A equals this, alias this equals A. I could never remember it. The syntax is absolutely terrible. The second thing is, since it is basically inheritance, I don't think it has any place in the class hierarchy, and it shouldn't be there, but it has a place in struct. And I would change the syntax of it, so instead of alias A this, you would have struct C colon A. and then it's
Yeah, so it's basically inheritance for structs.
inheritance for structs, and then suddenly everybody knows how it's supposed to work because it's something familiar rather than something peculiar.
Yeah, yeah, that works.
Yeah.
Yeah, sorry, yeah.
I just want to say for the record, first of all, if you have struct inheritance, there are some rare useful cases that absolutely should not change this or stop this going forward. But occasionally it is useful to be able to either access the fields or the entire structure of a member. Also, I just looked it up, and very, very technically, this is actually defined behavior. It's going to access the function from the parent because alias this is only invoked if the lookup is otherwise undefined. But you are completely right about this being terrible.
Yeah, but I mean, I don't want to make this about let's fix alias this for classes. Like, yeah, that's a problem, and it might be fixed. But then there are other problems. Like, there's also this very old bug. So with overload resolution. So if you have a struct and you have like an int and an alias this to it, and then you have like two overloads, one that gets an int and the other that gets a const s, and then you call foo of s. Which overload should be called? Yeah, the first. Why the first? Maybe the second. Why not the second? Because it's a const conversion. It could be argued both ways, right? But if you look at the compiler, like the compiler has a very simple matching strategy, right? So, for example, if you would call foo with a const s, then it would be like an exact match, and that would be preferred over all of the. If you have two exact matches, then you're going to do an error, right? In this case, what the compiler does, it tries to convert s to for the second overload. It sees that it is a match constant. So match constant is like you have the same type, but it needs to be promoted to a const qualifier. The convert one is where you actually do a conversion, right, from one type to the other. So what happens here is that the alias this is an exact match, whereas the s, the actual instance, is a constant match. So what is it's going to call the first overload with the alias this, which, at least in my opinion, it's surprising. But I know that you can argue both ways. But I would expect that indeed, like if you follow the compiler, like a constant conversion is superior to a convert. So the problem here is that when you are matching functions with alias this, the compiler doesn't consider it like a convert match, which it should be. And I tried implementing that. A lot of code started failing, like breaking changes. And there was another approach to this, like adding a new, yeah.
Yeah, you've been talking about, you had an earlier comment about the general thrust is about complexity and relative value. And just noting a couple of things. One is that there are two different types of complexity. One here is, you know, like it's a bear to do in the compiler, right? It's a mess. It's hard to do. Bugzilla has this, you know, 2-decade-long list of screw-ups, right, or something. And that's one complexity. And the other is the complexity as presented to the user of the language, right? Is it immediately assimilable? Could you immediately quote the rules, you know, that kind of thing, which you're revealing. So my observation here is that this is, in fact, the hard work, I believe, of language design. This is the hard work, which is power, you know, you want power, you want readability, right, and you want simplicity. And it's just readability and simplicity kind of related. And I guess composability, as you've mentioned earlier, but it's the hard work, and I'm really hopeful that the additions thing helps us go forward. But I've heard additions cited so often that I'm just thinking this is some Kool-Aid. You know, I mean, I don't know that this is going to work. I hope it does work.
I'm going to touch on additions in a bit.
I really hope it does work. But this is the hard work, and I'm especially happy to hear things like Timon's suggestion, this doesn't change anything, you can remove stuff. You know, those kinds of things are to really be praised. And I'm happy that you're turning it over, that you're, in fact, you've actually energized a few people here, I think. This is good.
Matthias?
So if we were using classes here, so class S with a parent class of A, and the first overload was A, and the second was const S, which one would be preferred?
Yeah, it would be the second one, because in that case, it is a match convert.
Yeah, so it should behave the same.
Yeah, but like I remember, like when I started working on this, people would say, like, you know, if you want to fix it, like think of if you had classes, what would happen? Well, I feel that that ship has sailed a long time ago. Like alias this has deviated so much from that, and it's like a lot of like happenstance semantics in many situations. And yeah, to go back to your point on complexity, the thing is that it's hard to tell whether the problem with alias this is that it wasn't properly designed from the beginning, or the fact that people like just came and said, you know, in this situation, this should happen, and they went on and implemented it like a special case or something, and then special cases started piling up, that it's really hard to tell what happens in certain situations, right? And yeah, coming back to this example, are there any other questions? No. Yeah, so when I tried to fix this, like there was no way, like putting it a match convert, I don't actually remember, but it broke like a lot of projects. And there was an alternative implementation where you add like a new matching level, which is like match alias this or something like that, which is under match constant, or between no match and match convert. I don't actually remember. But Walter was adamantly against it because, and I actually will thank you for that, because the match thing is very simple. Like anyone can understand it. You don't have to be a compiler developer, right? And this sort of simplicity is what actually has drawn me to D. And this sort of simplicity, I feel that it's not valued anymore in this community. Like you have all sorts of features and people are saying like, you know, it's like immensely helpful. Yeah, but it's like super hard to implement. And this sort of complexity breeds new complexity, and you will be at a point where you will not be able to implement anything in the compiler because you have like tons of special cases. Yeah.
Well, we can't fix alias this because every attempt at fixing it breaks legions of code. However, we can replace it. And I suggest replacing it with struct single inheritance, and then discourage people from using alias this and use the new one. And we all know how struct inheritance should work, so that shouldn't be an issue. But I'm also glad that you appreciated my adamancy about the because I can tell you from experience, nobody knows how overloading works in C++. Even people who write C++ compilers, and I implemented the damn thing, and I can't tell you how it works. Because it's pages and pages in the specs of if this, then that, if this, sort of like that. And it's just impossible. And how people deal with overloading in C++ is they try random things till it works. So that's why I was so adamant about sticking with that scheme on matching.
Okay, so now moving on, the final part with attributes. Let's just take them in order, like pure. You have functions that can be strongly pure and weakly pure, and the whole idea behind them, I think, was that maybe the compiler can do some optimizations with these, but it turns out that the compiler doesn't do any optimizations on pure, and also it was one of the reasons why the metadata immutable dip was killed, because like what happens with strong purity, right? If you have like, I don't know, immutable struct at the top level, and then that immutable struct is accessed by a strongly pure function, that's completely fine because technically you cannot modify it. But now if that struct has a mutable field in it, then you're breaking purity, right?
I can tell you what pure is good for. It's so you can write multi-threaded code and not have to worry about side effects.
Yeah, but
that's what
don't
it's
we
good
have
for.
like shared for that? So.
No.
No, pure is different because when you're doing multi-threaded code, you generally don't want to touch any kind of global state, including shared.
Yeah, since pure is completely stateless, that way you can do completely reliable parallel processing and multi-threaded code. That's its purpose. And that's why it's...
yeah, but I mean, can't you, this feels like this is something like a linter should do. Why do you have to have it in the compiler? Like
No. I'm sorry.
That's what it's for, and that's why people complain that pure is too strict. Well, it has to be strict for multi-threading. Yeah, it's a bondage and discipline thing. It has to be that way because then you can fire off a whole bunch of pure functions. They run in parallel, and you don't have to worry about any synchronization with it.
Yeah, I mean, are there people here who are doing multi-threaded application and using pure?
Yeah.
And it really does help you.
Oh.
It's honestly a critical component, especially if you're going for task-based threading. We do not want anything touching the global state at all, and ensuring that at the compilation level stops people from writing bad code effectively.
And I do some multi-threading code where pure doesn't actually work for me. Just as a usage pattern, what happens is that you're actually spinning out different sections of arrays, for example, like you get this portion, you get that portion, you get the other portion. So depending on how you define the isolation, you still have issues that the programmer has to maintain themselves.
Yeah, my point here is that pure is for the rest of us who are not using it is like a really big pain, and it adds complexity to the compiler. Like. Yeah, we're going to talk about also like what Pure did with the templatizing of runtime. So that's why I feel it's something that should be outside of the language. But yeah, what, Attila? Or yeah.
Yeah, I just want to mention one thing about Pure. There is certainly optimizations that you can do with Pure, like strong purity. The compiler doesn't do it like I think DMD doesn't do it, but LDC actually infers purity. By like if it has all the context, you can optimize it. So yeah.
There was an optimization that was done, but it turned out that it was buggish and it was just removed. So yeah.
I wrote some stuff that depends on Pure. So for SIL, the language in Symmetry, I wrote something that if you give inputs and output, it will find what function will map those inputs to that output. So for you know what you want to do, but you don't know what the function's called. But it only works with functions because you don't want hard drive.
Yeah, again.
So there's that. And secondly, there's a question of creating immutable values from pure functions. So that's really, really multi-threading as well. And the Pony language has a transition thing that they have to use to be able to construct it because it's basically, modifying something and then returning it and then basically transitioning that to immutable. And we don't need that because of pure functions.
Yeah, well, to me, it feels like Pure. Of course, I mean, any feature is going to be used at some point by someone. It's going to be found useful. But and if Pure is important for multi-threaded application, then I don't know. Maybe it should be spelled differently. But the thing is that Pure is also impeding like developing some stuff. And now people are talking like, do we want to have like the standard library to be Pure or not? It comes in a lot of design decisions where I feel that it's something which honestly it goes down to taste, right?
Modifying global state is usually not a good idea anyway, so for me, pure should be the default even.
Yeah.
You've just touched on this. you've just touched on this, Razvan, that since pure is mostly used for multi-threaded work, then why not change it or just add a strongly pure attribute? A thread-safe attribute, and then discourage people from using pure. So then you get the functionality and perhaps some other checks for thread safety, and not have to deal with pure so much. What about that?
Not a big pure user, but the fact it creeps up in identifier like pure malloc or versus just malloc is not a good sign. I think it does segment the code base around there.
Okay, so we have some experience with pure and other attribute in general being a problem. And the policy that we ended up with is that you generally don't want to use them, like even if the function is pure, unless you actually need it. So in case you are building something multi-threaded or whatever, and the pure constraint is important to you, then make a pure function. But please, like, just don't feel like annotating half of your function in your code base as pure just because they are pure. This is, in my experience at least, this is where you run into problem. It's like when you start, dutifully and diligently annotating everything, it makes the code very inflexible. Every time you refactor something, you need to change the attribute in half the code base. This is really bad, but in itself, like, if you want to use pure because you want to do parallel processing, we do that, and it's a very good idea, and it provides good value. Just like, don't feel the need to put it everywhere.
Yeah, to move on, like what I want to share is that the pain when we tried to template runtime hooks. So what happened like before when the function, so these functions in the runtime, they were used, some of them were using some global state, but because the compiler was lowering to them and then the code was linked, the compiler just said like, they're pure, it's fine. Yeah.
Regarding the mutable dip, I mean, my original draft actually came with the proposal to define more formally what pure even means in terms of what rewrites are allowed. And I don't think pure killed the mutable dip. It's more
I
like,
said it was one of the factors. That was also with shared and immutable. So
I mean, it's more that that the mutable dip was trying to solve a problem that I thought, I don't know if we need to solve this, but if we solve this, we shouldn't break the other attributes. So we need to give them a meaning that is not based on like physical memory locations. And I still think that could be done. Maybe unmutable is not the best way to go about it, but we should still define what the attributes mean, I think, in a semantic manner.
Yeah, and like going back to what I was saying, like when you started templating all of those methods, you would get like a lot of errors, like this thing is not pure, this instantiation is not pure, so we had to like work around it. So I have heard what you said. I feel you. There are use cases where pure is useful. But from my experience, I mean, I don't use it, and it's mainly a pain whenever I hit pure. Is like when I do some compiler work, and it's always like super annoying. So yeah, I guess this does not apply anymore. But now next, no throw. So again, no throw is for functions that are not supposed to throw. But it works if the exceptions are, caught. So the performance argument doesn't stand here. But I understand that if you have like some client code, then you don't want, you want to make sure that there aren't any exceptions that actually are thrown. You don't want that to happen. But still, again, this feels like something that the linter should do, right? So yeah.
Okay, I'm going to let Walter say what he's got to say, but after this, let's hold questions till the end of the talk so Razvan can get through it.
All right. The purpose of no-throw is performance optimization, because when you have RAII, resource acquisition is initialization things. If there's a potential for throwing, that means you have to build an exception handler around the destructor. And if it's no throw, it doesn't have to do that. So it's a significant performance enhancement, and that's what it's for.
Okay, so the way this works is that the regular user who doesn't know that should just put the no throw around.
If he's not throwing in exceptions, he can just put no throw on it, and then his RAII code will run faster.
Yeah, in this case, I think it makes a lot of sense, like no throw to just be implied by the compiler, to just be inferred.
It does well, inferring has its limits, okay, because any functions that function calls may throw, and the compiler needs some assurance that those aren't throwing, so it can eliminate the exception, the need to have unwinding code in there. So, and you can see this by building some code and making it no throw, not no throw, and looking at the generated code.
Okay.
Okay, questions closed.
Yeah, I mean, at NoGC, at SAFE, I feel that, they do have a usefulness, but as I said, like, if you're really interested in safety, you can just, like, go to Rust. Like, from my opinion, I've been doing it, like, I've been advertising it to students, like, memory safety, D, and so on, but, like, as time passes, I just don't feel comfortable anymore, like, saying this. Like, if safety is critical for you, I don't think that with the bugs that we have and with DIP 1000 and with everything, I'm not comfortable recommending people use D for safety. And yeah, NoGC is kind of okay, so. Yeah, my main takeaway from this is that this is probably something that the compiler should not do. This is actually the job of a linter. And the thing here is that we have all of these qualifiers, and yeah, people have all of these arguments that, it's immensely useful for me in this case and in this case and so on. But yeah, if someone comes and says, I want some code where I don't have any assignments, like, are we going to create like an attribute for that? I know it doesn't make sense. It's just for the sake of the argument, right? Maybe an alternative approach is that like you have like this tool, and it's like really easy to customize it and to just using DMD-as-a-library, and then you just do a pass on the code, and you get all of these warnings. It's really not something that the compiler should do. And yeah, as we've seen, like these attributes, they add some complexity that lead to other forms of complexity, not to mention that right now we're talking about inferring attributes for all of the functions, but we have like this problem that was also mentioned, where if you have two functions that call themselves recursively, that's like a hard problem to solve, and it's been lingering around. And now that we have them, we're having all of these discussions, like we need to support them in Phobos v3. Should we make like, I don't know, a version that throws and a version that doesn't throw, a version that is safe, a version that is trusted, and so on and so forth. And just, it just feels like we're kind of missing the bigger picture here with attributes. Now, editions. If I would have to sum up, like, what I feel about editions is like, please don't. Like, the thought that we would have to support every mistake that we've done, I don't know. I have nightmares with this. I'm terrified of how what this is going to turn the compiler into. I know it sounds good, like, yeah, we're going to have everything forever, but there are certain situations where it's really not obvious how you are going to be, you will be able to support multiple editions for the same feature. And that means that like all of that terrible stuff that I showed you with alias, this is going to be there forever, right? And on top of that, we're going to implement subtyping for structs. Like, it just, to me, that seems like it's not a maintainable thing. And I want to interject a bit here and say that deprecations are actually a good mechanism. Like, I really don't understand why we are so keen on editions and we hate deprecations so much. And I think that the interpretation is that there was this thing with DIP 1000, like the mistake we made that actually made the deprecations be a villain, is that there was a point where we were thinking, yeah, we want DIP 1000 to be the default, so maybe we're going to start issuing deprecations for code that is not using DIP 1000. but doesn't abide by the DIP 1000 rules. And that was the point where people started having like tons of deprecations and going crazy, like, oh, I'm so tired with all of these deprecations. But before that, like, yeah, we were still deprecating things, but like that was the sensible thing to do. In most of the times, we were deprecating things that were broken. And I think that that's quite okay. And I actually urge you to reconsider this, because the editions thing, I honestly hope that it's never going to be ready, because it's going to be a disaster to the code base. So I'm sorry if I'm like blowing the air out of people's balloons here, but I think we also need to consider the complexity of the code base. So for conclusions, like, complexity breeds complexity, and we really need to make sure that what is added actually brings tangible benefits. And I know that that's hard to kind of measure, right? So we don't know, but oftentimes when I read the forums, I just feel that a lot of debate is going on topics that are actually not so important, right? Whereas, and I've seen your posts, Manu, and I mostly agree with what you're proposing there. And I think that people that actually have, commercial experience in this should actually have louder voices over there. So, and still, we need to be able to reduce the compiler's complexity. And if we ever have editions, I think that like the complexity is going to blow up exponentially. That's everything.
Okay, more questions now.
Now, Razvan's been on stage for an hour for a half-hour talk, so I'm not sure if we should actually take questions. Maybe one or two? Just a couple, all right.
We have one over there.
Oh, sorry?
Okay, thank you. So how would having attribute inference on non-templated functions ease the situation? That's question number 2. And question number 1. And reflection number 2 is, I recently watched a talk at C++Con where they discussed what really safety means. And it turns out that just using Rust is, in some situations like building a graph structure, not self-evident that it's going to be easier for the developer to build it in a robust way, because they need to simulate pointers using indexes. And what you do then is you basically convert the memory null checkings to bounce checks. And if you fail that, you can get you can also get like indexes that are out of date, meaning basically simulating memory errors in a logical way.
Yeah, there's actually, I think I posted, there is this GitHub profile where you have like a collection of memory corruption programs which are done in safe Rust. So it's like, here are your memory vulnerabilities in Rust. So yeah, but to comment on the first question, I'm not saying that attribute inference is going to fix all of these problems. So in my ideal world, like all of this attributed stuff is going to be done by a linter. It's not going to be in a compiler. But with regards to the no-throw thing optimization, right? You could have the compiler infer no-throw, right? So it's being done for templated functions. So I don't see why it wouldn't be done for normal functions.
Yeah, so on no-throw, topically, I understand the optimization benefits, but for me, their benefits go beyond that. So we use no-throw and no-GC together in our code base, and while it, obviously we're doing this time-critical stuff, but no-throw also helps me reason as a developer about the code flow. I don't know how you do code coverage analysis in the face of exceptions. And no-throw provides a guarantee that I'm not just no-throw, but everybody I call is no-throw. And that is an incredibly useful attribute. So I would not like to see that discarded. Actually, yes. Actually, going back to one of the Phobos 3, there was discussion of a low level. I was very pleased to hear that it wasn't just going to be no GC, but for the 2 levels sort of approach, but that the other library would allow us to actually just get an error I would rather get an error and handle it in certain code paths because I can reason about it.
Yeah, well, I mean, my opinion here is that we are a language that has a garbage collector, and we are a language that has exceptions. So one stance, of course, it can be argued both ways, but to me, it feels a bit schizophrenic that we have all of these features, but then we offer all of other features which kind of make sure that you are not using them. Like, they should exist, but I think we should just pick one side, right? And just go like, you know, most of the people, they're going to use the GC and exceptions. And like, if you want to do like some exotic things, sure, we can have like some libraries. We can have like some, I don't know, extra checks and linters, whatever, but you are not like in what the language was designed to do. So
if you want to do that, then you're designing Go, not a systems language, right? And I love Go.
All right, we'll wrap it up with a comment from Walter here.
I know I've argued with you about stuff like this, but I'm actually very glad you're bringing this stuff up, because every once in a while we need to sit down and revisit our basic assumptions about the language and decide if they're actually working for us. So I know you've been heckled a little bit about this, but I really appreciate you bringing up these things in the talk here. It's, you know, the responses from the audience and the interest it generates, I think, is very valuable for us. So thank you.
Well, and with that, your job is done. Have a break. And in fact, it's not just his job that's done, it's everybody's job that's done. That is the last talk of our DConf this year. All right, Mike, you going to come down the front so we can do all the official wrap-up? No, Mike doesn't want to be on the stage. He's stage shy. We know Mike.
All right, we want to thank, first of all, our hosts, Symmetry, for once again bringing us here. Without you guys, we wouldn't be here in London, so thank you. And this year, we are additionally supported by WECA. They filled a gap that we had, and we really appreciate your support too, WECA. I don't think we've ever seen so many WECA faces at DConf. That was really nice. And also, I want to give a little shout out to Descartes. They've already left. I think they had an early flight to catch, but they helped out just a little bit more. And I think next year we're going to be able to bring the registration rates down if we can continue getting the support. So thanks again to Descartes.
Cool. And, you know, there's a bunch of other people in this building right now that we need to thank. For example, the ever-diligent AV team up the back. We've got Hakeem, Harry, Caroline, Tom, Tim, and Patty. We would literally not have a conference if it wasn't for everybody back there doing their jobs so well. So thanks for making it a smooth experience for everyone. And out the front, on the front desk, we've had Sarah and Eden from Brightspace just standing there doing their thing all day, every day while we're having fun. So thank you to them. Now, you might notice your laptops are fine this year. That's because we have Abdul on security. You did not mess with Abdul. And you have full bellies thanks to Easy Gourmet with their catering. So thank you to Easy Gourmet. Last but not least, thank you, Gong. You're so good. All right. So I think that's it for the wrap-ups. Thank you, Walter, again for being out here, creating the language. Still going after how many years has it been? 25 on D? 24, getting near 25. He's still going. He retired and made a language, and he's still going. Look at this guy. I think that's just about everyone now.
And the speakers. Thank you to the
All
speakers.
the speakers, I guess, sure.
And we hope to see more next year. And now,
it's time for the photo. So everybody rock up to the stage. We got to do the DConf photo. All right, standard approach here. Tall people up the back.
could I get one of you to snap the photo?
It's not often that I get to feel like the short one, but look at Robert here. All right, we don't all need to fit up on this podium either. We can fill some of the area down front. Would you like to give us one last joke to take the audience out in a, I wouldn't call it a high, just take them out on something?
I'm going to be booking me now.
I won't gong you this time. Nothing? Oh, dear. All right, let's just do the photo. Kimchi. Yeah, where's Mike? It's his fault.
Let's press the button a billion times.
All right. Well, then I guess we have this room for another half hour tonight before we got to clear out. The Beer Conf, as usual, unsponsored and a travel lodge. Otherwise, we have this place again tomorrow for the hackathon. For those that are coming, it's just pretty casual if you've never been before. You sit around, you talk through problems with people that you know, you write code if you feel like it. We did get static 4 each out of one hackathon. That was like the first hackathon, wasn't it? Yeah, Timon did that for like the first hackathon. So they do end up being productive things as well. Otherwise, I'm just filling air at this point. So for whoever leaves, see you next year.